Welcome on board of this course, a course where you will learn all about React Native. React Native is an amazing technology that allows you to build real native apps which you can ship to the Apple App Store or the Google Play Store with the help of JavaScript and the React library. You don't need to know iOS programming, so you don't need to know Swift or Objective-C, and you don't need to know Java for Android programming or Kotlin. You don't need to know anything of that. You will also not learn it here because all you'll need to build native applications, real native applications, with React Native is JavaScript and React and, well, React Native, which you're going to learn in this course. Now for this course you will need some basic JavaScript and React knowledge. That is a prerequisite, but you will learn everything about React Native, so all the building blocks that make up React Native, all the components you got there, how to style your apps and everything of that. You're going to learn that from scratch in this course. No prior React Native knowledge is required. Now in this course, we'll start at the very basics. I'll take you all the way up to a React Native Advanced Programmer where you will know the ins and outs of React Native and what makes up a React Native app. You will learn how to build your apps with components, which components are built in, how it works behind the scenes, how to style your apps, how to provide nice layouts that also work on different device sizes and different platforms. You will learn how to add navigation, how to make sure that you can have tabs or a side drawer, how your users may go forth and back in your application. You will learn how to manage state with the help of Redux also. You will learn how to tap into native device features, how to use the device camera or how to use Google Maps or get the user location. You will learn how to send data to a web server and store it there on a database and so much more. It's all in that course and you will all learn it from scratch here. Now you will not just learn all of that from scratch, you will also learn it in a practice-based approach. We'll build multiple apps in this course where we can focus on the different aspects. And by having multiple apps, you also got multiple occasions for practicing the concepts, for focusing on individual aspects, and you can therefore of course also pick the specific modules in this course which sound most interesting to you, since you have multiple entry points, if you will. Now besides all of that, there's plenty of stuff for you to follow along, to code along, to learn and to repeat, and therefore by the end of the course you will be a React Native developer capable of building your own apps, diving deeper into React Native, or of course also apply for React Native jobs. Now that's the course content, but who am I? My name is Maximilian Schwarzmüller. I'm a freelance web developer and 5-star rated instructor here on Udemy. I got multiple best-selling courses. The React Native course you're watching is the best-selling course here on Udemy. And I also got the best-selling React course, where you learn all about the React library itself, which by the way is a great preparation for this course. In this course, I teach you everything I know about React Native, all the things that make up a React Native application, and therefore you got everything you need to get started with React, React Native, and build any application you want. I'm super excited to dive into all of that together with you, and therefore let's not lose any time, let's dive right into it.
So what is React Native? Let's start with the React part, also known as React.js, which is the name of that library. And I do expect that you know what React.js is. You don't have to be an expert in React.js, but you should know what React.js is. Nonetheless, let's briefly summarize what it is so that we're on the same page. It's a JavaScript library for building user interfaces. That's the official definition. That is what React does in the end. It runs on JavaScript and it's good at building user interfaces. Typically, we use React in web development for building web apps, but it's important to understand that React itself, the library, actually makes no assumption about what we're building with it, because it's actually another library which you also use when you're building web apps with React that is responsible for rendering something onto the screen, and that's the React DOM library. Now in every React for web project you're working on, you will call React DOM render at some point of time and hand off the React app to that method to actually render something onto the screen. And that's the library that knows about the web and knows how to, well, render HTML elements and so on. React itself is platform agnostic. It's just a library that's good at building trees of components, of finding out whether something changed, if something needs to be re-rendered, of managing state, of passing data around. But it does so in an abstract way, which is why you can use React on any platform. You're not restricted to the browser, to HTML, to the web. You can use the logic React gives you anywhere. It's the React DOM part that then knows how to work with HTML and so on. And that is super important to understand because that's important when we think about React Native. React Native is a separate library, which in the end is a collection of special React components it gives you. So a collection of components you can use in your React app. And these components are special because React Native actually knows how to translate them, how to compile these components to native widgets for iOS and for Android. So React Native kind of is like React DOM. It knows how to talk to the native platform, to Android and iOS, and how to render native widgets, and it gives you a bunch of these widgets as React components so that you can build a user interface with these compilable components, so to say. Because you won't be able to use your regular divs and h1 and paragraph tags in React Native apps because there are no direct equivalents for that in native code, but I'll come back to that. Now, besides giving you these components, React Native is a bit more than that. It also gives you access to some native platform APIs. For example, it helps you use the device camera, so things like that, common tasks you would want to do in native apps. And in general, React Native gives you tools to connect JavaScript code to native platform code. Because you typically build a React Native app by mostly writing JavaScript code, or depending on the app you're building, by entirely writing JavaScript code. Now, I say mostly, at least that's a possibility, because you can also write native code for iOS or Android, and React Native gives you the tools to connect your JavaScript code to that native code, though that's a bit more advanced, and in many apps you will never need that. And therefore, React Native gives you full flexibility. It gives you a way of connecting JavaScript to native code, and it also gives you a lot of pre-built native features which are conveniently usable from inside your JavaScript code. So if you then combine React Native and the features that gives you with React.js, which knows how to update a user interface and how to control a user interface, then you get everything you need to compile a real native mobile app. And that's also what React Native gives you. It gives you everything you need to then take your JavaScript code and compile that to a real native mobile app, which you can then ship to the App Store for iOS or to the Google Play Store for Android. So you get a real native mobile app as a result in the end. So now that we know what React Native is, let's take a brief look behind the scenes. Now, as I mentioned, with React and React Native, we build an app, and our code typically looks something like this. We build normal React components, as you know it from the web, with JavaScript, because JavaScript is the language we use to build React Native apps. But in there, we use special components like view and text here. These are not your normal HTML elements because the normal HTML elements are not supported. The native platforms don't know how to use them. Therefore, you use special components given to you by React Native, for which React Native is able to translate them to instructions the native platforms do understand. So that's how this works. Now, it's important to understand that your views, so the components you're working with, therefore are in the end compiled to real native widgets, to real native elements, to real native code. Your JavaScript code, where you manage your business logic, will not be compiled, but your views will be. And that, of course, also means that you typically get a great performance when building React Native apps, because the result is a real native app where a large chunk of the code is real native code. Now, if we take a closer look at this component thing, it's important to understand that you can, of course, use React for building web apps, but that you could also build native apps for Android and iOS with native code, so without React Native, or that you can use React Native. So these are 4 different ways of building apps where, of course, React for the web won't give us a native app, but just to compare how this would be related. So if you're using React for the web, you typically work with, let's say, a div to structure your content. If you would work directly with Android, so you would build your app in Android Studio without React Native at all, You would work with an Android View, for example. That would be a widget you can use there in the user interface you're building directly with native platform features to structure your content. On iOS, that would be the UI View widget. And you don't need to memorize these terms. I just want to explain how React Native translates things for you. Because in React Native apps, you actually use the view element. Now, if you have a look at that view element, you of course see that it's very similar to the div element. It looks like a HTML tag. The difference, of course, is that it starts with a capital character, and that view is no HTML tag. The browser wouldn't know what to do with a view. But React Native does, and React Native will translate that view to the Android view or to the UI view for you. And it does that, of course, not just for this view general wrapper component, but for example, if you're fetching user input on the web, you would do that with the input element. If you would build a native Android app, you would use added text. For a native iOS app, you would use UI text field. And in React Native, there's the text input component. Again, React Native compiles that to the native widgets for you. And that's how React Native works behind the scenes. Of course, we don't care about the web in this course here, just so that you understand that there are some similarities. We use these tags, which look like HTML tags, but of course that the important difference is that these are special components compiled to native code. Now, as I already mentioned, it's important to understand that for the UI, React Native gives you special components, which are then compiled to native views. For your other logic, so if you're using Redux or if you're having any business logic, you're sending HTTP requests, you're transforming data, all your other JavaScript code is not compiled to native code, but instead it's running on a special thread hosted by React Native. So you can imagine your React Native app, which you get in the end, as a real native app, because it is one, where all the views have been compiled to native widgets, but where there is an extra mini app inside of your app, a mini JavaScript app running in there, hosted and started by React Native, so to say, which runs all your JavaScript code, and your JavaScript code can then talk to the native platform. You can picture this like this here. You have your code, your app, and you build a native app, and that's running on a native platform, and of course there you have certain platform features available, like for example using device camera. Now, as already mentioned, your code can be split into two things here, your views and your business logic, so the other JavaScript code. Now, as already mentioned multiple times, your views are compiled to native views, to native widgets for these platforms, and your code, however, is kept as JavaScript code, and you can tap into native platform features like the camera because your JavaScript code runs in a special virtual machine in the end, spun up and hosted by React Native inside of your app. So the right part here is all inside of our native app, which we ship to the app stores. And that JavaScript core, this JavaScript virtual machine, knows how to talk to the native platform features, so to the operating system your app is running on in the end, through a special bridge, you could say. And that bridge and that virtual machine, that's all automatically provided by React Native. You don't have to care about this. All you do is you write your React Native app with JavaScript and with these special components. And that's all you need to know for now. This is how a React Native app works behind the scenes. And I find it important to be aware of this because it takes some of the magic away in a positive sense, because you understand what you're actually writing and what will happen with your code and how this code ends up in a native app. And of course, you also understand that you have a real native app therefore in the end. Not all your code is compiled, that would be pretty impossible, but your views are compiled. And of course, the views, so the part the user sees, is the most important part when it comes to performance for an app, because re-rendering the UI and all of that, that's typically the performance intensive part. And therefore, it's very good that this is compiled. That's one of the huge strengths of React Native. So now that we have an idea of what React Native is, we can get started with React Native. And I'd say let's get started by building our first little React Native app, or by getting our first React Native app up and running. So we want to create a new React Native app, and as it turns out, we actually got two options for that. If you search for React Native, you'll find the official page. And on that official page, if you click on Get Started, you actually have two options here. You have the Expo CLI Quick Start and the React Native CLI Quick Start. Now, what's the difference and which approach should you use and why, and what will we use in this course? So we can use the Expo CLI, the Expo tool, for generating and managing our React Native app, or we use the React Native CLI. Now, if you first have that choice, you would probably go for the React Native CLI because you want to build a React Native app after all, right? Well, let's have a look at what Expo is. It's a third-party service which is completely free to use. You don't need to sign up to get started, and you don't have to pay to build an app which you can publish to the app stores. So it's really free to use. What Expo gives you is kind of a managed app development workflow. It takes a lot of the complexity away from you because building React Native apps can be very complex, especially when it comes to integrating certain native device features like accessing the camera. And Expo simply gives you a lot of convenience there. It makes development of React Native apps a breeze and so much easier. The downside is that you're limited to the Expo ecosystem because Expo in the end is like a wrapper, you could say, around your app. A thin extra layer between your app and the native raw React Native experience. And you still get a native app in the end, and you still use React Native under the hood. That's all happening. But Expo abstracts away some of the complexity, which also means it, of course, removes some of the fine-grained control you would normally have if you build a raw React Native app. Because if we have a look at that other workflow, the React Native CLI, that's in the end managed by the React Native team or parts of the React Native community. And there you have a bare bone development setup, which means you get a native app, you need to install Android Studio, you need to install Xcode to build that app, and you need to configure and manage a lot on your own. As soon as you start adding certain native device features, like let's say as soon as you want to use the device camera, you'll have to bring in third-party packages where the setup process can be quite complex. And therefore, this can be more cumbersome. You have pretty much no convenience or utility features to tap into. But of course, the advantage would be that you have full control. You can control every tiny piece. You can easily write your own native Android and iOS code and connect this to your JavaScript code. That's not really possible with Expo. So if you are a super advanced developer and you already know you'll be building a very complex app where you need to do a lot of manual workarounds, a lot of fine-grained configuration, then you definitely want the full bare bone experience on the right. If you're getting started or if you're building a normal app, then the Expo CLI will very likely give you everything you need. It gives you wrappers for the most common native device features you need, like using the camera, like using maps. That's all made super simple. And if you ever get to a point where you find out, oh, I need more control, then you can always also switch from the Expo workflow to the native workflow. You can eject, and then you have the full flexibility. Therefore, nothing speaks against getting started with Expo. You can always switch to the other experience if you need to. And we'll use Expo in this course because it's simpler, because it gives you everything you need for most apps, because it's so much more convenient to work with it, and because you can always switch. Now, later down in the course, I will also give you an introduction to the more bare bone workflow and what that would mean for you. But for the majority of the course, we'll work with Expo. Behind the scenes, this Expo tool works such that you have your native device or your simulator, so your iPhone or your Android phone, and you have your app, your React Native app you'll be writing, so your JavaScript code where you write your React Native app. Now, on your native device or on the simulator, you will install an extra app from the App Store, the Expo Client app, and we'll do that together in the next lecture. Now, your app can then be loaded into that client app, which is this extra wrapper, to see it there, to run it there, to test it there. And that's, of course, great for development. You can also publish your app as Expo app so that other people who have the Expo client installed can easily run your app. They don't even need to install it from the Google Play Store or the Apple App Store. But of course, typically you want to build an app which you can publish to these app stores, and no worries, that's possible with Expo too. That extra client app which you have, which wraps your app, is great for development because it speeds up the entire development workflow. But if you want a standalone app, so an app that is not relying on that Expo client, which most of your potential users probably won't have installed, Well, then Expo also allows you to build and publish standalone apps. So apps that do not rely on the Expo client being installed. So therefore, with Expo, you can build normal apps which are distributed to the normal app stores standalone, where your users don't need any special app installed, but you have that extra convenience during development, which is great. And as I mentioned before, if you would need to, you can always switch or eject, as it's called, to the non-Expo development flow as well. So that was a lot of introduction to React Native and Expo, but I find it important that you understand what you're working with before you get started. Now with that, it's time to get started though, and for this, visit expo.io. There you can click on Get Started and you find the starting steps here. Now you don't really need that first step. We can jump right into step number 2, which is that you need Node.js. Now you need Node.js, which is a JavaScript runtime that allows you, for example, to build server-side apps with JavaScript. You don't need that because we're about to write any Node.js code in this course. It's not a Node course, no worries. You don't need to know Node.js. But it's a package which allows us to run JavaScript on our machine, and for example the Expo client behind the scenes also runs on JavaScript. It's totally not related to React Native, that's just for this tool to work correctly. Also for this command to install the tool, npm, that's the Node package manager, and that's also made available by Node.js. So the first step is that you visit nodejs.org and there download the latest version, in my case 12.6, from there to get started. And whatever your latest version is, when you're viewing that, simply download that version, install it. It gives you a normal installer. You can simply walk through by clicking through all these steps there, nothing too fancy. It's available for Mac OS and Windows and Linux. So simply download it here, walk through the installer, and once it is installed, you can proceed to this third step here. So with Node.js installed, let's copy that command here and then open your normal terminal or on Windows your command prompt and paste that command in here. Now on Mac and Linux, you might need to add a sudo in front of this. On Windows, this will not be required to get the right permissions. So here I'll enter it, then you might be prompted for your password. Simply enter it if you are. And now this will install the Expo CLI, which is this tool that helps us create and manage React Native projects with the help of Expo globally on your machine, so that you can use it from anywhere on your machine, so from anywhere in your terminal. So let's wait for this installation to finish. You can ignore any warnings you might be getting in between, and I'll be back once this installation finished. You can also ignore such in-between errors here, by the way, as long as this overall doesn't crash with an error, but finishes with a message like this one in the end, you were successful. So with this, we got Expo CLI installed. The next step is to create our project, so step number 4 here. We do this by running expo init and then any project name of your choice. And for that, first of all, make sure that you use the cd command to navigate into the folder here on your machine where you want to create that project. So I did that here. I'm in that folder, and now I can run expo init, and I'll name this rn first app because it's our first React Native app here after all. Simply hit enter. That name, of course, is totally up to you, which you have here. And this will now create a new folder in the place where you ran this command and set up our React Native app there using Expo. Now you probably are asked which template you want to use, and there you can go with the blank template for now. Make sure you don't choose bare minimum, because that would be a setup without the Expo environment with all the convenience features. So definitely go with blank here. Now next, you'll probably be asked to enter a name for your app, and I'll just enter rn first app here. That's in the end the name, which is displayed in the task switcher of your app on the home screen and so on. You can leave the slug as it is and simply hit enter again. Now I'm also using Yarn on my machine, which is an alternative to NPM. You might not be asked whether you want to use Yarn, which is totally fine. I will also choose no here to use NPM. And therefore now this will go ahead, create this project folder, install all required dependencies in there, like React and React Native, and give us a React Native project which we can use to build a native app. So let's wait for this to finish now. Now once it did finish, you see the next instructions here. you can navigate into that newly created folder with the cd command, and then in there simply run npm start. npm start will now start up the Expo development tool, the Expo Dev Tools, and a new tab should open up in your browser. Here is that tab which did open. If you're seeing any issues here, you can ignore that for now. This here is the Expo development tool, or the Expo Dev Tools as it's called. It's a window which allows you to run your app on different connected devices or simulators, and it allows you to generally manage parts of your app. You see some output from your app here, some warnings you might be getting, and this is a very convenient window for managing your app and for running your app. Now also make sure that here in the terminal where you ran npm start, you leave that process running. You might see that it didn't finish. You don't see that input line again where you can enter commands. Instead here, you can't type, or you can press some of the shortcuts you see here, but you can't type new commands. You can always quit this process by hitting Ctrl and C simultaneously, but you should leave this process up and running for as long as you're working on your project. And if you're then done for the day, you can quit it and restart it on the next day. Because this process will also watch your code, and whenever you change something in your code and you save that change, it will automatically save this and publish it to your connected device. But speaking of that, let's connect the device. And for that, the easiest way of getting started is to use your iPhone or Android phone which you own. So in my case, it's an iPhone here. And here's my real phone, and I'm in the App Store. Now it's in German because I have a German phone, but this is the normal App Store. Now in there, you can go to the search area and search for Expo. Now once you did that, you should find that Expo client here, and you can simply download that to your device. It's free to use. Simply install it onto your device and wait for this installation to finish, of course. And once this is finished, you can open this. And now with the Expo app installed, you don't need to sign up here. Instead, on Android, you should be able to scan that barcode right from inside your Expo app. On iOS, simply open up the camera app, and then you can go also to the DevTools here, and you see that barcode here. Simply hold your camera onto that on iOS, or the Expo app scanner here on Android. And you should be prompted whether you want to open that app in Expo then. Simply hit open there, and now this should open your app here in the Expo client which you installed. Again, without signing up, just by holding your iPhone camera over that barcode, or on Android by doing that from directly inside the Expo app where you will have that option to do so. So now this will build the JavaScript bundle as you see here at the bottom, or put in other words, this will now take your app and compile it basically and prepare it, and then load it here over Expo's servers into your app. And you can simply hit got it here on the first screen. And then this is your starting React Native app. And now let's actually view the code for this and see how we can change something in the code to see something different here on this screen. To view and edit our code, we need an editor. And I recommend using Visual Studio Code, which is a free-to-use, very powerful IDE, which is great for JavaScript development, which is what we're doing here at the end. You can get it from code.visualstudio.com. There you find versions for Mac, Windows, and Linux. Simply download the one for your operating system and walk through the installer this gives you. Once you did install it, open up Visual Studio Code, and in there open your project by going to File, Open, and then simply pick your project, in my case, RN First App. Click Open here, and this will now open up the project here in Visual Studio Code. Now, my Visual Studio Code looks the way it does look here because I have a special theme enabled, which you can change under Preferences, Color Theme, and there I'm using the Dark Plus theme, so if you want to have the same look, you can use that. And I also installed a special extension, which you can do under View, Extensions. There I got the Material Icon theme installed. This one here, which is totally optional, but you can install it from there as well, and thereafter go back to View Explorer to see your files again, so that you get the same file icons as I have here. Again, that's totally optional. And with that out of the way, this is our React Native app managed by Expo. Now let me quickly walk you through what we have here, and then show you what you can change in code to change something in your app. Now, we have a couple of folders and files here. The .expo folder just holds some configuration for Expo. You don't need to touch this. The assets folder, that holds some images in this case, like the icon of your app and the splash screen image, and we'll dive into how you can customize this towards the end of the course, and we'll use other assets like images in general throughout this course, of course. The Node Modules folder holds all the dependencies of this project. That's, for example, React and React Native, but also dependencies of dependencies. And this folder is managed automatically for you, so you don't need to touch this, and you shouldn't touch it indeed. Gitignore is a file that helps us with Git, which is a source code management system or a source code management tool. And you don't need to use Git. If you do, you probably know what Gitignore does. And if you don't know what Git is, after this lecture, you'll find a brief introduction to it or some resources that help you get started with it, but you don't need to use Git to work with React Native. Watchman config, that's something you can ignore. As you see, it's empty here. It's a tool used behind the scenes by Expo in the end. And the app.js file then is the file which holds the code that is responsible for rendering what we see here on the screen. We'll dive into this in a second. App.json holds some configuration for our React Native app powered by Expo, and we'll dive into this throughout this course as well. For now, let's ignore it. Babel config configures how the JavaScript code is optimized and compiled. You can leave the defaults here as well. And the package.json file manages your dependencies. And there you see that you're using Expo, but also React DOM, because Expo actually also supports building React apps for web. But then also React Native here, and well, React Native web, because again, Expo gives you the option of also building web apps with the help of React Native. It's not something we'll focus on in this course though. So that's the setup we have here. The important file for us at the moment is the app.js file, because that's in the end responsible for getting something onto the screen. Now, the exact file content you are seeing here in your app.js file could change over time though. This starting project, which gets generated automatically, simply sometimes is changed. That does of course not affect what I explain here or this course. It does not mean that anything is outdated or anything like that. It's just a different starting project. And if you want to follow along with exactly the same one I got, you find it attached, so you can also use that. But of course, you could also continue with yours if it looks slightly different, because as I mentioned, it's just the starting project you got. React Native, of course, still works the same as I explained it here, and therefore you can absolutely follow along with that and edit your app.js file just the way I edited it. And in there we see we do import React, just as we would do it in a React web app. We need to import React because here you can also see we're using JSX, which is this special JavaScript syntax that looks like HTML, but in the end is just JavaScript. In case you never saw this, definitely dive into a React app or React tutorial first. I do expect that you know how React generally works. We also have another import here, and that's the React Native import, where we import style sheet, text, and view from there. Now, these are these special components and features I was talking about earlier. Text and view are components provided by React Native that are compiled to native platform widgets. And style sheet is an extra feature provided by React Native that helps you with styling. Now then, here we have a normal React component as we would build it in a React for web app too. We're having a functional component here, and with the help of React hooks, we can work with functional components only, as you probably know. And this functional component returns some JSX code that is rendered onto the screen. And here we're using the view widget or the view component provided by React Native and the text component. And the view component is like a div. It's a good wrapper, also good for applying some styles for some containers. And the text is then used for, well, outputting some text, which you put between its opening and closing tags. And down here we have some styles defined. React Native does not use CSS, but it uses a styling syntax that is based on CSS or follows similar naming conventions, but we'll dive deeper into how to style your React Native apps throughout this course, of course. So with that, let's change what we see on the screen, and let's actually add a button here. Now, the good thing is we can import a button from React Native. That's another core component provided by React Native. So we can add this import and then use a button down there. However, we don't use it with the opening and closing tag, but as a self-closing element. And then we can add a title prop here to set the text we see on the button. For example, change text. Now when we tap this button, we might want to change this text here. And for this, we need to manage some state here because I want to change some data which should lead to this component being re-rendered. And for this, you need state. Now, prior to React 16.8, which is supported here though, you would have to convert this to a class-based component to use state. Since React 16.8, we can use React hooks. And in case you don't know what hooks are, you should definitely dive into the basics of hooks. Attached, you'll find resources that get you started with that. Hooks are imported from React, and here we need to use state hook, which allows us to manage state in a functional component. With that, we can use that hook by calling use state here and giving it a default value, which could be this text here. Let's cut it from down there and add it here as a string. And then here we can use array destructuring to get our output text and get a function to change or reset or overwrite this output text. And that's just how the use state hook works. It gives you an array with exactly two elements, where the first element is your current state snapshot, so either our starting state or thereafter for subsequent re-render cycles, whatever we set our state to. And the second is a function that allows you to set your state to a new value. And calling that function will re-render the entire component, and output text will then refer to the latest new state. So here, between text, I want to output text, and upon a press of this button, I want to change this. So on the button, we can therefore register on press, which is basically the equivalent to on click, which we would have in the web. Here it's on press. And then we need to bind this to a function, for example, to an anonymous inline function here with this syntax, where we call set output text, and we set this to the text changed. So this will call this function here, override our state, therefore re-render this component. This will be updated in the next render cycle, and therefore, since we output text down there, this will change. If we now save all of that, the cool thing is, your app, which you should still have opened on your phone, should have automatically reloaded. You don't need to restart it. You don't need to scan this code here again. Just by changing the code and saving this file, it should automatically reload here. And now if we now tap change text here, you see the text changed. And that's your first React Native app doing its job, powered by Expo. But again, you can build and publish this as a standalone app, and we'll do that by the end of the course. And therefore, this is an amazing way of getting started. And React Native development can be as easy as that. Now with that, let's finish up this first module before we then dive way deeper into React Native and into writing React Native code from the second course module on. Getting started with React Native apps can be really hard work. It wasn't that hard with Expo, and indeed generally Expo makes working with React Native pretty simple and fun. But it's important to understand that React Native is not about writing JavaScript once and running it everywhere. It's instead about learning React Native once and then write code that is flexible regarding the platform it's running on. For example, and you will see that throughout the course, there aren't that many components React Native ships with that would automatically adapt the way they look to the underlying platform. You as a developer instead have to find out on which platform your code is running and then adjust your styles to that platform to get a look that fits the platform, or maybe even adjust your logic to that platform. The same for orientation or device size changes. You need to write code that is flexible. You will learn all about that in this course, but you will see that writing React Native code is not about writing code once, but instead you will have to add some if checks to find out on which platform you're running to adjust the look and feel of your app based on the platform and device size your app runs on. So to sum it up, you have no or very little cross-platform styling of components. Most components that are built into React Native don't come with a lot of styling attached to them. You have to take care about styling instead. And you only have a basic set of pre-built components anyways. Don't expect a vast amount of pre-built components. If you worked with other alternatives like Flutter or Ionic, you're used to having a bunch of components which are pre-styled and give you a lot of awesome functionality out of the box. React Native is much more bare bone. You got some basic components which you need, but then all components that would be a bit more complex are components you'll have to build on your own based on these primitives you're given. And indeed, you will see these primitives you're getting are actually all you need. But again, we're back to you will need to combine them manually, install them manually. And that's something other alternatives sometimes do for you. For React Native, you have to do it on your own. Also, as I just mentioned, for creating responsive designs where your app looks good on different device sizes and different device orientations, you don't really have tools that help you with that. You will have to write code that is flexible, that checks the available device size, and that then automatically adjusts. So there's a lot of manual work to be done by you, as you can tell. But that also gives you a lot of power, and in this course you will get all the knowledge you need to master this and build truly amazing React Native applications. I also don't want to hide that React Native is a fast-moving target. We got new versions being published almost every month. Breaking changes do happen, and of course I'll do my very best to keep this course updated to let you know about changes and how to adjust your code. But sometimes you just have to go back to an app you built 6 months ago and you have to change something there because something changed in the latest version of React Native, and in order to continue working on your app you need to change something in the code which used to work before. That's normal, that will happen. Not all the time, not every month, but it will happen. Also in React Native, you typically have a high dependency on third-party packages. Now the good thing is when working with Expo, that's only partly true because Expo already itself is such a wrapper with a lot of cool features built in. Therefore, you have a high dependency on Expo when working with that, but you don't have to find dozens of other third-party packages to access the camera, to work with Bluetooth, or anything like that. If you're building a bare-bone React Native app, that would be different. There, only a basic set of features is built right into React Native, and for most things that you want to add to your native app, you would have to reach out to other community-managed packages to make them work. And even with Expo, we'll need a couple of third-party packages to have everything we want. And that is something you have that dependency, and that of course means that if those packages change or aren't maintained anymore, you have to find alternatives, or you have to update your code. So that's something you just also have to be aware of. And React Native simply also has some bugs. Not crucial ones. You can build basically any app you want with React Native, but sometimes things just don't work as you would expect them to work, and you need to get creative, find workarounds, and so on. And in this course, I will also show you some of the strange things React Native has, but in general, when building React Native apps, you have to be willing to stay updated, to use Google, to dive into issue discussions, and to simply, well, try things out. With Expo, you have a pretty smooth development experience, but still, the road can be bumpy from time to time. Now, that might all sound pretty bad, so shouldn't you learn React Native then? Well, let's have a look at the alternatives. Of course, one alternative always is that you build real native apps with the Android framework for Java or Kotlin, or with Swift Objective-C for iOS. You can do that, but of course the downside is you have to learn these languages, and the huge advantage of working in one project and sharing a lot of code will be totally lost. In React Native apps, sure, you will probably need to adjust your code to the platform you're running on from time to time, but the vast majority of your code base can be shared and can be reused without any adjustments. If you're using the native platform languages, then you definitely have to work in two totally different projects and you won't be able to reuse a lot of code. Alternative 2 is that you build a progressive web app. That's a normal web app that utilizes some features that make it look and feel like a mobile app, but it's not distributed through the app stores, and it relies on users using a browser that supports the features you're using, and if that's not the case, your app doesn't run that well. The third alternative is that you use Ionic or a similar solution. Ionic is a tool or a framework that allows you to build real native apps which you distribute through the app stores with web technologies. In the end, Ionic takes a normal web app and wraps it into a native app. So it doesn't compile anything, it just wraps it. And that's a nice approach. I like Ionic actually, and it can be perfect for a lot of apps. But of course, a possible downside is that performance can be worse because you just have a wrapped web app. You have no compiled native app. And that's something you do have with React Native, of course. And since we overall got tools and we can acquire knowledge that helps us overcome the challenges React Native sometimes poses, React Native is an awesome way of building native apps. You can share code, you get great performance, you can distribute it through the app stores. That's pretty nice. Now, one side note, you also got alternatives like Flutter or NativeScript. Those alternatives follow a similar approach as React Native does. You get a compiled app there. They simply use different programming languages, different frameworks. And attached, you find a link to a comparison video where I compare all these alternatives in case you're interested in a little bit of a deeper dive into that topic there. So what are the requirements for you to complete this course and to build native mobile apps with React Native? You need JavaScript and React knowledge. You don't need to be an expert, but basic knowledge is required. You don't need to know Android, Java, Swift, or Objective-C or Kotlin. You don't need to know anything of that. Will not write code in those languages. Now, regarding the hardware and software you have, it depends on what you want to build. If you want to build an iOS app, which you distribute through the App Store, then on Windows that's not possible locally, but with the help of Expo, you can actually build such an app there remotely, which means it's getting built on Expo's servers and you can also distribute it to the App Store with the help of Expo. But it's a bit more difficult, and if you're not using Expo, you absolutely can't build iOS apps on Windows. That's simply a restriction imposed by Apple. Same is true for Linux, by the way. You can't build iOS apps there either. Android apps can be built on Windows locally with or without Expo, and it's the same for macOS and all platforms. You can build iOS and Android apps on macOS with or without Expo without problems. So it doesn't look too bad, I'd say. No real deal breakers in here. With that, let's dive deeper into React Native and learn all about it. Now, we tested the application on a real device, which is of course pretty nice and also amazing to see it run there. But for development, I will actually use a simulator, which is a virtual device running on my machine, simply so that I don't constantly have to test the app on my real device. I like having it here. Also makes it easier for recording. You probably also want to test the app on a simulator at some point. For example, because you probably only own either Android or an iOS device, and you also want to test and see your app on the respective other platform. Or you have both devices, you have an iPhone, you have an Android phone, but you also want to test your app on an older iPhone, on a smaller Android device. And with simulators and emulators, you can launch different types of devices and test your app there. To get started with that, go to that guides section down there and click on up and running. Doesn't really matter where you click though, in the end you just need to get to docs.expo.io, and there in the managed workflow you can click on iOS Simulator or Android Studio Emulator. And there you'll learn how to install Android Studio and then launch a virtual device, or install Xcode, which is Apple's development environment, and launch an iOS simulator. Important, an iOS simulator can only be launched on macOS devices because Xcode, a tool which you absolutely need for that, is not available on Windows or Linux. So you can't run an iOS simulator on Windows or Linux. You can run an Android Studio emulator there though. On macOS you can run both. So let's now install these things, and let's start with the Android Studio emulator. For this you first of all need to install Android Studio. For this you can of course simply Google for Android Studio and you should find developer.android.com/studio. Simply click on there and then there choose download Android Studio and agree to these terms here. Now this will open up that download window and now download Android Studio, which is quite large and therefore this download can take a while. Now I'll be back once this download is finished to then continue with the setup. So the download finished for me, and with that I'm opening this up. Now I'm on Mac here, but also on Windows you simply, double click on that downloaded file to start the installer, and the installer will open up and walk you through a couple of steps. Now in that installer, you can simply leave all the default settings. Now with Android Studio installed and the installation finished, we'll launch it in a second. Now before I launch it together with you and we walk through this first step, make sure you have these settings down there on macOS and Linux configured correctly. So on Windows, you should need to do that, but on macOS and Linux, make sure you follow these 2 steps which you find in the official docs so that everything works correctly. Now with that, let's launch Android Studio. Once you start it, you should see a screen that looks something like this. There, you can click on Configure and then choose the SDK Manager. Now here in the SDK Manager, make sure that you have one of the latest SDKs installed. Now, typically you have the topmost SDK, which is still in beta. So in my case, that's the Android API level 29 Q, which has no official name yet. And the latest stable version, in my case, Pi, is the one you should install, typically the second item here in that list. So the first version, which has a real name, so to say, in this case Pi, make sure that this is installed simply by checking it here. And once you checked it, you can click Apply down there, and this will automatically download and install it. Besides having an SDK installed, make sure that in the SDK tools, you have the Android emulator installed here. So simply click on this here, add a checkmark here, and the SDK platform tools and the SDK tools, that all these 3 are checked here. Also, check the Intel x86 emulator accelerator here and the Google Play services. With all of that checked, click Apply, and now again this will prompt you and then start downloads of all these items and install them into your Android setup here. And you need all these things installed to develop Android applications. So let's wait for this download and installation to finish here. And with that finished, you're done here. You can close that. And the next step, still in that Android Studio window here, is that you click on Configure AVD Manager. This is the manager that allows you to create and launch virtual devices. You see, I got a couple of devices already. You might have none. You can always create a new one in the bottom left corner by clicking on Create Virtual Device. And then choose a phone here. And you can choose any image you want here to create different devices of different sizes. I would recommend going with one that has the Play Store installed. That can help with testing certain features, which we might need later. But in general, you can pick any image here, which you want. I'll go with the Pixel 2 here. Click Next. Then choose an Android version you want to use on that device. And there I would use the latest stable one. So not the beta one, not Q in my case, but the latest stable one. You might need to download it first, this image. This is independent from the SDKs you installed a second ago. These are device images. So make sure you download the latest stable one and select it thereafter. Click on Next. You can leave the default settings here. You could dive into advanced settings if you really know what you're doing, but otherwise you can leave the defaults and click Finish. And this will now create a new emulator, in my case this one here, and you can launch the emulator by clicking that green play button here. And this will now start that emulator here, which is now booting up here. And once it is booted up, you can run your Expo app, your React Native app on this emulator. So let's wait for this to finish and let me then show you how to launch your Expo app on that emulator. So the emulator finished up booting, and now you can launch your app on this emulator simply by going to your project where you might have your process still running. If you quit it, you can simply restart npm start in your React Native Expo project. So that's what I'm doing here. And it's again starting the Expo DevTools in the browser here. And now here, where we previously scanned this QR code, you can press Run on Android device or emulator. And if you have an emulator up and running, it will automatically run your app there. Or in your terminal here, where you have this running npm start process, you can press A to also launch your app on the emulator. That's what I just did. This will now install the Expo client on the emulator automatically, so you don't need to install or manually install the Expo client there. It's done for you. And once it's done with that, it builds your app and runs it on that Android device. So let's wait for this to finish. Here it is. Here it's booting up. And yes, click OK here. You're prompted whether you want to allow displaying this app the first time you launch this. turn this on here, then go back, go to the app drawer here or to the task manager and go back into your app here. And now here's your Expo app launching. It's again building that JavaScript bundle at the bottom. And once it's done, it will launch your Expo app here. And only that first build takes quite long. Subsequent rebuilds and hot reloads, as you saw, are pretty fast. So let's wait for this build to finish. And now it is finishing up here. And here we see our app. By the way, this is nice. We saw it on the iPhone before, at least here in the videos. Now here it's running on Android, and the button is one of the very few components React Native offers which does automatically adjust its look to the platform. So that's pretty sweet. And we have the same functionality as before. And this allows us to test this not only on a real device, but also on a simulator. And there you can simulate any Android device you want, which is of course pretty useful. So that's the app running on an Android simulator. And throughout this course, I will always also show how this runs and works on an Android emulator. Now let's next dive into running this on iOS. So we installed Android Studio and launched the app here on an Android emulator. Now let's do the same on iOS. And this, as I mentioned before, only works on macOS. You can't do this on Windows, unfortunately. The first step there is that you install Xcode, and you do that from inside your App Store, so the App Store on your Mac. There you can simply search for Xcode and then install Xcode. I already got it installed, but simply install it from there. These are the Apple developer tools. You can only install them on a Mac, and you should do so there. With that installed, make sure you install the Xcode command line tools by simply launching Xcode. And there, without necessarily opening a project, you don't have to do that, going to Xcode preferences in the top left corner, and then make sure you got command line tools installed here by selecting the most recent entry you have here under command line tools. That is already all. You can now launch a simulator by going to Xcode and then open developer tool simulator here. This will now launch up an iOS simulator. Here it is booting up, and for me it picked the iPhone X here. You can change that simulator by clicking on it and then going to hardware here, device, and then selecting iOS, and you can pick different phones. And if you choose a different one here, it will launch a new emulator with that different configuration. And here I'll just go with this iPhone XS simulator. I closed all simulators and then restarted it, and then it automatically picks the last one you chose here. And now let's wait for this to boot up before we can run our React Native Expo app there. Here it is running. And now again, go back to your npm start process, which should be up and running. And in there, you can hit I to launch this project on an iOS simulator. Alternatively, you can always go to the Expo DevTools in that browser tab and click Run on iOS Simulator there. That would work as well. Here you also see some log where it tells you that it's connecting and so on. So now here we're asked where we want to open this in Expo, and the answer is yes. Just as on Android, it automatically installed the Expo app, so you don't need to do that manually. It does it for you. And then it launches this app and launches your project in that app. So let's again wait for that to finish. Click Got It here, and here's the app, and just as on the real device, we can click Change Text to change the text. So this is the app now running on simulators. This is the setup I'll use for the course so that I can show this app on different devices here on the screen. You can test it on simulators as well. You can test it on real native devices. Before you ever publish an app, you should definitely also test it on real devices though. Otherwise you won't know how your app behaves there. So using simulators only is not an option, but for development it's of course great. So what's in this course now? What will you learn in this course? We're almost done getting started, and therefore with this basic module where, well, we set everything up and you get a rough idea of what React Native is and how it works. After this, we'll of course have a very important module where we dive into the React Native basics. In this module, you'll learn all the core fundamentals you need to know about React Native, how these apps work, how you work with React Native components, how you build your own components, how you make that all work as a native app, which you can test on your emulators or real devices. All of that is in this super important module. Now, after all these core basics, which are really important, we'll also have a look at debugging. How can you track down errors? Which tools are there to help you with debugging? These are all questions we'll tackle in the debugging module. Now, thereafter, we'll dive back into the basics, but into the advanced basics, if you want to call it like this. We'll have a look at how you build real apps, how you style apps, which different options you have there, how you work with all these components that are baked into React Native and with your own components that you can build based on those, how you lay out your apps. So here, we'll really bring together many concepts and compose that all in a more realistic app, which does more useful things, and where we'll need to tackle certain problems you have to tackle in real apps. So that's another core module for you to learn how React Native works and how React Native apps are built. Now, once we completed this module, we'll have a solid understanding of all these fundamentals, but there will be one problem. Up to this point, the apps we built thus far are not really flexible, they're not really adapting to different screen sizes, and there might be differences between iOS or Android regarding how apps should look like or how certain things should behave, which we don't really cater for. Therefore, we'll then have a module where we dive into how to build responsive and adaptive apps. So how you make sure that your apps look great and work the way they should work on different devices, different device sizes, and also on different platforms, so on Android and iOS. And how you can use one project and one code base to still fine-tune your app to different platforms in certain areas. Now, after all of that, you'll have very solid fundamentals, but we'll also only have worked on apps that have mostly one screen. Now, in most apps, you have tabs, you have a side drawer, you can navigate forth and back between different pages, and you have nice transitions and animations for these navigation actions. And therefore, we'll have a whole module dedicated to navigation and how you can build navigation into your app, how you can provide beautiful transitions, how you can add tabs, different kinds of tabs to your application, and all these core techniques and things that you need in most applications you're going to build. Now, by then, we'll also have a feeling for a problem that managing state, managing data in our application can be tricky as our application grows. And therefore, we'll then have a whole module where we dive into how to manage state with the help of Redux and how you can pass data around in your application. After all of that, it's really time to practice, and therefore, we'll have a whole module where we build a brand new application from scratch, where we incorporate all the things we learned thus far. That's a module where you can practice this on your own, or you just follow along with me, or you practice first and then compare your solution to mine. So it's a big practice module where all these core things we learned about come together and can be seen in practice. Now, after that, we'll take that same app and enhance it, for example, by handling user input in a better way, by validating it, by showing error messages, by making sure that our app has certain data criteria that needs to be fulfilled before we can continue, and so on. So that's another core module because, of course, in many applications, you'll need to gather user input. Now, thereafter, we'll also leave our application, in a certain sense, because we'll learn how to send data to a server and store it on that server in a database. Of course, that's another crucial task because not all data lives on your device. Instead, there is some data that needs to be shared with other users, for example, or that should be backed up, or that should be available even if users reinstall your app. And for all of that, that data needs to be stored away from your app. It needs to be stored on a server, it needs to be stored in a database, and that's exactly what we'll have a look at in this HTTP requests module. Now, speaking of servers and so on, many applications also need user authentication. You need to be able to sign users up and log them in, log them out, manage their session, and that's exactly what we'll have a detailed look at in the user authentication section, another core section with another core feature that you need in many applications, and we'll have a detailed look at all of that in this module. After this module, you will have a lot of core building blocks you need for apps you typically build, but one thing will be missing, and that's how you tap into native device features, how you can use the device camera, how you can get the user location, or how you can use Google Maps. And that's what we'll have a look at in this native device features module. You will learn how you can get the user location, how you can use it, how you can store it on an on-device SQLite database. All that fun stuff is in this module, and therefore this is another crucial module, of course. Now thereafter, I'll dive into different ways of building your React Native app, because for the majority of this course, we actually use Expo, the tool we got started with in this first course module, because it makes building React Native apps such a breeze. It's such fun, it's easier, and therefore definitely my recommended approach. But you might not always want to use it. And in this module, I explain when you might not want to use it and how you then build apps without it. Though I can already have a little spoiler at this point, for most applications, the vast majority, Expo is an amazing tool, and also important, really important, all what you'll learn in this course can be applied to Expo and non-Expo apps. And I make that clear in this different workflows module as well. And I show how non-Expo works work and how you write code for them. And surprise, it's exactly the same as you learn in the rest of the course, basically. Now, thereafter, we of course aren't really there to just build an app and then throw it away. Instead, you typically want to publish it. So I'll have a whole module focusing on how you publish apps, and we'll not just have a look at how you build it and how you then get it into the App Store. We also will have a look at over-the-air updates, for example, how you can automatically update the installed apps without forcing your users to re-download an updated version, which is really amazing. So that's also covered in this module. A lot of content. All these modules, of course, are extremely detailed. You'll get tons of knowledge about React Native, and by the end of the course, you'll be able to build amazing React Native applications. Now you know what's in the course. I also want to make sure that you're getting the most out of the course, and therefore here are my hints at how you can or how you should work with this course to ensure that you're getting the most out of it. Now, the obvious thing is that you should watch the videos. It's a video-on-demand course. It's fully built to, well, have all these videos for you to get all the knowledge. That's how knowledge is transported in this course. Now, be aware that you can adjust the speed of these videos. You have the playback controls here, where you can play videos back in a faster or slower way in case I'm going too fast or I'm going too slow. I do my best to find the best balance for all users, but of course you might have a different knowledge of React or even React Native, and therefore take advantage of these speed controls. Also, of course, pause the videos and rewind if something isn't clear. And of course, my recommendation also would be that you code along. And therefore, you might need to pause videos occasionally so that you can catch up or try something out on your own. And that's really how you get the most out of it, by coding along and trying things on your own as well. So definitely also pause videos, try something on your own first before you then watch me solve it. I think that's another great way of experimenting and getting a feeling for whether you really understood something. Now, also, of course, use all the course resources, and that's mainly, of course, the attached links you find on some lectures. I typically mention if something is attached, and all the attached code snapshots. Now, you find code snapshots on many lectures throughout this course, reflecting the progress up to that lecture, and always on the last lecture of every module. Now, these code snapshots are there for you to compare your code to them. You can also run my snapshots, these attached code attachments, as standalone projects, and there's a how to use text file in every attachment that shows you how to, well, get this attachment to run. Now, definitely take advantage of this. Compare your code to mine if you're facing issues, if something isn't working the way it should work or it's working in my videos. All the snapshots which are attached are taken directly from the recordings, so they absolutely reflect what I show. So if something's not working, take my code, compare it to yours, maybe replace your code with mine, even just temporarily to narrow down the issue, and you will be able to solve all these issues. Now, of course, there also is a Q&A section where you can ask. Now, please be aware, I only can help on questions directly related to course lectures or course source code. I'm not providing any personal coaching for your own projects or your own code snippets. That's not something I can offer, unfortunately. But the Q&A section is there for you if you're facing some very strange error which doesn't seem to be related to the code, or if something is unclear, if some concept is unclear even after watching the video for a couple of times, then the Q&A section is your place to go. Now be aware, if you're just getting some error with your code, definitely take my attached code and compare it, because that will help you solve such problems. And also don't just ask in the Q&A section, also help others, because that is how you will learn the most. By helping others, you're challenged to dive into problems, you have to solve problems, and that's always how you learn the most. And if you're sharing a solution that turns out to be wrong, that's absolutely no problem, then you'll learn again by getting corrected. So definitely take this as an opportunity to master this topic, to master React Native, and to get the most out of this course. So time to now really dive into React Native with the help of Expo here. But again, Expo is really just a thin extra layer. What you're learning is React Native. So let's get started. Let's get started building our React Native app, and let's dive into the core basics you gotta know when you work with React Native. How you work with these built-in components, how you style your app, and how you generally will go about building a React Native app and wiring things up. A crucial part of React Native are these components which are built into React Native. Because as you learned in the first section of this course, these are special components for which React Native knows how to translate, how to compile them to native platform widgets. And you can only use such components in React Native apps. You can build your own components, but these then also in the end have to be made up of these built-in components. You can't use divs or paragraphs or anything like that. So we have to work with the ones built into React Native, because there React Native knows how to translate them. And there we have things like the view, text, button, touchable text input image. These are some of the components you will see throughout this course. There are more, and we'll see plenty of them throughout the course. And you will learn how to work with those, how to configure them, and how to compose nice user interfaces with the help of these components. Now you, as I just mentioned, of course, build your user interfaces, your custom components with the help of these built-in components here. So you compose your user interface, your components from these built-in components there. And it looks something like this. You build your own myTitle component by taking the built-in ones and mixing and matching them together to get the look or the component you need. Styling also is an important part in React Native apps, and there it's important to understand that React Native doesn't use web technologies, it doesn't use HTML. It uses JavaScript arguably, but doesn't use HTML, and it also doesn't use CSS. So CSS, which you use for styling in the web, is not supported in React Native. But it gives you styling commands, styling configuration you can add to your components, so to these components that are built into React Native, either with the help of inline styles or with so-called style sheet objects. And there you write these style instructions in JavaScript, but you use a syntax which is based on CSS. So it's not directly related to CSS, but of course it's influenced by CSS. Many of the instructions you use here are inspired by CSS, and many of the rules or of the properties you know from CSS also work here in JavaScript in your React Native app. Now, regarding the inline styles versus style sheet objects thing, I will show both, but I will already say that using style sheet objects is preferred, but I'll come back to that once we do use it. And with that, now that we know roughly what's up with components and styling, why don't we just get started and start working with these things? For this, I'll create a brand new project, again with Expo init, and then a name of your choice, and I'll name it RN complete guide, because in the end, this is a complete React Native guide, which you got here. And I'll start with the blank template here, so that first option in my case here. Regarding the name, I'll name this RN guide, but you can choose any name you want here. Simply hit enter, and I'll go with npm, not with yarn. And now, just as in the first course section, this will create a new project and set up a React Native app in there. So let's wait for this to finish. And with it finished, you could follow these instructions, but I'll not do this here. Instead, here I'm back in Visual Studio Code, still with my first app from the first section opened, and I'll open the new one now, the one we just created. And here is the project opened up in Visual Studio Code. I walked through all the core files and folders we have here in the first course module, so I'll not repeat this here. And with that opened up here in Visual Studio Code, I'll now actually go to the menu and then choose Terminal, New Terminal, to open up my system terminal or system command prompt, depending on which operating system you're working on, here in the IDE. So that's your normal command prompt, your normal terminal, just integrated into the IDE and already navigated into that project folder. So you don't need to use CD to navigate anywhere else. And now here I'll run npm start, and this will do the same as if I would have run it here. The difference is now I always see errors or any log messages directly here in the IDE, which is more convenient to work with. We still got that process, which you should keep on running to get these live updates when you save something. You see the commands you can type here or the shortcuts you can press to launch your app on emulators. And you also have that browser tab up and running here for your application, the Expo DevTools. Now I got two emulators up and running here, Android and iOS. You don't need that, of course, but I want to show you how this app works on both. And I can run this app on Android by pressing A here in the terminal. And I can run it on iOS too by pressing I. And I did both here. Alternatively, we could have used these buttons here in the Expo DevTools in the browser. So now this is launching the app here on these devices, on the Android and iOS simulator, and I'll be back once this finished because the first launch always takes a bit longer. Subsequent rebuilds, reloads are way faster, of course. And here we got that starting app running on these emulators. Now, in case it looks a bit different for you, attached you find my starting project in exactly the same way I have it here, so that you can also use that, replace the files in your project with mine, and then if you run npm start, get, well, this look here. So this is the starting project we'll now build up on and will now work on. Of course, the question is, what will we build here? Now we'll dive into the basics here, therefore of course here we'll build a relatively simple app, but already showing a lot of the core features you gotta know. So the app we'll build here will be an app where you can save your goals for this course, your course goals. Therefore we'll start by adding an input field here where you are able to enter your goal, and of course then a button which adds it, and then here we'll have these various items, these various list items below that with your goals on them. If you tap them, that will delete the item. So up on a tap, that will be deleted. By pressing that button, we of course add an item, and we'll also enhance this application here throughout this module so that it also works a bit differently by the end of the module. Then we'll just have a plus button here, so to say, and by pressing this button here, we will open a modal, which is an overlay over the screen where you can then enter your goal, and we still will have the output here, but basically the inputs will be taken away from that main screen into that modal. The idea of this, of course, very trivial app here is that we get to know a lot of these core features, these core components you work with, how to style these components, how to work with such a modal, and so on. And we'll obviously build way more complex apps throughout the course, of course. So let's get started with this very trivial, nonetheless super important and helpful application now. And for this, it makes sense to start here in the app.js file. Now leave that terminal open here and that process running, of course, so that changes in your code are automatically reflected to the emulators. And now let's see how we can get started with that. I already mentioned in the first course module that React Native is all about these built-in core components like text and view. A view would be your div from web development in case you're a web developer, which you probably are if you know React. So it's a great container component. You can style it as you see it here, and you can wrap other content with it. Now, a text, on the other hand, is a core component for, well, outputting text. That's its goal. Not there to output an image, but there to output text. Now, what you can't do in React Native, and that's the first important thing, you can't, for example, output text between a view like this. If we would try to save this without that text wrapper, you see we get an error. That's, by the way, a screen you will see from time to time when working with React Native. It gives you an error, it explains what went wrong. Here, for example, it's a pretty clear error message telling us that text strings must be rendered within a text component. And why is that so important? Why am I emphasizing this? Because that's an important difference to web development. There, you can put text anywhere. In web development, you could have a div, and between the div opening and closing tags, you could have any text. And this will not work on React Native, not only because we're using a div, that's not supported there, but of course, because on React Native, you really can only output text between text tags. So you need to use that text component provided by React Native to output text. And that's a crucial difference to the web, where you can throw your text anywhere. In React Native, it's way more important that you use the right built-in component for the job you want to get done. And for styling, for setting up a container where you structure different content, that would be a view. For outputting text, that would be a text. For outputting an image, for example, you'll have an image component. So that's how React Native works. And speaking of styling and of layouting, the view has this as a main job. It's mainly there to apply styles and to lay out the content you have in there. And speaking of that, let's get started with layouting. Let's say in our app, we want to have two main areas here on that screen. At the top, I want to allow the user to enter some text. And on the right of that, I want to have a button to confirm this choice. And below that, so that's part one, the input area. And below that, we have the second part, and that's the list of goals the user entered. So therefore, here in app.js, we can get started by having a wrapping view, because just like in normal React, you need to have one parent component, and that will typically be a view in React Native, because that gives you most layouting and styling options. And inside of that view, we could have another view for the input area, where we then add our input. And below that, yet another view to have our list of goals. And I'll get rid of that text. And it's pretty normal in React Native that you have quite a lot of views nested into each other so that you can build any layout you want. Now, let's get rid of this container down there, by the way, and also of this style assignment. And let's start with all of that from scratch. Important takeaway right now is each component provided by React Native has its own job. There aren't that many components, but the ones that are there have clearly defined roles. And you do then build your UI by nesting these components into each other, depending on which you want to achieve. For example, if you want to build a layout, you start with nesting a couple of views. And then once you're at the part where you want to output content, you'll start adding text and so on. And we'll do all of that over the next lectures. You can also always go to the official React Native docs. And there, if you click on Guides, Components and APIs, you'll get an overview over these core building blocks. You find the view here, the text, the image, the text input, which I mentioned earlier already, and a couple of other core components. And you'll see pretty much all of those, or most of those, throughout this course. And this is a great place to dive deeper and learn more about them. And as you already can tell, if you leave out the platform-specific ones down there, which are more niche-focused, then there aren't that many core components, only about 10 core components, and that's how React Native works. Nonetheless, you'll be able to build any app you want, as you will see. So back in code, we started with throwing in some views here, and of course right now this won't work, this will just break or will not render anything meaningful to the screen. In that first nested view here in this block, I want to have a text input and a button. Conveniently, both is provided by React Native, We have a text input here, and we also have a button component. So we can import both text input, which allows the user to enter text, and button. And then here in that view, in that first nested view, I'll add a text input as a self-closing tag because there's nothing we could pass between opening and closing tags. And for the button, you could think that you use a button like this, but actually that's not how this React Native button works. Instead, it's a self-closing button, and you set a title property to define which text to render there. And here we could say add. Now we have a text input and a button there. And if we save this, and this reloads, we see the button here, but we don't see the text input, right? So that's not working as intended. The reason for that is actually that the text input will be hidden here below the status bar. So now is the time where we should get started with adding some layout, some structure to this page. Because just adding components alone won't do the trick. A React Native app is all about using components and then adding the right layout, the right structure to your components. So here, for example, it would make sense to add some general padding around that views on this top view. Padding basically is some distance from the border of that view, which is basically the device frame in our case here, since I'm talking about the topmost view, to the content of the view. So some spacing between the borders of that topmost, of that surrounding view, and the content in the view. And for that, we can add the style property here on the view. Most components in React Native support the style property. The view does. And there you use this dynamic content binding here, which you know from normal React 2 with the single curly braces. And style expects a JavaScript object now. So we add another pair of curly braces here. And now a common mistake is that you think this is a special syntax which requires double curly braces. Indeed, it's the normal React syntax with single curly braces, where then the dynamic value you're passing to style just happens to be a JavaScript object. Hence, we have another pair of curly braces. And in this object, you can now have key value pairs where the keys are your style property names and the values are, well, the values for these style properties. And these style property names are influenced by CSS. So here what you can do is you can add padding that exists in React Native as well. And a comprehensive list of supported style properties can always be found by going to the component you're using, like the view here, and then by clicking on the style property. And here, if you click on view styles, you see a list of all provided properties which you can use. And you see some special properties for the view here, and then some general props like layout props. And there you would find the padding, for example. So that's how you can find out what's supported, but you'll also see many examples throughout this course. So here I add padding, and the value now can just be a number, which will be device-independent pixels, so a pixel value which always looks good no matter which device size you have. So here we could add 10, and if we do that, now we see the button is a bit further down. Maybe let's add 30 here so that we can see a bigger difference. And now that's working, and now if you tap above the button, you don't really see an input here, but you see that my soft keyboard opened up on Android. On iOS it doesn't open by default, but there also you can tap here, and if you tap often enough, or if you go to hardware and then keyboard, toggle software keyboard, it should open up there as well. So here we also have an input. So now we can see that input because now it's not behind that status bar anymore. So adding that padding probably made sense because now we made sure that our layout is inside of our screen here. Now there are other tools for making sure we have enough padding here as well, but for now let's manually set the padding and let's maybe set it to a value of 30. So we were getting started with the layout. Now let's go back to this component and let's make sure we can see something. We can see that there's a text input and we don't just have to guess it. For this, we can go to the text input and there, for example, add the placeholder prop. And just as before, to find out what you can set, you can always go to the official docs. In this case, to the text input docs. And there you find a description how to use it and some examples. But if you scroll down, you also find all the props you can set. And there, for example, you find out that you can set a placeholder prop, which is that dummy text that is shown before the user entered some text. So here that takes a string, and here we could enter course goal, because you should be able to set your course goal here. And if you do that, you see both on Android and on iOS there is this course goal text. Now still, it could be a bit better, it could be a bit clearer that there is a text input. And therefore here I'll also add a style, another inline style, and here I'll set a border bottom color of black. Black now is a string. Such color shortcuts are supported in React Native, and a comprehensive list of all available colors is attached to this lecture here. And I can also set a border bottom width of, let's say, 1. And what this does is it should set a bottom border on this input, so that now if we go back, we have that underlining here. We can clearly see it on iOS. And since there still is not that much space on iOS, let me actually ramp up this padding up here to 50 maybe. Yeah, that looks better. So now we have that border below our input, and that makes it clear that there is an input here. Of course, you're not restricted to only setting a border on the bottom. You could also just set a general border by leaving out bottom here, a border color and a border width. And if you did that, then this would be surrounded by a border. Now, one important note regarding these style names here, these style property names, you of course see that it's border width, border color written like this. In normal CSS, you would have border dash color, and that would apply the border color, but that would be an invalid property name in JavaScript, which is why this is not supported. Now actually, a valid property name in JavaScript would be if you wrap this in quotes though. But even that is not supported in React Native. So these alternative syntaxes, for example, this syntax would work in JavaScript if you apply some style to a web HTML element. These syntaxes are not supported in React Native though. There you really have to use this camel case syntax where you, for example, write border color like this. Or in short, you have to use the property names you also find in the official docs. There are no alternative names for these style properties. And we could now also add a padding here of, let's say, 10, so that we have some spacing between the border and the actual part where we enter something. And I'd say this already looks way better, and we can clearly see that we here have an input where users can enter something. So we got started with the text input. Right now we're not doing anything with the values the user enters. But before we do that, let's make sure that actually the button is not below that input, but next to it on the right. And for that, again, we need to work on the layout. That's why I have this extra view here around the text input and the button. We wouldn't need that, but now with that nested view, we can control how these two items are aligned to each other by, again, adding the style property here. And now, for layouting, for positioning things, React Native uses Flexbox, which you also might know from the web in case you don't, attached to find resources that get you started with CSS Flexbox. You don't need to know Flexbox in and out, but it helps to know a bit about it. Flexbox works such that it positions elements inside of a view next to each other or above each other. By default, above each other in React Native. You can change that by setting flex direction from column, which is the default, to row. And by just adding this on this view, we override the default, which is, well, the default, which is why we don't have to set it, of column. And now already we'll see that the button and the text input sit next to each other. Doesn't look that great yet, but they're sitting next to each other. Now, to make that look better, we can also add more. For example, you can define how things are aligned and distributed in their row or column. For example, with justify content, you can control how items are distributed along their main axis. And with row, the main axis is from left to right. If that would be column, the main axis would be from top to bottom. So now we could specify a value, and here my IDE even gives me auto-completion, which is very convenient. We could specify a value of space between, for example. What this means is that all the remaining free space is between the two elements. So they're now not sitting directly next to each other, but instead there is some free space between them, as you can tell. Now we can also align them on their cross axis. So main axis for flex direction row was left to right. Cross axis then is top to bottom. For flex direction column, the main axis would be top to bottom, and the cross axis would be left to right. So the cross axis simply is the opposite of the main axis, so to say. Justify content positions along the main axis. With align items, you can control how the child elements of this view are aligned along the cross axis. There you have different values, like for example, center. So in this case, since we have flex direction row, this should vertically center all items, which means that the button now looks nicer and is simply centered there in the middle of this input. Well, and now we can also ramp up the width of that input a little bit by going to the text input, and there on the style, we can also add a width of, let's say, 200 to give this a width of 200 pixels, which means that this now is a bit bigger. Alternatively, by the way, you could have also chosen a percentage value like 80%, which means that this takes 80% of the available width made available by its parent component, so by the view that surrounds it. And now with that, we had a look at the first important fundamentals about laying things out in React Native and styling things. But right now we're doing all of that with that concept called inline styles, which means we're setting up the styles directly on the elements. And that's not ideal. In this lecture, I want to dive a bit deeper into Flexbox, especially regarding how you use it in React Native apps. If you know all about that already, you can of course skip this lecture. So for this, I prepared a simple dummy application, and of course you find that attached. It's a normal React Native app built with Expo, and in the app.js file here, what I have in the end is just a view with 3 views in there, where each view then has a text with text 1, 2, 3. This simply creates some boxes with different colors, red, blue, and green. And now we'll use Flexbox to move these boxes around so that you can get a feeling for how Flexbox works, because it's so important. Now, first things first. By default, every view in React Native, even if you assign no special styles, uses Flexbox. And that's different to the web, for example. There, if you have a div, which would be your equivalent to a view, kind of, it doesn't use Flexbox by default. In React Native, it does. Every view by default organizes its children with the help of this Flexbox thing. Flexbox simply is a term, is simply a concept from CSS that is all about organizing child elements in a one-dimensional space. So here, for example, in a column. That's also another default. Not only does every view by default use Flexbox, it also by default organizes children in a column, so from top to bottom. That's also a difference to the web, and I don't want to emphasize these differences too much because, of course, you don't need to be a web developer to build React Native apps. But I think a lot of people do know web development, do know CSS, Flexbox, and therefore it makes sense to also talk about the differences. So in the web, when you use Flexbox, not only is it not turned on by default, in addition, if you do turn it on, the default is to organize all child elements in a row. And here the default is to organize them in a column. You can change that default though, so in this case, on the view which holds my boxes, by adding flex direction here and setting this to row, for example. Now you will see that these 3 boxes are organized in a row from left to right. Now besides row and column, you also have row reverse and column reverse. And this simply also, well, does what the name implies. Now we still have a row, but the first element, the red box, actually is on the right and not on the left anymore. So that's also something you can do. Let me go back to row though. So that's the first thing you can do. Another important thing about Flexbox is how child elements are sized. Here, I gave every child element a width and a height of 100. Now, if we would remove that width and height thing on every child element, then you will see that now we have a very, very small row here, because every box now is only as wide as its child requires it to be, and only as tall as its child requires it to be. So every box here which holds a number is only as wide and tall as the number it's containing. Now you can change that with the surrounding Flexbox container too. Let's give that a width of, let's say, 300 pixels, or of 80% of the parent width. So in this case, since it's the root element, of the device width. And let's give it a height of, let's say, 300. If we do that, and now really important, I'm doing this on the view which holds all these boxes. I'm not doing it on the boxes themselves. So if we assign this width and height on the surrounding box, you see something interesting. The height is assumed for all the elements. Now all the views in the Flexbox take the height of the parent. The width has no impact here. That's also a default behavior you got here, obviously, since we haven't changed anything. The default behavior here indeed is that the child elements in a Flexbox, so in this outer view here, are organized such that they align themselves along the cross-axis by stretching. Okay, that were a lot of terms. What does this mean? Now, when working with Flexbox, we have two important axes. The main axis depends on your flex direction. For a row, which we have here, flex direction row, the main axis is from left to right. For row reverse, it would be right to left. For column, it would be top to bottom. And for column reverse, it would be bottom to top. So that's the main axis. And then you also have a cross axis, and that's simply the opposite of the main axis. So for a row where the main axis is from left to right, the cross axis would be from top to bottom. If the main axis is from right to left, which would be the case for row reverse, then the cross axis would be from bottom to top. Okay, so that's the main axis and cross axis concept. Now you can organize your child elements. So in this view where we have the three boxes as child elements, you can organize these child elements along these axes. You use justify content to organize elements along the main axis, and you have align items to organize elements around the cross axis. Now you see the values you got for justify content here if you add these quotes or if you place your cursor in there and you hit Control Space. You see you can center elements, you can position them at the end or at the start of that container, or you can add some space in between. For example, if we use space between here and we use align item center, then things will change. Now you will see they're taking the width of the surrounding container. Every box itself still is pretty small, but they're split or they're distributed across the width of the parent container. And they're no longer taking the height because along the cross axis, we're aligning them with align items. And there I set this to center. The default here is stretch. And if I set it back to stretch, then unsurprisingly, they do stretch for the entire height. Now, if you want to make sure that they take the available width, you can't set stretch here on justify content, which is your main axis positioning vehicle. So you can't set stretch here. So what can you do regarding that then? Well, that is something you now configure on every child item itself. You can tell a child item how much space it should take of the space it's potentially getting. Stretch here is kind of a special case. There you set this up on the parent item. Normally you set this up on the child item. So for example, if I set this to center now so that the parent doesn't tell the child how much space it should take, then we can fully control the space a child takes by going to the child style, and there you can add flex, the flex property. The flex property is applied to items that are inside of a Flexbox, so that are inside of a view in this case here. And that can be a view itself, but that could also be another component like a text, for example. So now here you can add flex and you can set this to a value of 1, for example. So flex needs to be a number. If you set this to 1, what you will see is that now the red container, where I did set flex to 1, takes all the available width it can get, just so much that it leaves enough space for the blue and the green container so that they can squeeze their content into the surrounding Flexbox. Now we can't see the boundaries of the surrounding container, but the boundaries would essentially be where the red item starts and the green item ends on the horizontal axis here. So now Flex 1 makes sure that the red item gets as big as it can get. So it takes as much space as it can get. By default, views only take as much space as their child elements require, so as this one character required. But with Flex 1, you change this, and they now take as much space along the main axis, so along the width here, as they can get. For the cross axis, again, that's a special case, you have to do this on the parent. For the main axis, and since we have row here, the main axis is a horizontal axis from left to right, you do this with the flex property on a child. Now, of course, you can add flex to other child elements as well, like to that second, to that blue container with the 2 in there. You can add flex 1 there as well. So now I have flex 1 on the red container and flex 1 on the blue container. And what now happens is that both of them take the available free space, and amongst these 2 boxes, the space is distributed evenly. And that's what this number here indicates. This number is a relative number. All items in the same flex box with the flex property distribute the available space by considering the number you assign here. And these numbers are relative to each other. So if I give the blue container flex 2 here, then this means that of the available space you have in that surrounding container, after deducting the space every element needs to squeeze its content in there, the blue container will take twice as much space as this one, because here we have flex 1, here we have flex 2. If we had flex 3 here, then this would take 3/5 of the available free space, because we have 3 plus 2, so we have 5 available segments, so to say. And here the red container would take 3 segments, blue container would take 2 segments. If we have 1 and 2, then we have 3 available segments, and the blue container takes 2 of them, red takes 1. So you always add up these flex numbers and then distribute, or that's automatically done of course, but then the available space is distributed accordingly. So now here we'll see that the blue container is twice as big as the red one, or it takes twice as much free space as the red one. So this is how you can work with flex. You can organize how items are positioned with flex direction, with justify content, and with align items. And you can also make your items grow and shrink with the help of flex. So now that's a brief introduction to Flexbox in React Native. As I said, inspired by Flexbox for CSS. So if you knew that, all of what I explained here is probably not new to you. We'll work with Flexbox throughout this course, so there things will also become clearer and we'll work a lot with it, and you'll see how you can create beautiful user interfaces with Flexbox. Flexbox in the end is the tool in React Native to structure your content on a page, to organize your content. And you typically work with a lot of views, which you also nest into each other, so that you can position elements the way you want. Because of course, and that's also important, you don't just have to have one view in your app which uses Flexbox. You could have another view in there which also uses Flexbox. And actually, as I mentioned, every view by default uses Flexbox. And you can then nest these views into each other so that you position everything the way you want. And you'll also see this in this module already. And actually, I'm already doing it here. In my views here, which are in the surrounding view, so my boxes here, there I also use justify content and align items to center my numbers in these boxes so that 1, 2, and 3 are centered there horizontally and vertically. And that works because we have Flexbox turned on by default and we can't turn it off, by the way. And therefore, I just use these 2 properties here to align my content of this view along the main and the cross axis. And here, since I set no special flex direction for this view, the main axis is top to bottom because the default flex direction is column, and the cross axis is left to right. That's just a side note. Inline styles are very easy to apply, but their downside is that the more complex your app gets and your setup gets, your component gets, the harder it is to follow along with all these inline styles. You will have a lot of code up there in your JSX code, and it can be hard to read it, to understand it. Therefore, whilst you can use inline styles, it's actually recommended to use a style sheet object, and that's exactly what's getting created down there. This uses style sheet, which is a class in the end provided by React Native, which is why we import it from there. And this in the end creates a JavaScript object which contains all your style configuration. The difference to a vanilla JavaScript object, which you could also create on your own like this, is simply that style sheet create could, in the future, also apply some performance optimizations and apply your styles more efficiently in the end. Therefore, you should use that because you'll lose nothing, but in the future, you might benefit from additional optimizations. Right now, when I'm recording this, there is no difference though. But again, you should use Stylesheet Create because it won't hurt and you might get additional performance optimizations in the future. Another advantage of using the style sheet is that this will automatically add some validation, which means that if you're using an incorrect style property or an incorrect value, React Native will detect this and will throw an error, which simply makes it easier for you to spot such errors. If there would be no validation, it would fail silently. It would just not apply the style. And you might not even see that instantly, or you see that the styling isn't correct, but you don't really see why it's not working. Therefore, this built-in validation is another advantage of using that style sheet object here. To create, you pass a JavaScript object as an argument. So the argument you pass here is a JavaScript object. And in that object, you can now define your styles. And you don't do this by adding padding 10 because it would be unclear where this should be applied. Instead, you use any property name of your choice, like for example, screen, to set up the style for our overall screen view. So for this top level view here. And you could have chosen any name you want here. This doesn't have to be screen. Here you now have a nested JavaScript object. So the value for this property is another JavaScript object. And there you set up padding 50, for example. So the styling we had up there as well. Now we can remove that style up here. I still have the style property, but I no longer have the inline style object. And instead here, I now point at styles, which is this constant, which holds our style sheet object. I point at styles, and then with dot, I point at the screen style. And that's what I meant. You can choose any name you want here. If you would have named this root, then you would have just have to use root up there. So you can use any name you want. You just have to make sure that the names you use down there meet the names you use up here. And now this tells React Native that this view should get the styles defined for a screen down there. We can do the same for our input container, let's say. Again, this name is totally up to you, input container. Here I will take this style object, I applied as an inline style to this view before, and I applied this as my value for this input container. Now, here on that view, we reference styles.inputContainer. Now with some auto formatting, which you, by the way, can do in Visual Studio Code by going to Preferences, Keyboard Shortcuts, and then search for Format Document. That's the shortcut you want to press, so that auto formats the document, the file. With that, we have some clean code structure here. We see these are our input container styles, and we apply them here. Another advantage of having this style sheet object is also that you can apply the same style to multiple views without copying it. So if we want to have the input container style, not just on this view, but also on this one down there, well, we could simply write styles.inputContainer. You can apply this style to as many components as you want. Now, of course, I don't need it here, but we could use it here if we would need it. Now, the last style I want to apply is on the text input here. There, I'll just name this input. Whoops, too many curly braces. Set up my styles here then, and then on the text input, refer to styles.input, like that. With that, if we save this, we have the same look as before, but now we're using the style sheet objects, which makes sharing and reusing styles easier, and which possibly also yields us some future performance optimizations. And in addition, our JSX code here simply is much leaner now. So that was a lot of talking, a lot of stuff being done. Now it's really time to make this button work and let us add a goal here, right? And for that, we need to find out what the user entered, and thereafter, of course, listen to a tap on the button and then add the entered goal to an array of goals, which we have to manage somewhere, which we then can output down there in this bottom view, right? That's what we need to do. Now, in this course, I will use functional components only with the React Hooks feature, which is relatively new. So in case you don't know React Hooks yet, definitely learn about them first. For example, in my React Complete Guide, I thoroughly cover them, but attached you also find some other resources that get you started with React Hooks. Because we'll need React Hooks to, for example, get the user input. We use the use state hook for that, which we import from React, not from React Native, but from React. It's a core React feature. And then here in this functional component, in this app component, we can get the entered goal and also get the set entered goal function to update this state with the help of use state. And by default, we have an initial state, which is an empty string because the user hasn't entered anything at the beginning. Now we can bind this to the text input. That means when the user types a character, we want to update our state and save the entered text in this state here, which we can then access through entered goal, and we'll pass the entered goal back into the text input. That's this two-way binding. It's a so-called controlled component, which you also know from React for web with normal HTML input elements. So here we can listen to onChangeText, a prop provided by text input, which takes a function that will execute for every keystroke. Now we could provide an inline function here, but we can also set up a separate function to have a bit of a cleaner code. And you can have a function in a function, and we need to have it in here so we can use our state or set entered goal function here by simply adding a new function here. Goal input handler could be a name. The name is up to you though. In that function, we'll get the entered text automatically. That will be passed in by React or by React Native here. And we can then call set entered goal and pass the entered text as a value, because the entered text here will already be a string, because we connect goal input handler to onChangeText by simply pointing at it here. Now that's important. Don't add parentheses down there, because this would execute this function when this code gets parsed, so when the UI gets rendered for the first time. You don't want to execute this immediately though. You want to execute it on every keystroke, and therefore you just take the name of the function, you pass that name of the function to onChangeText, and that effectively tells React Native, hey, that's the function I should execute for every keystroke. So don't add parentheses here, so that this can run on every keystroke. Now instead of this function syntax, you by the way also can use a different syntax, which is the one I will use throughout the course, where you create a constant with that name here, and then the value of that constant after equal sign is simply a function using that arrow function syntax. So then this here is your argument list, and this is the function body. That's normal JavaScript syntax. It is supported by the JavaScript code React Native is able to run, and therefore this is the syntax I will use. You connect it to onChangeText exactly in the same way as before. Okay, so now we have this function connected. We update our state with whatever the user entered on every keystroke. Now we also have to pass that text back into the text input so that it's displayed there correctly by simply binding the value property to entered goal. So to our state, which will change with every keystroke. And with that, we're getting access to the user input because it will now always be stored in entered goal. Now, when the user presses the button, we want to use that entered goal. So for that, I'll add another function here, add goal handler. And that's just a naming convention I'm using for these functions here. You can name them whatever you want, whatever you are used to from your React apps. In the end, the function name should simply describe what's about to happen, and that here will handle a press on that button, which in the end will then add a goal. Here, the function won't take any arguments, but in the function body, I want to add my entered goal to a list of goals. And we have no list yet, so for now, what I do here is console log, which is supported in React Native, entered goal, so that we at least see that this was saved correctly and that this function is executed. For this to execute, we need to connect it to the button though. There we can add the onPress prop and point at the add goal handler, again without parentheses, so that this does not execute immediately, but only when a press happens. And now let's save all of that. And let's go back. And let's maybe enter learn React Native. And the good thing is you can use your real keyboard here and press add. And you should see here in your terminal this log. You also see this, by the way, in your Expo DevTools here in the browser tab. There, if you click on one of the connected devices, the one where you just click the button, in my case the Android device, then there at the bottom you also see Learn React Native. And of course, it also works on iOS. Learn all about React Native. If we enter this here and click Add, then we also see that being logged here, and also see that in the Expo DevTools. If we click on the iPhone, at the very bottom, we see this log. Okay, so we're getting the user input, we're storing it, we're console logging it. Of course, we don't want to console log it, we want to output it below our input here instead. We want to have a list of our goals below this input area. So for that, we need that second view here, which should output our list of items. So here, between the opening and closing tags, I want to output all the elements we added, all the goals we added. For that, we first of all need to manage our goals, and we can set up another state for that, which initially is an empty array. Hence, I pass an empty, array as a value to use state. And there we have our course goals and a set course goals function. Now, these names are always up to you, but they should describe what's in your state and how you can update it. So now here, when we add a goal, I want to update my course goals to add the new goal. For that, I can call set course goals, and now set course goals to a new array where I take my old course goals and add a new one. Now, this is a syntax you might not know. That's the so-called spread operator. It's a JavaScript feature which takes an existing array, and course goals is an array. It's our current state snapshot before the update, and pulls out all the elements from that array and then adds them here to a new array, which is why I have the surrounding square brackets. Without these surrounding square brackets, this would not work. But now we create a new array and we add all the elements of the old array, and now we can also add a new element. So here I add a comma to add an extra element after all the elements I'm pulling out here. And the element I add here is my entered goal, of course. So now we update our list of goals with the old list of goals, initially an empty list, but then this will grow over time because we then also add a new goal when we press that button. Now, a tiny side note, when working with set course goals here is our previous state, and the way React updates the state, this should always be your most current state snapshot, but it's not 100% guaranteed to have that 100% guarantee. When you update your state based on the old state, you can use the function form of this set function, where you don't pass the value of your new state here, but instead you pass in a function, typically an anonymous function, where you get your current state or current goals, so your current state snapshot, and then you return your updated value. So here I return my updated array with that inline arrow function syntax, where if you only have one expression, you can omit the curly braces and the return statement and just enter the value you want to return, and it will be returned. That's all normal JavaScript here, nothing React Native specific. So here, I then take my current goals and then add my entered goal. This syntax is a bit better. The other syntax would have worked as well, but this is guaranteed to always work because React Native will here always go ahead and give you the guaranteed latest state snapshot before it then applies your state change here. Now that's all nice. We'll now have a list, an array of goals managed here. How can we now output this though? Now to output our list of goals, here in the view, I want to simply output a couple of text components for now, where I simply print my goal. And to do that, we can enter a dynamic expression here with single opening and closing curly braces. And now we refer to course goals, which is this variable we got here with array destructuring. Course goals is our array of goals. And now, just as in normal React, which is a differentiation I don't really like because we are using normal React here in the end. So just like you know it from React for web projects, you can now map this array of data into an array of components with the map method, which is a normal JavaScript method. The map method takes a function which executes on every item in the array. So here we get our goal, and it then has to return a new component here. Again, I'll use this inline arrow function syntax, where instead of having curly braces and then returning something, I omit the curly braces, and I omit the return statement. This is valid JavaScript syntax. This will also return whatever I enter here. What I want to return is a text component. So this text component we imported from React Native. And with this, we can now output our goal here. Because a goal in course goals will just be a text, because what we add to course goals is the entered goal, and the entered goal is what we get from the text input, and that's just text. So here we're now just outputting some text, and I'm mapping all my course goals into text components, which will be output in this view here. And with that, if we save this, we should already be able to start adding some goals. So learn React Native is one thing I can enter here. Hit add, and here it is. Learn it for real, and we got this as well. And if you also want to make some pancakes, well, you can do that as well. And of course, this also works on iOS. Learn React Native for real. And of course, I still want to make some pancakes. So this is working, and this is how we can output a simple, a very trivial list of items here. Now, of course, these items look rather boring though. So maybe we can apply some styling there to make them look better. Before we do that though, please note that we have an error here in our terminal. Now, our app clearly works, but the error we're getting here is that each child in a list should have a unique key prop. And that's a normal React rule, nothing React Native specific. Indeed, you should always, when mapping this to a list of widgets, assign a key here so that React is able to efficiently update this list behind the scenes if it needs to. You do this by adding a key prop here, and then the key should be some unique identifier. For now, let's go with the goal itself, which isn't strictly unique. You could enter the same goal with the same text twice, which would give you an error. But for now, let's assume you're not doing that. Therefore, we can use goal as a key, and if we do that, we're getting rid of that warning. If I now learn React Native, I can add this without an error. Again, if I add the same text twice, well, then technically I don't even get an error here, but this would be wrong. Here it is. Here is the error because I got two children with the same key. So for now, we'll just assume that you don't do that though. That's the normal key rule you have in normal React as well. So let's simply assume you don't enter the same goal twice, and let's continue with styling these items, because right now they're not looking too exciting. So let's style these components there. And for that, we want to apply some style to the text components. The text component does indeed support the style property, as you can verify in the official docs. But the text component actually does support less styling features than the view does. And therefore, I'll wrap this into another view component. And that's just the view component we are importing from React Native. That's also the part I meant with. You only got a couple of base components, but they'll get you very far because you work with views and buttons and texts all the time. So here I'll wrap this text with the opening and closing view component here. And now here we have more styling options. Now again, I'll not go for inline styles here, but add styles to the style sheet. For example, we could name this list item, but the name is up to you. And let's say here we want to have a padding of 10. Let's maybe give it a background color of this gray hex code here. Give it a border color of black and also a border width of 1. And now let's assign list item as a style to this view by referring to styles.listItem here. And with that, if we save this, now our list items should look a bit better. Learn React Native. This is how it looks like. Now, some spacing would probably also be nice. We can achieve that with margin. Padding is spacing between the border and the content. Margin is spacing between the border and the surrounding content, so the other elements around it. And there we could add margin 10 to add a margin in all directions. We could also just add a margin to the top or just to the bottom. Or, and that's something which doesn't exist in CSS, you can add a margin vertical of 10 to have a margin to top and bottom, but not left and right. And that's, by the way, an example of how this is based on CSS, but it's not the same because margin vertical wouldn't be a property you have in CSS while you have it in React Native. So if we now save that and we add learn React Native here, now you see there is some spacing between these items. And of course also on iOS if we do it there. So this now adds our items. And whilst we probably still don't win a beauty award, it's a good start at least. And we'll dive way deeper into styling and all you can do there later in this course. We just have to get there step by step, of course. Now, one thing we have to adjust now, by the way, the key here always has to be on the root element in your list. So the element which you are repeating. And we're not just repeating the text anymore. Instead, we're now repeating the entire view. So the key should be added to that view here, and not to the text in the view. That's why I got this warning or this error again. Now with the key moved to the view instead of the text, this should be gone. Now there's one thing you will notice. If you enter a goal here, and here I will quickly use the same goal over and over again, even though that gives me an error, but the app will continue to work. So let's ignore the warning at the bottom. If I enter this often enough, you see at some point of time, will exceed the boundaries of the screen, but by default you can't scroll. And that's something which can be really confusing if you're getting started with React Native, because if you're coming from the web, there you can always scroll. The browser by default makes your page scrollable if your content exceeds the boundaries of the page. Here, that's not the same. You don't get scrolling just because your content goes beyond the boundaries of your screen. Instead, your content is just not reachable anymore. Now, obviously, that's not an option. That's a horrible user experience. We want to have a scrollable content. But in native apps, you have to be explicit about the fact that this page or a part of this page should be scrollable. And it's the same in React Native, therefore. So here, what we can do is we can use another component baked into React Native, and that's the scroll view. And as the name suggests, this is a view which is scrollable. So now we can replace this view here, which holds our list items, with the scroll view. On the scroll view, you also got properties that allow you to configure it. You can just place your cursor here and hit Control Space to get an idea of what you can set, or check out the official docs. For example, you could set horizontal to scroll horizontally, but here I'll leave the default, which is vertical scrolling. And by just adding this, you will see that now if I add learn React Native a dozen times here, so let me fill that page. Now this is scrollable, as you can see. I can now scroll my content, and only the part which is wrapped in the scroll view. We could have wrapped it around the entire page, so we could have replaced this view here with a scroll view, or wrap this with a scroll view, so that would also work. It's also something we can do. And then the entire page is scrollable. So if I now add learn React Native here, you see that now the entire page scrolls. Here on iOS, you can even scroll without items. That's the default iOS behavior. But it, of course, always bounces back. But that's up to you where you add this. And here I just want to have a subsection of the screen which is scrollable, so I only wrap this section with the scroll view. But this is, of course, a super important component for any content where you can't guarantee that it fits onto the screen. Now, of course, you might think that with all these device sizes available, you can never guarantee this. But there are certain pieces of content, like an input and a button, which you will always be able to fit onto the screen, and which also can be configured to resize themselves to fit onto the screen. Whereas there is other content, typically lists of data like this here, where you can't guarantee it, and where you just know after 10 or 20 items, it will definitely exceed any screen, and that's the content you want to wrap into a scroll view. Other content like input, buttons, hard-coded static text, so basically any content where you know how many items you'll have in advance, typically can be squeezed onto a screen with the right tools, namely with Flexbox, which we'll also do throughout this course. But for dynamically generated content like this, you definitely want a scroll view. Now I just showed you the scroll view, and it's already time to let go and to get rid of the scroll view. Why? The scroll view is great if you have a scrollable area on your screen, but it's not so great if you have a list where you don't know how long it will be, or which might be very, very long. Now, if you know you have some content, maybe a list of data, but you know it's only 20 items, so it will probably exceed my screen boundaries, but it will never be more than 20 or 15 items, then you can use a scroll view. But if you have very long lists, then a scroll view can be very inefficient, because what it does is it renders all the elements in advance, even the ones that are not on the screen. That means that even the goals down there, which are currently not visible, are fully rendered. And when you scroll such a very long list with a lot of elements, or if you do anything else on the screen, that can really slow down your app. If you have a list with hundreds or thousands of elements and they're all always rendered, even if you don't see them, that can really slow down your app. So in order to speed that up, there is a component built into React Native that handles such infinite lists or lists that are potentially very long in a more efficient way. And that's the flat list component, which you also import from React Native. Flat list replaces scroll view, so to say. So here we can simply use flat list, which is a self-closing element. And flat list has two important properties. The first property is the data property, where you point at your input data, and this should point at an array. So here I point at course goals, because that's the data I want to output. The second important property is a render item. That takes a function which is called for every item in your data to render a list item. This is a function which will get some data about that item, hence I'll name the argument item data, and then it has to return a component. So here I'll return the same view I had before, just get rid of the manual mapping logic, so I'll still return this view. Now you don't need to set a key here anymore, but I'll come back to how this is keyed in a second. So now here we got the item data, and therefore we don't have the goal here anymore. An item data is a more complex object, but in there what you'll have is a item property. Besides item, you also have the index, so the number, the position of that item in the array starting at 0. And separators, which would allow you to basically render separators dynamically between list items. Not something we'll do here. But item will be your data. So one element from your input data. And that here is therefore one of our goals. And if we do that and we save this, let's now learn React Native, maybe here on the iPhone to mix things up. And we can add things here. And if I add a lot and I then close the keyboard, I can scroll, but you'll see that there is a warning. We expand this, we see virtualized list missing keys for items. So that is another warning related to keys. The reason for that is that flat list automatically adds keys to your items, but only if your data, your input data, has a certain shape. And our current shape, where we simply have an array of strings, is not supported. The shape it would expect is that you don't have goals, which are just strings, but instead that your list is a list of objects where you must have a key property in that object. And here I'll actually create a random key now with math random, and then I convert this to a string because it should be a string. And of course, that's not perfectly unique. You might have the same random number twice, but it's good enough for this demo here. And now you can have any other data in here in that object. The key is the only must-have property. So here I'll have a value property, but you could have named this val or text or whatever you want. I'll go with value. And this is now my entered goal. So now our course goals array here is an array of objects where each object has a key property and a value property. And now if we feed that course goals array into flatlist, flatlist is happy because it expects a data source where you have an array of objects where every object has a key property and then anything you want. Now to output our data, it's no longer enough to access item data item because item is now an object and not just a string anymore. But item will have a key and a value property now, because that's what we're setting up there. And I can simply access the value property to output the text. And now if we save this rebuilds. And therefore now if we try this again with learn React Native, close the keyboard, you see we no longer get the warning. We can still scroll this, of course. We get no error here either, because now we have that key property here. Now, in case you have data where you don't have a key property and you don't want to transform it, let's say you had ID instead, which would cause a warning. As you can see, if I test this, we get the warning here. In that case, you can also add another property to FlatList. Besides data and render item, you can add the key extractor property, which takes a function that tells FlatList how to extract your key. And by default, the logic is I'll have a look at the item and look for a key property. But now with key extractor, you can change this. Key extractor takes a function which takes two arguments, the item it's looking at and the index of that item. And now you need to return a key. And by default, it would look for item.key. So that's the default logic, which you don't need to add. Now here I changed the key or the unique identifier to be on an ID prop. And therefore, I will change this down there in the key extractor to get the ID as a key. And now with that, you also get rid of the warning because you inform React Native's FlatList how to get a unique key for every item in your list. So now here, if we again learn React Native here, we add this. You see, this works. We can scroll this. We also get no warning. So that's FlatList, and you should use FlatList for very long lists, for lists where you don't know how long they will be, but where they potentially are very long, because that gives you a better performance than a scroll view, which on the other hand is great if you know you only have a limited amount of items which will probably go beyond your screen boundaries, but where you won't have too many redundant items rendered outside of the screen. So we already had a look at a solid set of basics you need for building React Native apps, for working with these core building blocks, even though, of course, a lot of the things are still unclear. We haven't really had a closer look at styling, at layouting, and so on. But one thing which we definitely should do now is also explore how you can build your own components. Because thus far we always worked in the app.js file, and you will certainly not build bigger apps in one file only. That file would get super big after all. And if you have a custom component which you plan on repeating, right now we would have to copy and paste our code. So let's create new components. And therefore here in the project I'll add a new folder named components. The name is up to you, but since I plan on storing some components in there, the name makes sense to me. And in there I want to create a component for the list item and also one for our input area. So let's create two new files in there, and I will have a naming convention for the files where I start with capital case characters. And I'll have my goal item.js, it's a JavaScript file of course, and my goal input.js file. Now both will hold normal React components. So let's start with the goal item, and therefore import React from React, just as you need to do it in a React for Web project. Then here I'll create my functional component, goal item, which gets props, and which then has to return some JSX here, and I'll export this as a default, just like this. Now, the JSX I want to render there has to use React Native components or other custom components, which then in turn use React Native components. And here I'll go with this content I had in here. So I'll cut it from the app.js file and return it here. Now, in order to use this here, we have to import view and text, so these two components, from React Native. So let's import view and text from React-Native here. In addition, I'm setting up some styles, and I want to use the style sheet, so I'll import this here as well, and then set up my styles constant, which you could name differently, of course, with style sheet create. And I'll go back to the app.js file and grab my list item style here, cut it from there, and go to the goal item and add it here to this object I passed to style sheet create. Now this should work, but of course what I'm outputting here will no longer be on item data. Instead, let's expect that we simply get this as props. So either props children, so that it can be passed between the opening and closing tag of our custom component, or maybe props title, whatever you want, a prop name of your choice then. Now we can use our custom component, the goal item, by going back to the app.js file, and here I'll add an import to goal item with a capital G so that React recognizes this as a custom component from /components goal item. You can omit the .js. And now we can use goal item down here in render item as a custom component. In this case, a self-closing component, because since I'm using props title and not props children, I don't expect anything between the opening and closing tags of my custom component. I do expect a title prop though, so let's set this here with title, and then here we can point at item data, then get access at the item, which is our object where we have a value key. And with that, we should still see the same as before if we enter some goals here. Learn all about RN. Yeah, that's looking good. Now with our custom component. Now here's a good practice for you to also put the text input and button, or this entire view here actually, into our goal input component. And of course for that you'll also need to wire up communication between the app.js file and the goal input component to be informed when users press this button in the goal input component and then add data here in the app.js file. It's how you would do it in a React for Web project too, so if you have experience with that, it should be no problem. Otherwise, we'll do it together in the next lecture, but if you know how to do it, definitely try it on your own first now. Were you successful? Let's do it together. Let's create a new component here in goal input by importing React from React. And then here I'll name this goal input. And I just like this constant syntax here. You could use function goal input to create your functional component. That would be fine too. Then here I'll export the default goal input. And now here we need to return something. And that something is in the end this view with the text input and the button. So let me grab that entire view, return it here between brackets so that this is written across multiple lines and nicely formatted. And of course, we now need to again import stuff from React Native because we're using a couple of components from React Native. We are using the view component, we are using the text input component, we are using the button component, and I also want to use the style sheet component to set up my style sheet object. So for that, let's add styles here with stylesheet.create, pass an object to that stylesheet create method, and of course take the styles from the app.js file. That would be the input container and the input, so cut both so that only the screen remains here. And back in goal input, I'll add both here to my style sheet so that this should work again. What won't work right now is that when we tap the button that we add this, because here we now actually, well, we are not having the state in goal input. And when I tap the button, I actually want to do something in app.js. So first of all, we need to split the state. The entered goal should not be managed in app.js, but it should be managed in goal input, because that's where we have the text input in the end, which is where the user does enter the goal. So let's add the use state import here in goal input, and then add our state management logic here with entered goal and set entered goal, which we get from use state, which we initialize with an empty string. Let's add it here to goal input. And from the app.js file, I'll also take the goal input handler, cut it from there, and add it to goal input here. So this function in a function, which we connect to onChangeText. And now with that, fetching the user input should work again. Now for the button. When we press this, I want to trigger a function in app.js. I want to trigger the add goal handler. And that function should stay here because I need to manage the list here, because the app.js file is the only component which will have access to the goal input and to the flat list where we output the goals. And speaking of that, we can already import goal input there in app.js from components goal input and add goal input as a component here above the flat list. But again, now we need to be able to find out when a button is pressed in this component. And in React, you do that by passing the function, which the child component should execute eventually, as a prop to the child component. So here we could add on add goal. That name is totally up to you. It's a prop you define. And this points at add goal handler. Now this alone won't do anything, but on add goal will now be received as a prop inside of goal input. And it will point at a function, which means we can execute it as a function there. So in goal input, there, on press, I can simply point at props dot on add goal, right? Because on add goal is that prop name I'm setting up here in the app.js file. That is received inside of goal input on the props object we're getting in every functional component. And on add goal points at a function, so we can pass it to onPress, so that onPress, or React Native therefore, knows that it should call this function when we press the button. That's how you do this in React Native. Still, we'd have an issue, because in add goal handler, I'm referring to the entered goal, and that previously was managed in here, but isn't anymore. We manage the entered goal, which is the text input entered by the user, in goal input now, and not in app.js. So add goal handler should actually now receive an argument, which is the goal title or whatever you want to name it. This name is up to you. And that's what we store as a value here. Now we have to make sure that we forward this argument when on add goal gets executed in the goal input. So that happens here on a press, and there we just point at this to also set up an argument which should eventually be passed along. We got two options. Option one is that we set up an anonymous arrow function here. Now this arrow function will be executed eventually, and therefore now we can add parentheses here, because this will now not get executed when this gets rendered first. Instead, this arrow function will be registered as a to be executed function for onPress. And now here in on add goal, we can forward the entered goal, for example. That would work. Or alternatively, we don't use this anonymous arrow function approach, and hence we can't add parentheses here. But then we can use another JavaScript feature. On functions, we can call bind to pre-configure some arguments which should eventually be passed along when this function gets executed. The first argument is always to what the this keyword should refer. This doesn't matter for us here, so we can just write this. But the second argument here, or all other arguments thereafter actually, will be the arguments received by this function when it is called. And it is called upon a button press. So these are now the arguments which are forwarded to the onAddGoal function, which in the end is just our addGoal handler function. And there we need the goal title, so we need to forward this. So therefore here, I can now set up entered goal as a to be forwarded argument. And that's normal vanilla JavaScript syntax here. And now with this, it's getting rendered, that's looking good. And if I enter learn React Native here, it's still getting output here. So that all works, but now we split this app into multiple components, which is what you typically do in React apps, in React Native apps, just like you do it in React for web apps, because it keeps your components leaner, more focused, and your code more organized and easier to understand. So we can add our elements here. What we're not able to do is delete them. And that's the next step I want to take, the next thing I want to implement here. We got our flat list with all these goal items. And it would be nice if we could tap such a goal item, so such a list item. And when we tap it, we simply remove it from the list. Now the good thing is we can uniquely identify every item, because every item here has an ID. So we can use that ID for then getting rid of the item. The missing thing is that we can tap it. Now on our own component, we can't simply add on press or anything like that. This will not work. If I console log does that work here, we'll not see that log as soon as I press the item. So let me show this to you. If you let this reload here, and then we again learn React Native, and I add this and I tap this multiple times here, I'm tapping this, you don't see the output here. And it makes sense. This is a custom component, and on press would now simply be a prop we pass to this component. This prop would be connected to this function, but nothing is triggering that prop from inside the component. So we'll have to go into that component and make sure that this view is pressable. Now, actually, a view has various props that help us with listening to events. If you type on here, your IDE, if you're using Visual Studio Code, should give you some auto-completion. And you see there are quite a lot of events you can listen to. For example, on touch end actually helps us with listening when the user basically touched this and is done touching this. The issue with that is that on touch end and a couple of other listeners we got here are on a too low level. We can set up very detailed listeners to various events here, but for example, on touch end doesn't tell us how long the user pressed this. And if you ever need to find out if it was a long press or a short press, you would have to manually set a timer when the user starts touching this with on-touch start, wait for on-touch end, and then manually decide if that was long enough or not. It's typically not what you want to do, though it's of course great that you have the full flexibility of doing that. But if you want these standard touch events, like a long press, well then this is not ideal because you would have to do all the heavy lifting on your own. You would have to write a lot of code to find out which kind of touch it was on your own. The good thing is React Native has you covered. There is a built-in touchable component which you can import. And touchable is a component you can wrap around any other component you have, so around any view or any text or whatever you have. And it's not visible, it doesn't render anything you can see on the screen, but it will wrap this and register touch event on the child you wrap touchable around. And touchable then gives you finished touch events, so more detailed touch events, which were pre-configured for you. Now, to be exact, touchable like this can't be used as a component. It acts more as a parent class for React Native because there are multiple specific versions of touchable which you then actually should use. For example, there is touchable opacity. Let's use touchable opacity instead of touchable because that now really is a component you can use. And now here you will see that if you type on, you get a couple of high-level touch events you can listen to, like on press or on long press. And that's of course way more helpful. Now here I can listen to on press, which means it's a normal press event as we could listen to on the button. And when this is triggered, what we can do, of course, we can execute any code we want. And for example, we could forward this to, let's say, props on delete. So we call a function that was passed into this component on the onDelete prop. We're not setting this prop right now, but we're now calling something on this prop. And now we can go to the place, to app.js, where we use goItem and add the onDelete prop instead of onPress. And onDelete should now point at a function because we are expecting a function here in our goItem because onPress expects a function. And we're simply forwarding what onDelete points to onPress. So onDelete should point at a function, and it is, but only a function that prints does that work. Nonetheless, that's at least good for testing. So let's see if I learn React Native and I add this and I tap this here multiple times, you see I get this feedback, this slight opacity effect here upon pressing. If I do this, you see that here in the log. So that did work. And you also see the effect of touchable opacity. This actually gives us a visual feedback about our touch by changing the opacity of the element we touched. You can also control this opacity by setting the active opacity prop here on touchable opacity and setting this to a number, for example to 0.8. And now this will be way less transparent, for example, if you press it. So now if I learn React Native here and I press this, the opacity effect is way less strong, as you can see. So you can configure this to your needs, and with that you can not only add a nice effect, but of course also listen to the press effect. Now touchable opacity is not the only component you can use though. Besides touchable opacity, you also have touchable highlight. So let's use touchable highlight now instead to see how that behaves. And the general idea is the same. With touchable highlight you can also listen to press events, so to these high-level events, these pre-configured events, but the visual feedback will be a different one. Here we'll not change the opacity of the wrapped element, but the background color. So now if I learn React Native, and I tap this, you see now the background color changes to black, and of course this here in this case is not the visual effect we want. Now you can also configure active opacity there if you want. You can configure which delay is assumed for a long press. You could have done it on touchable opacity as well. So you can configure that effect, and you can simply play around with that to get a feeling for how to use it. Besides touchable opacity and touchable highlight, you also have touchable native feedback, and that only works on Android. And for now, you don't know how to find out whether this runs on Android or not. I'll show how to determine which platform you're running on later. For now, let's use that, and you won't be able to test this on the iPhone simulator, but here on Android, if I now add this, you will see that you get this ripple effect now if you test this here. And of course, you can also configure this effect here with props you can set. And as always, the official docs are also a great place to go if you want to learn more about how to configure this. So having that ripple effect can be nice on Android too. And last but not least, there also is touchable without feedback. And this does what the name suggests. It allows you to register these events, but it gives no visual feedback, because sometimes you just want to have something which you can tap, but where you indeed don't want to give any feedback to the user. So here I can tap this as much as I want. The tap is registered, and hence I see the output here, but we get no visual feedback. So these touchable components are really important in React Native because they allow you to attach the normal high-level touch listeners like on press, on long press, and so on to any component in React Native. And with that, you can build your own touchable components, your own buttons, your own links, whatever you need. Now here I'll go back to touchable opacity because I like this opacity effect, but really feel free to pause the video here and play around with these different touchable effects and play around with the different configurations you can apply there. Obviously, we'll heavily use touchable throughout this entire course, so we'll see them there plenty of times, but this is also a great place for you to get started with these components. As I said, I'll go with touchable opacity here, and now the next step is to make sure that we don't just log something to the console, but that we actually delete the item which was pressed. Now to delete the item which was pressed, I'll add a new function here in my app component, so a new function which I store in this constant, and I'll name it remove goal handler. And here I expect to get the goal ID as an input, because this ID allows us to identify the item which we want to remove. As an alternative, we could also get the index in the array and then remove the item by index, but I think the ID is even better because, well, we have an ID clearly matched to every item. Why wouldn't we use that for deleting it? And now in here we can set our course goals, because of course I want to update my course goals. And again, we're making an update that's based on our current course goals. So I'll use that function form here. I pass a function, an anonymous function, to set course goals. There I get my current state snapshot, my current course goals. And in the function body, I have to return the updated course goals. Now, in case you're wondering why I don't have curly braces up here, here I use the shorter syntax where I only have one expression which I want to return. So I omit the function body and the return statement. Here I'll have a little bit of a longer statement, therefore I want to have the function body here for readability. Because in here I'll return current goals filter, because filter is a built-in method built into JavaScript that allows us to return a new array. Filter always yields a new array, which is based on the old array on which you're calling it, filtered by a certain criteria. Now, the criteria is in the end passed with the help of a function which you pass to filter. This function which you pass to filter gets the goal because this function runs on every element on the array you're calling it. So in this case, it runs on every goal we have in the current goals array, and therefore we get that goal it's currently running on. And now we can return true if we want to keep that item, or false if we want to drop it. And we want to return true if the ID of the goal we're looking at is not equal to the goal ID we're getting as an argument, because that's the ID of the goal we want to delete. So we only want to keep items where these IDs do not match, because if they do match, then that's the item we want to get rid of, and therefore we of course want to drop it from our new array. So this is the filter logic for getting rid of an item and returning this here as our new state, which is in the end set thereafter. Now we can connect remove handler to onDelete. And now here we got two options or multiple options of doing this. We can simply point at remove goal handler, but keep in mind that you need to pass the ID. So option number 1 is that you also forward the ID here to goal item by simply pointing at item data.item.id, because just as each item has a value, each item here also has an ID, because we're adding an ID when we're adding an item up there. And now, since we pass the ID to the goal item, and we pass the onDelete prop to the goal item, inside of the goal item, here, where we call onDelete in the end, or where we forward the handler onDelete points at to onPress, we could also bind this to set a default argument when this gets called, and the default argument here would be props ID, so the ID we're also getting, so that this ID is passed to onDelete when it's getting called upon a press. That's option number 1, and it's the option I will use, but also to show you the other option would be that you don't pass the ID to goal item, but instead here onDelete, you know in the end the remove goal handler will be executed. And then here you could add bind this and then point at item data, item ID. That would also work. Now I will revert this, however, and I will go with the approach where all the information is inside of the goal item and we do connect our function with the ID from inside the goal item. Now with that, we should have a setup where we can also delete our goals. So let's wait for this to reload and let's test it, maybe here on iOS. We want to learn React Native, and now I want to use different names so that we can see if we deleted the right one. We want to learn it all. We want to maybe also get really good at React Native, and whatever it is. And now I will actually click on learn it all to delete that, and that seems to work. Here, learn React Native, and now the last one. All deleted, and also without any errors here, so this seems to work fine. With that, we're deleting items with the help of touchable opacity in this case, which helps you register events like onPress on any component or on any components you need. Now that we got these basics out of the way, and before we dive way deeper into React Native and also how we can style our apps in a little bit of a more beautiful way, because obviously our styling here definitely still has some upside potential, to put it like this. Before we dive all of that, let me show you another exciting component that's built into React Native and that also shows how easily you can add cool features to React Native apps. And that's the modal component. You find it, of course, in the official docs in that components and APIs guide here. And there you will find a modal down there. Now it's under others. And here, this modal is a nice component that allows you to, well, add such a nice overlay, full screen overlay with little effort. Now let's add a modal for actually hosting our goal input. Right now the goal input is here at the top and that's all right. But I actually want to move that into a modal so that we have it on a full screen overlay in the end. And we only have a button here at the top, so in place of goal input, which opens that modal. So let's go to goal input. And there I want to, well, wrap this into a modal. So I'll import modal from React Native because it's a component shipping with React Native. And there I want to use that modal around my view here. So just like this for now. And now let's save that. Let's see if that already changes something. A bit, yeah, our styling is off. We're losing that padding which we set up originally, right? In app.js, we have that general padding on our screen view, which is that outer view. Well, it's certainly not getting applied on the two platforms anymore, on the two devices, because our content is way outside of this screen. So that modal is already doing something. Of course, we're not really seeing that much. Now for modal, so for this modal component, you can set a visible key that defines whether this is, well, currently visible or not. And that takes a boolean if we set this to false, for example. And thereafter, if we have a look at our applications, we of course see an empty screen. By the way, in case Android shouldn't update for you after setting this to false, simply close the app here with the help of the app drawer. And thereafter, in your process down there, the npm start process, press A again to restart this on Android. So now we have an empty screen when this is set to false. Now obviously hard coding this is not the solution. Instead in app.js I now want to have a button which allows us to open that modal, and then we will close the modal from inside the modal when we press the add button there. Now we're already importing button here into app.js, and now that I see this, we can of course also get rid of these imports which we're not using here right now. So just leave the button import here along with the other imports we are using. And now here at the very top we can add the button. Whoops, that's a self-closing tag though. And set the title to add new goal, maybe, something like that. If we do that, we of course should see that button here at the top, and here it is. And now when we press that button, we want to show that modal, right? Now for that we need to manage more state. So in here, besides managing the course goals, I will now also manage whether we're currently in course add mode or if we're not. So initially we're not, so the initial state I'm setting is false, and I'll name my state here, and of course that is totally up to you. I'll name it is add mode and set is add mode. Again, these names are up to you. I'm just having a convention here, which you also find in the official React docs, where here we try to give the state we're controlling a fitting name, and then we basically take that name and add set in front of it to make it clear that this is the function to change that state. So set is add mode is what we in the end need to call when this button is pressed. And here we can use an inline function or use a named function and just add the handler here, whatever you want. I'll go with the inline function and call set is add mode and set this to true here when this button is called so that we open the modal. Now we can take that is add mode state which we're changing and pass this to goal input to then change the visibility of the modal in there. So here we could add a visible prop, but that prop name is up to you because it's on our own component. And I pass the is add mode, so that's the state we're controlling, to visible mode. So the value stored in is add mode is passed as a value to the visible prop. Now in goal input, we can therefore now use that visible prop. So here we can use props visible, now referring to the visible prop we got on the goal input, which we then forward to the visible prop of the modal. If we now save that and we have a look at our app, if I press add new goal here, indeed, you see that modal content appear again. Now obviously, it's not looking that beautiful here, so we should change this. And one other thing I want to change is that animation would be nice here for opening the modal, right? So here, let's add animation type, which is a nice property we can set here. And you can set this to a string, and there you got 3 options. None is the default, but you can set this to slide. And now the modal should actually appear by sliding up. So if you press add new goal, now this slides up, also on Android. So that's a way better user experience, I'd say. The next step is that we ensure that our content in the modal is presented in a nicer way, maybe centered here in the middle of the modal. For centering the content in the middle, we can use a technique I already covered earlier. Styling, and there specifically Flexbox. So on our modal, we have that view, or in our modal, we have that view. That's our root view. It's the only element in the modal. And then this view, of course, has other child elements, but that's the only direct child of our modal. There we have the input container style, which we apply, and there we currently set a flex direction of row. Now, of course, we could leave that, but I'd say in the modal, if we present it on a full screen like this, I'm actually fine with a vertical orientation so that we have the input and below that the button. So I'll change this back to column, or since this is the default, simply delete this flex direction. And now I want to center this horizontally and vertically though. And for that, we can set justify content to center here and align items to center. But that alone won't do the trick. You can see if you open the modal, it's still all the way at the top. And the reason for that is that our input container, so that view we're assigning this style to, by default doesn't take the full available space it can get in the surrounding view, so in this case in the modal. The modal theoretically takes the full height and width of the screen, but the view simply doesn't take that full available space by default. That's just how it works. That's the default setting. it only takes the space its children require, so the text input and the button. So the view essentially has the height of text input and button combined, and then also the width of the broadest child in this case, so of the text input here. And by the way, here Android just didn't update correctly. That's why you see this strange output here. You can ignore that for now. So to make the view take the full available space here, you can simply go to the style you apply to the view, in this case our input container style here, and set flex to 1 here. Flex is a property which is, well, used in conjunction with Flexbox. And as you learned earlier in this module, in this extra Flexbox lecture, Flex allows you to control how much space your different items inside of a Flexbox take. And if it's the only item, this simply ensures that this container will take all the available space. You could also set this to Flex 2. The exact value doesn't matter here if it's the only child, but you need to set Flex to make sure that this takes the full available space. If you don't do it, it will just take as much space as its child elements do. If you set Flex, it will take as much space as its parent element gives it. So as the parent element of that view, the modal in this case, gives the view. So with Flex 1 added here, if you now save this, on iOS, you see now this is nicely centered. And to also see this on Android, what you can do is you can open the task switcher, close this app here, and press A here to restart this app on Android. Doesn't like the modal, as it seems. And now here, you also see that. Now, tiny adjustment is a little bit of spacing between the button and the input which I want to have. And for that, I'll go to the input and add a margin bottom of 10 here. But with that, I'm quite happy about that. Again, unfortunately, Android is really having some issues here with my modal. So let's close it and see it. Whether that looks good. Yeah. This is good. Now I want to make sure that when we click add here, we do actually now close the modal. So the add button here calls on add goal, and that basically forwards the goal to app.js, which is exactly what we need. But what we also need to do is we need to make sure that when we add a new goal, the modal gets closed. Now keep in mind that we, in the end, control the modal visibility from inside the app.js file, because there we have the isAddMode state, which we're changing when we click this button here, the add new goal button, for example. And this state value, isAddMode, is forwarded to goal input, where we then use it to control the visibility of the modal. So in order to make sure that the modal disappears, we simply have to change isAddMode again inside of the app.js file, because the new value will then automatically be forwarded to goal input. So all we have to do is in add goal handler, where we set the course goals, we also have to set isAddMode to false because we're done adding. Now, a little side note, the way React works, if you're setting two states after each other, it will batch these together. It will not re-render the component twice, after the first change and after the second change. Instead, it will basically apply all state changes at once and only re-render the component once, which of course is good. Otherwise, we would have an unnecessary re-render cycle there, and this is simply a nice optimization React does for us. So we can absolutely change two different states after each other like this. And with that, the modal should now actually also disappear if we set this to false. Let's test it here on iOS. If I add learn React Native here, click add, this disappears, and now learn way more. This also works, and I can also still delete items. Now to test this on Android, same procedure as before. Let's actually restart this on Android. Click add new goal and learn React Native here. Click add, and this closes it. Now let's also learn way more here, like this, and this all works correctly. Now, two tiny improvements I still want to apply. For one, I want to clear the input once we're done, and in addition, I want to provide a cancel button so that alternatively, instead of adding this, we could also cancel here to close the modal without adding an item, because right now that's not something we can do. Let's start with clearing our input here after we entered something. For that and goal input, in the end, we have that entered goal and we need to reset this once we add a new goal. Now, of course, we add a new goal when we press that add button, and there in the end we trigger a function which we get with the help of the onAddGoal prop. Now, to also clear our input, what we can do here is we can add a function inside of the goal input component, add goal handler or whatever you want to call it. This is a function which doesn't have to take any argument, and in the end it's now this function which I want to trigger. So I want to trigger add goal handler, so my own function in this component. Now in here I want to call props on add goal without bind. Here we can just call it like this, because when this function runs I want to execute it. Here we're just passing a pointer at this function without parentheses, so here we must not have parentheses to not execute this too early. Here we absolutely need parentheses because this only runs when this function executes, and that is when I want to trigger the function in my parent component, so in the app component here. And here to onAddGoal, of course I still want to forward my entered goal here, so this state I want to forward this, but thereafter I also want to clear it. So thereafter I'll set entered goal to an empty string again, which will reset the text we entered here. So that's one thing. The other thing is a button that allows us to close this. For that we can add a button here, and that button could have a title of cancel, because that's in the end what this button should do. And for a cancel button it might be nice to not have the default blue color but change that color. And you can do this by adding the color prop here. For example, we could set this to red here, because red, in my opinion, is a nice color for a cancel button. If we save this and we test this here on iOS, we see the cancel button and the add button. And now if I learn React Native here and I add this, this is added. And if I reopen this, you see it was cleared. And cancel, of course, doesn't do anything though, because we need to connect cancel to the app component where we control the visibility by controlling the isAddMode. So here we can also add another function handler in the app component now, cancel goal addition handler or something like that. It's a very long name. I just want to be clear about what this does and when it's called. So here we have the cancel goal addition handler, and in the end here we can simply set isAddMode to false, which will close the modal. And of course we're not doing anything else. We're not changing our course goals because we canceled the addition. And now we can forward this to goal item, to goal input, so to our component here. There we can add a onCancel prop. The name of that prop, of course, is up to you because it's your own prop on your own component. And I forward a pointer at cancel goal addition handler to onCancel. And now inside of goal input, we can trigger onCancel upon a press of this button. So here we add onPress, and we want to trigger props.onCancel here. So the function we're receiving on our onCancel prop. With that, the cancel button should work. Yeah, works just fine. Now it should also work on Android, of course, but to test it, same procedure as always. Let's close it and restart it. And thereafter, let's see if clearing the input works. If I enter learn React Native here, click add. Yep, that's empty, and cancel also works. Now regarding the styling here on Android, it would be nice to have some spacing between the buttons, or actually on both platforms, maybe have these buttons sit next to each other. Now, this is also a nice practice for you. You can pause the video here and try positioning these two buttons next to each other on your own. Only the two buttons, not the input and the two buttons, but these two buttons should be in a new line below the input, but then sit next to each other. After this short pause, which you can use to pause the video, we'll of course do that together. So, were you successful? Let's try it together. The key here is to use Flexbox and another view. Because, again, as I mentioned earlier, and as is really important to understand, view components are your core component for organizing other components, or for being used as a container, which you can also style, but here in this case, to organize other components. So I'll move the two buttons inside of that view, and now we can assign a style to that view. And that style, of course, will be defined here in our style object. And I'll name this button container. This is up to you, this name. And in there, I want to set a flex direction of row to have them sit next to each other. And then I'll set justify content of space between to have the free space between the two buttons. Now let's add the style here to that view, styles button container, and save this. And now here are the buttons, but to have the free space have an effect here, which will be even clearer on Android, by the way, that it's currently not having any effect. So that space between is not having any effect. Let me quickly show this on Android. You see, there is no free space. The reason for that simply is that we have no width assigned to our button container, and therefore, as you learned, it only takes the width of the children, and that is simply the width of the two buttons added together. Hence, there is no free space to add in between. So to have some free space in between, we simply need to assign a width to the button container. And now that width is of course up to you. Since the input has 80%, we could go with 80% here as well, or maybe with 60% to have it a little bit more narrow than the input above, so that the buttons do not sit on the edges of the input, but that's of course up to you. And therefore, now with that, if this reloads, and we have a look at this on Android by using this convenient way of closing it and restarting it, now we should see some free space between these two buttons. Yeah, that's looking good. And of course, you can play around with that. You could also, alternatively, of course, add styles to the buttons. You can add style props here too, and add a margin on the left and right of each button. That would have worked too. You can also play around with other values here, like space around, to have the free space to the left and right of the buttons and not just between them. These are all things you can do. I'll go with space around here and have a final look at this. But ultimately, that's of course simply something that's up to you. Important here is of course that you understand how you can achieve something with the help of a view which you wrap around your buttons and Flexbox then. And with that, I'd say we have a decent look here. Now, one last thing, really last thing, which I now still want to do, is resize these buttons, because they're not equally sized, and I think it would look a bit nicer if they had the same size. Now, on a button, you can't add a style prop and set a width, no matter if you're using inline styles or the style sheet object. Instead, and that's something you have to know, which is why I'm covering it here, you have to wrap your button into a separate view, like I'm doing it here, and then give that view a button. For example, here we could add styles button, referring to a button property down there to each view. And there, on this button property, which I'm now adding, you could add a width of, let's say, 40%, and that will be 40% of the parent of that view, so 40% of that button container view, which itself takes 60% of the entire available width. And we can do this on the other button as well, of course. So that's just something you have to know. If you add your surrounding views here around your buttons, now with that, if we again restart Android, we should have buttons that are equally sized, which of course often is something you want. Of course, you could have also used a pixel value here instead of percentage values. But now with that, I'm really happy. I think that's now really an app that's looking good, behaving good. And yeah, it's a good start with React Native. Now, obviously, there's so much more we can learn and we will dive into. So much more we can do regarding the styling, because as already mentioned, this is certainly not the most beautiful app you ever built, but we covered a lot of important fundamentals here. So throughout this module, we had a look at a lot of important basics you have to know when working with React Native. You learned about these core components which you import from React Native, and that you only can work with these core components. You can build your own components, but these components then in turn also have to be based on these built-in core components or on other custom components, which then are based on these core components. That is really crucial. You have to use these core components, and you can style these core components with the help of inline styles or a style sheet, as we're doing it here. In the end, all the styling, of course, happens with JavaScript, because that's all just JavaScript code here. It's a JavaScript object in the end, to which we're then pointing here when we're assigning a style. And in general, you control your entire UI with JavaScript. This part here, the view, so the elements you're building here, this is the part which React Native will compile to native code. This part up here, your other JavaScript code, that will stay JavaScript code. That will not be compiled. Instead, that will run in this virtual machine, which I showed you in section 1 of this course, and will then talk to the native code through a special bridge set up by React Native. Now, and other than that, we used normal React features. We're using props to pass data around. We're using state here with useState, the useState hook to use functional components only. You could have converted this to a class-based component to use setState there and use state in there, as you probably learned it about class-based components. But I want to use this very modern React syntax, and hence I use React hooks. And with that, we got the basics set. Now, of course, besides the official docs, which are always worth a look if you want to learn more about a specific component, we'll dive much deeper into these components we used here, into styling. And in the next section, we'll also have a look at how you can debug such an application before we then build a different app, a more beautiful app already, where we then dive also into questions like how you can adjust your app to different device sizes, how you can style your widgets, your components with in a bit of a nicer way, and also how you can adjust your styles or your layout to the different platforms, so iOS or Android you're running on. So now that we took our first steps into the React Native app landscape, and before we'll continue building more exciting apps, working more with components and styling and so on, it's also time that we have a look at what we can do when things go wrong, namely at debugging React Native apps, because there always will be some errors. And there are different tools you can use to track down your errors, to fix them, or to avoid them at runtime. When we talk about debugging, it's important to understand what could possibly go wrong and in which situations you might want to debug your code or avoid errors. And the most obvious thing that can go wrong is that your app crashes or that you're getting an error message. In development, that's this red box which overlays your app, which we already saw before in this course. And these error messages are, of course, a clear sign that something's wrong with your code. More subtle than that are logical errors. In your apps, you'll certainly at some point have some behavior which might not make sense to you, or where something just doesn't work the way it should work. You're not getting an error, but your app is misbehaving. It's working incorrectly, and typically you have some logical error somewhere that's causing this. And last but not least, you have your user interface, your styling, your layout, the user experience you want to create. And maybe that's off. Maybe there you have something that just doesn't look or feel the way it should look or feel. And that's also something that can go wrong and that you want to avoid. Now, typical examples for error messages or causes of error messages are syntax errors, where you simply have a typo in your code or where you forgot a closing curly brace, something like that. But also simply bugs in your code. So for example, a line of code where you use a value which you actually never set. So you're trying to, for example, calculate something with an undefined value or parse a string which is actually undefined, anything like that. That would typically also lead to errors. And then you have a special type of error. And these are unavoidable errors, as I like to call them. Now, that does not mean that these are errors you can't avoid because you're just not good enough as a developer. Instead, I mean errors which could result from you making a network request and the users of your app not having a network connection, or that you're writing to the file system and somehow this access is blocked. So you can't be sure that this will never fail when users use your app, because you can't control how they're using your app or in which circumstances they're using your app. And for such errors, you can also find strategies where you can't avoid the error, but where you can handle it. Now, for logical errors, typical example would be that you have some undesired or unexpected app behavior, and you of course want to get rid of that. That you have some unexpected or unhandled user behavior, so that users are using your app in a way you didn't intend them to use. So when testing your app during development, you want to be really creative and find out if users could get into spots where they can't proceed or where your app is not working correctly. So that maybe the users followed a certain sequence of steps that leads to an error, to a logical error. Maybe some input is missing at some point and you're not checking for this input to be set, and therefore with that not being set, you can cause another issue or go into another error. So something like that. Now, last but not least, if we talk about the styling and the layout, obviously we can have unexpected or wrong stylings. We're testing the app and we see that doesn't look the way it should. Or maybe we just have inconsistent results on different devices. Maybe our app looks good on iOS but not on Android. Or last but not least, maybe we have a layout that just doesn't work or feel right on certain devices or orientations. Maybe our content doesn't fit onto the screen on very small devices. These are all things we also want to rule out. Now that's what you can debug. How do you debug? Which tools do you get for debugging your errors? Now, the most obvious tool you're getting, and yet the tool a lot of people overlook or just don't look at all, are the error messages. Seriously, read the error messages you're getting. I've seen it so often in my courses that students get some error and just go, oh God, I got an error. Screenshot or copy and paste it, Q&A section. And sometimes errors can be really hard to debug or to understand, or you need some experience to find out what exactly went wrong. But to be very honest, often error messages are really clear regarding what went wrong, or even contain a solution regarding how you may fix the error. And last but not least, simply taking an error message and Googling it also often gets you very far, because chances are you're not the first one who's getting it. Now, let's say you're not getting an error message, but your app is not behaving correctly in some spot, or you're not sure if some value is set correctly in some part of your code. A very easy way of looking into your code, of getting a feeling for the values you're working with in code, is to use good old console log. Now, console log debugging doesn't have the best reputation, and indeed it's not that great if you're debugging a very complex problem, but to simply get an idea for the flow of your code or for some of the values you're working with, it's great. You can simply dump it into your code and then find out which value you're using at which point, or how something behaves in a certain situation, or if something is getting executed at all, and therefore this is definitely something you should also do. Now, for more complex problems, or if you really want to step through your code step by step, using the Chrome debugger and breakpoints is a great tool, and it's supported by React Native, both when you're using Expo or when you're not using Expo. There you can really dive deeply into your code and get a feeling for how it works and go through it step by step and look into your code whilst it's getting executed. So let's have a look at these things now. For this, I'm back in this application. We worked on this goals application where we can add some goals here. And this is the code we wrote there. I haven't changed anything in there. Now let me showcase the different things that could go wrong and how you fix them. So let's start simple. Let's say we have a simple syntax error. Here, where we open our modal in the end by setting the add mode to true, let me remove that closing bracket. Now that's a clear syntax error. It's an error we can and we should totally avoid, because we as a developer made a clear mistake. Now the good thing is, even our IDE recognizes this and gives us a warning here, though unfortunately the error it's showing here is not entirely correct. It says that it's expecting a comma. Well, actually that's not the real problem. The real problem is a missing bracket. Still, we get an idea that something's wrong here, and whilst you still need to think about the issue and you can't blindly use that solution, by looking at that code, at some point you should find out that there's a missing bracket. Even if you forget this and you save this, let's say, then the JavaScript bundle will be built here. As you see, I launched this on both Android and iOS, and now we're getting this red error screen I was talking about. And again, here, we can simply read the error message. It's still pointing us at the wrong solution, expecting a comma, but it does point us at the right code line. Here you see it highlights this button title add new goal line. So it still shows us where we should look, and that the issue is probably stemming from this line. We get the same error, by the way, here in this console and also in our Expo DevTools here. There you see the same error message, also with a hint at the line where this error is coming from. So you're getting a lot of help for tracking down this issue. Now here, it's unfortunately still not picking up that I fixed this error, and hence here we see it crashed on iOS. On Android, it's not reloading. Now on Android, we see a command we can use to reload the app. We can click down there or press R twice to reload, but it's still not picking up the change here, even though I fixed it in code. So one solution here is to simply stop the packager and restart npm start. This happens rarely, but sometimes this breaks, and then simply restarting this npm start process is the thing to do. And with that, I'll rerun it on Android by pressing A, and on iOS by pressing I, and now this should relaunch the app on these devices. Again, this will happen rarely, but sometimes it, well, just happens, and you can just restart it to get this back to work correctly. Now with that running again, let me show you an example for an error message you're getting where you don't have a syntax error, but you still have a clear bug in your code. Let's say when we add a goal here with the goal title, we add a check where we see if goal title length is greater than 0 to check that the value is not empty, or actually that it is equal to 0, which means the user didn't enter a title. And in this case, we just return, which means we're not going to add this goal here, and we're also not going to close the modal. So we're just ignoring the user input because it's empty. We might want to show an error message, but for now, we'll just do it like this. Now, when we do that, it will generally work all right here, right? If I save this and we go back here, open this and I click add, you see I can't add an empty goal. I have to enter something for this to disappear. Now let's say in our goal input component where we are fetching user input, where we then forward it by calling on add goal here, we forget to do that. We forward null here, or we forward nothing because we simply forgot to add this here. Now our app starts just fine. It doesn't break immediately because we have no clear error in our code, no syntax error. But if I enter something here and I click add, I get undefined is not an object, evaluating goal title length. And again, this is an error message that helps us. It informs us that the problem has something to do with something being undefined and that it is related to this goal title length check. And then you could dive into the place where you access goal title length and trace down the issue. So we're having problems getting the length of goal title because it's undefined as it seems. Well, we're getting it here, so the error is certainly not here. But let's go to the place where add goal handler is called in the end. Now, if you remember, we're passing this to the on add goal prop here on goal input. So we should probably go to the goal input, which you, by the way, can also do by holding Command or Control and clicking on the component name. Well, in there, we call on at goal here, and oh, here we see what the error is. Now, of course, in this case, I constructed this error here, but you get my point, obviously. This is an error you could certainly have in your code where you forgot to add it, where you maybe changed the way your code works and you forgot to adjust it in all the places, and therefore you're suddenly getting this error. Now, the error message helped us find the issue. Now, that are error messages. We'll get error messages during development, and reading them is a super important thing to do because they really can help us find out what's wrong. Now, let's move on to errors which don't necessarily throw error messages, or where you need to dig a bit deeper to find the root cause. And let's, for example, say that in app.js, we wanted to find out if we're really deleting the right goal here. To find out whether that's the case, we can console log our goal ID here, maybe add some info text like to be deleted in front of this so that we get some information about what's getting printed here. And then we have our list of course goals here. So that's the list without the item being deleted. And then we would want to see it after that being deleted, but the way this set state function here works in the end, the way React updates the state, just printing the course goals again in this line won't give us the already updated course goals. Instead, that will only be updated in the next render cycle. So we'll not see our course goals there, but that's no problem. We just need to log this at a different place. We log this right here in our component. There we log the course goals, and this entire component will be re-rendered when we update our course goals with this line. So this will rerun. So we can maybe just also add a little console log re-rendering component so that we know that the course goal list we're printing after this one is the list after every re-render cycle, whereas the course goal list we're printing after this to be deleted line is the course goal list before we deleted a course goal. And now we added some console log statements that allow us to dive into the flow of our code. With that, if I save this, the app restarts and we already see re-rendering component, which makes sense, it's getting rendered the first time. And we see we have an empty array, which also makes sense because we haven't added anything. Now let's add a new goal, maybe here on Android. Finish the course. If we do that, we see the component re-renders. Makes sense because we added something. And then, most importantly, for the other re-rendering where we added an item, we see that item here in the array. We also see the ID of that item and the value, which looks all right. Now let's add another item maybe. Learn React Native and add this. And we see this here. We also now see that it's an array with 2 items if we expand this here. So we're now able to look into our code. And now let's delete the item by clicking on it. And let's delete the finish the course item with the ID 0.818 and so on. So if I click finish the course, you see it gets removed. So it seems to work correctly. And our console log confirms this. We're re-rendering our array with this ID only, so with the other item, which we didn't delete. And up there we see to be deleted is this ID. Here, this log is coming from this line before we deleted it, so it's still included. But for the next re-render cycle, we see that this ID here is indeed not included anymore. Of course, that's a bit of a made-up example. We, of course, see that that's behaving correctly here. But simply imagine you have a more complex flow in your code you want to debug. Then such console log statements can really help you understand how your code is running, how often it's running, and if the correct values are getting used. So console log statements can really be helpful if you dump them into your code. Just don't forget to also remove them eventually so that you don't crowd your code with tons of console log statements. Now, sometimes console log alone doesn't get you that far. You need more help. And in such cases, you can debug your code remotely. Now, for that, you need to open the debugging menu on these emulators, or on real devices too, if you're working with those. You do that by pressing on the iOS simulator Command D, and it will open this menu here. On Android, you press Command or Control M. And it will open this menu. Now you see some options there, and we'll have a look at the important ones throughout this module. The option we'll now choose is Debug.js remotely. If you press this, a new tab should open up in the browser, which automatically navigated to localhost 1901 in my case here /debugger UI. That should open automatically. Now for this to work correctly, make sure that in your Expo DevTools you have set up the connection to be LAN or local, not tunnel. Otherwise, this will be super, super slow. And now, what this debugger yields you, this new tab, is that you can open the Chrome Developer Tools now with the shortcut you should be seeing here. And there, you now also see the same console log you're getting here. So you now also have another console you can look into, which might be more convenient to work with. Just to quickly show that example with the course goals again, if I console log my course goals here and I save this, this rebuilds, and now we see the array here and we can expand it. So this might be a bit more convenient to work with, basically as you know it from web development, in case you're a web developer. But you can also do more. You can dive into sources, for example, to dive into your source code and set breakpoints. There, simply expand this debugger worker.js thing here, expand these folders, and you'll find the folder structure you're also working with. For example, there, in your users folder here, you find the app.js file, you find the components. So now in app.js, if you open that file, you see your code as you wrote it, so in the uncompiled version, which is great because it's easy to recognize your code there. And now here, for example, let's say you wanna stop the code when you're about to add a new goal, you can add a breakpoint by clicking on the left of the line number here so that you have this blue mark, and now your code execution will stop the next time you hit this code line here. Now, I enabled debugging on the Android emulator, so it will not stop if I try it on iOS. It will stop if I try it on Android. We could have enabled it on iOS too, here with debug remote.js, but I didn't do that, so let's go with Android. You can ignore this warning here. You can simply dismiss it, and now press Add New Goal, and maybe enter Learn React Native. Click Add, and now you see this is getting stuck here, because if you go back to the DevTools, this is now paused. You see, this is now highlighted in blue. It's getting paused. And now the cool thing is you can walk through your code step by step with these controls here. Simply play around with them. And you can also hover over things to look into your code. For example, to see the current value in goal title. Now we can simply progress through these lines step by step with this button. You can step into a function call with this button or step out of it with this button. And you can always resume code execution with this blue play button. This can be a very powerful tool for really diving deeply into your code flow because it allows you to fully understand what's going on, to look into your values at runtime, and to get full control over your code. Now, if you want to learn more about how to use the Chrome debugging tools, you find a helpful link attached to this lecture, which has more information about the Chrome debugging tools. Now I removed the breakpoint here, and now that we saw the debugging tools in action, let's have a closer look at these debugging overlays we can open on these virtual devices or on real devices too. So on Android, again, you open it with Command or Control M, and first of all, I'll stop remote.js debugging. You always need to stop this once you're done, and you should stop it when you're not in need of it anymore, because it slows down your app a bit if it's running. And now let's see which other cool things we can see there. For example, we can reload the app. Simply, reload it in case it got stuck somehow. You can also disable live reloading, which is this automatic reloading when you change something in code. You can try and enable hot reloading, which means it will try to reload parts of the screen that changed without reloading the entire app after saving a file. The default is that it reloads the entire app, and often hot reloading doesn't work in exactly the way it should work, which is why it's not enabled by default. So I'll also go with live reloading here, but you can play around with that. And then we got these three other things down there, where especially the inspector and performance monitor are very interesting. Let's start with the performance monitor. If you enable this, you get this overlay, which basically informs you about the performance you're having. And there you can see at how many frames your app is running, how many frames were dropped, and so on. Now, please be aware that the performance you're seeing here is not the final performance of your app, though, because it's still in development mode. We're not having the debugger attached, but development mode also means that there is a lot of overhead in your code. For example, the overlay you're seeing here, which is part of the app, so to say, which makes your app slower than it would typically be. So this can be an indicator, but it's not the final production-ready testing you should do. Still, it can be nice, here you open it with Command D on iOS, it can be nice to look into this and get a feeling for how your app's behaving and how it's performing, how much memory is consumed, and so on. This can also help you spot memory leaks if this value, for example, is going up and you're occupying more and more memory on the device. Now, there also is one thing in that developer overlay you can open, which is extremely helpful for debugging your user interface, and that's the toggle inspector option. If you toggle this, you'll see this overlay at the bottom here, and now you can click onto items in your user interface to get information about them. For example, here the button. Now you see the margin around the button, the padding, you see its position in the component tree, you see some configuration about the button, and you can also have a look at the surroundings and therefore get a feeling for why things are laid out on the screen they are. You can always close this again by opening the developer overlay and then again clicking toggle inspector. And of course, that's also available here on iOS, where you can also get a feeling for how things are positioned and why they are positioned in that way. However, there is an even better tool for inspecting this. Therefore, I'll close this here. And that's the React Native Debugger. You can search for React Native Debugger, and you should find this GitHub page here. And on this page, you can download the React Native Debugger. You find installation instructions here, and you can simply go to the release page in the end here to download one of these binaries for your operating system. So for Windows, exe file here, the setup file, for Mac OS, a DMG file, and so on. So these are the different things you can download. I'll go with the DMG file to download the latest version here. Save this and wait for this download to finish. And then let me simply execute this and finish up the installation by simply walking through the installer, or in my case here on Mac OS, simply dragging this into the applications directory. And now I can open up the React Native Debugger here. And here it is. Now, it's not working right now because for this to work, you need to enable remote JavaScript debugging on the devices. Just what we did before to debug this in Chrome. Now, this essentially replaces this Chrome debugging experience, you could say, or enhances it. Now, with this opened up, press Command-T on Mac or Control-T on Windows or Linux in here to open a new tab and open and confirm that React Native Debugger port, which the Chrome tab also used before, and confirm this. And now it's trying to connect there, and to make this succeed, open up your developer tools, let's say on Android now, and debug JavaScript remotely. And now this should connect here, and you'll see your console output here now in the debugger tools. You'll also see, if I expand this, that in sources, you can again dive into your code here if you want to, just as before. And the big difference, of course, is not that you can do this, because that's the same you could do in the browser, but that here, you now have the pretty neat tools here on the left. So you can still, of course, set breakpoints and everything, but here, you now for one got your Redux debugging tools, and we're not using Redux here, so they're pretty empty, nothing going on here. But at the bottom, you have this Elements debugging tool. And this allows you to explore your React Native JS Xcode, so to say. So your element, your component tree in this nice user interface, which is definitely nicer than the inspector you could toggle here. Because now here, you really can have a look at what's going on. We can dive into the root component to then find our app component down there. And in there, we find our view with that button. We can click on the button, and we see the props that we're using on the button, like on press, and the title that we set. We can click on our own component where we see the props we're forwarding there. We can even change the visible prop to toggle this modal like this if we want to. So that's really nice. We see the hooks we're using in there, like the state we're currently managing in our component. And if I open that modal here, you see that state, the props here changes. And if I start typing here, like learn React Native, you see that this also updates here on the right. Slight delay, but that shouldn't be an issue. So that's really neat. We can add this and see the state changes here. We can, of course, dive deeper into our goal input to see the modal here. You can explore the flat list and what's configured there, and dive deeper into this view if you want to. It's really a lot of stuff you can do there. And you can overall explore your component tree there to find out what's going on. On elements where you directly added a style, like on this surrounding view, for example, where I set this padding, you can even inspect the style and not just see the style, but also change it. For example, to increase the padding or reduce it. And this gives you an easy way of testing different looks and layouts on the screen to find out what's looking good for you and what you want to change. You can also go to the Profiler tab here and start a profiling session, then do something on the screen like open and close the modal and stop this, and you'll get the default React DevTools experience here where you see which of your components were repainted. You can dive into that to get an idea for what was repainted, which props it had at the time, and how many re-render cycles you had to, for example, find out if there are unnecessary repaints going on. Obviously a bit of a more advanced thing to do, and something you might want to do when you're closer to finishing up your app to make sure you're optimizing performance and you're avoiding unnecessary re-render cycles. But these tools can really be helpful for spotting little issues in your app and for making sure that everything is working in the way it should work in your app. Now, one other cool thing you can do with the React Native debugger, you can right-click anywhere here, let's say here, and you can enable Network Inspect. And if you do this, then you can go to the Network tab and you'll see outgoing network requests. Now, these are all just debugging related requests, but later in the course, when we'll add our own network requests, where we send requests to our own web server, we can even inspect those here and look into them and see if we're sending and receiving the right data. Something which is otherwise pretty hard to do with native apps. Here it's a breeze. So React Native Debugger really is a cool tool for looking into your app, for setting breakpoints, viewing the console, viewing your component tree, viewing the styles you're using there, and so much more. It really allows you to dive deeply into your application code, into your UI, into your logic, and find out if everything is working the way it should work. And you can even go in here and change certain things like the styling, as you saw, to experiment with different settings and find out where you need to tweak your app for it to work correctly. So now we had a detailed look at the React Native debugging experience, at the React Native debugger, at the different tools you have for finding and fixing errors, for analyzing your user interface, your component tree, and so on. Now, there's one type of error which I mentioned, which is the so-called unavoidable error. For example, that you're sending a network request and you can't guarantee that your users have a network connection, or for example, that the server is online. We'll handle such errors later, specifically when we do start sending network requests, because there we'll simply have a better example for when we need that. And there you will learn how you can handle these unavoidable errors too. With the knowledge you gain in this module, you hopefully have a solid set of tools to build applications where you are able to find and fix errors, because you will always encounter errors when you're writing code. There is no way around that. Now, with the fundamentals about React Native out of the way, it's time to dive deeper into what it takes to build real React Native applications and which core building blocks you need there. We'll dive into the heart of building React Native apps, so the core things you gotta know. And that would be components, that you know how to use the built-in components, where to learn more about them, and which important components are built in. And of course, that you also have a clear understanding of how you add your own components and how you use your own components, and how you would build a more realistic app with that mixture of built-in and custom components. And since components alone don't really make up for such a great app, they would look pretty bad, pretty boring. We'll also dive into styling and layouting in this module, because that's another core building block that you need to master, need to know to build React Native apps. You'll learn how to style components, and we'll dive into some more exotic styles, if you want to call it like this. You will learn how to add custom fonts and so on in this module. And I already had a closer look at how Flexbox works in the basics module, and will still, of course, also use it in this module, so you get more practice with that as well. Now, actually, there is a third core building block that you typically work with when building React Native apps, and that's the native API modules you can work with. So things like using maps, the user location, camera, these are all the important tools or features many mobile apps, of course, need, and many React Native apps therefore need. And I will cover this thoroughly in this course, but at a later point of time, simply because we need some more advanced knowledge to really work with these tools. So therefore, in this module, we'll have a look at components, how to build our own components, which important components are built in, how to style them, how to create nice layouts. And in detail, we'll build another app in this module, still not the most complex one in the world, but definitely more complex than the previous app we built. We'll dive deeper into built-in and custom components. We'll add images and custom fonts. And in general, we'll dive deeper into styling and into adding layouts with Flexbox and into, well, building a more realistic app that looks good. So let's get started. Now, to get started, I again have the app running on an Android and an iOS simulator. It's my default starting app, and again, attached you find that starting project which you can work with to have the same starting setup as I do. For me, it's just a new React Native project created with Expo, and this is the project we'll build up on. Now, the important question, of course, is which kind of app do we build here? What is the goal of this module? In this module, we're going to build an application where I want to have a little header at the top, so a little bar at the top, which simply displays the title, which is guess a number, because we'll build an application where you enter a number and the computer, the app, will try to guess it. And therefore, we'll have a starting screen where you have an input for your number, which the user of the app can enter. And then, of course, we'll have two buttons, basically a confirm button here and a reset button here. So two buttons that allow us to control that input. Then a button to basically start the game. So once you chose a number, which basically loads a different screen, you could say, which still has our title at the top, but where now the computer will output a guess, let's say 63 initially. So that's a guess from the computer, which you kind of output in a nice way here. And then you have to tell whether the actual number is lower or greater than what the computer guessed here. So you got two buttons to control this. We want to show an alert if you give the user a wrong hint. So if your number is lower and you say greater, then I want to show an alert where we say something like don't cheat, anything like that. So a little check in there. And once the computer guessed the right number, so once the game is over, basically, we'll have a game over screen here where we say something like game over, where I then want to output an image here, maybe such a rounded image, like some goal image, a summit, something like this. And below that, we'll output some info text, like the computer guessed your number 15 in 10 guesses. So basically a summary. And also a button to basically restart and play a new round with a new number. So the nice thing about this application is that whilst it, of course, isn't overly complex, there aren't tens of dozens of screens involved, but whilst that is the case, we have a lot of different components, which we also can style and lay out. We use an image, we'll use our own custom fonts, and we have also quite a bit of business logic in there to control the guessing, to check whether the correct number was guessed, and so on. So it's a really nice app, a really nice second step, which will make sure that all the basics are super clear and set after this module, so that you're more than well prepared for more advanced applications after this great application here. So with that, let's get started with our application here. And there are various ways of getting started, of course. I want to get started by first of all dropping this container style here in my starting screen, and instead I want to get rid of the text and everything here, and I want to start by adding my own header, so this bar at the top of the screen. Now, we can build such a bar on our own here, get rid of that import, which we don't need. And I will build it not inside of this app component, but in a separate component file, in a separate custom component, because, and that's already one super important thing to take away, just like in React for web apps, it is a good practice to split your app into multiple components, which you then compose together, because that leads to more manageable and reusable code. So I'll add a new folder, components. The name is up to you though. You can name that folder whatever you want. And in there, I want to have a header.js file to hold the header component. There, we need to import React from React so that we can, well, use React in there and write JSX code. And then we'll also need some components from React Native, because you must never forget that these are the only core components you can use in the end. You can't use any web HTML elements or anything like that. You need these core primitives React Native gives you. So we'll definitely need a view in here, and also a text component, and also a style sheet component. And now with that, we can get started building our header. So for this, I'll add a header constant which holds my functional component, because I'll work with functional components only in this course. We'll use hooks in places where we need to manage state or side effects. And here we will, of course, export this component in the end, and also set up a styles object with style sheet create so that we can style this in the end. Now let's create our component here. Let's return something here. And what I want to return is in the end a view with the text inside of it. And the text should be our title. So therefore, between the opening and closing text tag here, I will output props title so that our own component can receive a title prop and output this here. And the view surrounding the text will be used for positioning the text and for giving this some styling. So for styling our header, because text elements on their own are also stylable, but not to the same extent like views are. Views really are a bit more flexible regarding the styles you can assign and regarding how they behave. And therefore, you always want to use a view for such a surrounding container for this overall styling your component might have, or parts of your component might have. So here I'll add the style prop and assign a style from my styles object, a style we haven't created there yet, but I'll name it header. And I'll also give the text a style prop though, and point at styles header title or whatever you want to name it, because as I said, you can style text too. And here I want to have some text specific styles later to also make sure that the text looks good. So now here in the style sheet, we can start styling our header, and I'll start with the header itself by adding a header prop. And then this object will hold the style definitions for the header, so for this view component here. And there, of course, you are free to experiment with whatever you want. I'll go with a width of 100% so that it takes the full device width we can get, or the full width of the parent component to be precise, but I'll add it such that the parent component takes the full device width, and therefore this will also take the full device width in the end. Assign a height, and there you can experiment with different values. I found 90 to look quite decent, and therefore I'll go with that. Side note, for now I will optimize for these screens which I have here. In the next course module, we'll dive into how you can adjust your views and your code for different devices, both regarding their size as well as regarding the platform your code is running on. For now, we'll not have any differentiation there. We'll just tune our app to look good on these two emulators. But again, I'll pick up on this later. So height of 90, a padding to top of 36 to have some spacing to the top. And I need to add this to basically cope for things like the status bar here or this notch here. So therefore I add this padding top. And I also want to add a background color here. And now you are, of course, totally free to pick any color you want. I prepared a nice color, a hex code of a color, which I personally like. And that is hash symbol F7287B, which is quite a nice color in my opinion, as you will see in a second. Now I also want to center the title, and therefore I'll use align items and justify content, because every view by default uses Flexbox, and therefore with align items and justify content we can control how the child elements of the view are positioned inside of the view. And with center for align items and justify content also set to center, we center all children or the child element inside of the view in, well, the center both horizontally and vertically. Now for the header title, I also want to set up some styles for this. So the header title here, well, that should get a color of black, because that will fit this color here and so that we can read the text. And I want to set the font size to 18, let's say, so that we have this fixed, a bit bigger font size here. With that, let's try using this header, and let's use it in the app.js file here. There we have this view, and this view has no style attached. I will change this and set up a screen view here and give this a flex of 1 attribute. Now we can assign this here, and flex 1 will ensure that this view takes all the space it can get. And since it's the root view of our application, that means it will take all the width and height it can get. It will occupy the full screen. And therefore, since my header takes width 100%, since I'll add it directly inside of this view, which is now configured to take the full width and height, this header will also take the full width. So now we just need to add the header here, of course. So import header from /components header. You can omit the file extension and then simply add header as a self-closing tag here. But don't forget to set a title prop, because remember that we're outputting the title prop here between the text tags. So we can add a title here. And I'll name it guess a number, because that's what our game is about. Now if we save this, it should automatically rebuild, and you should see a header that looks like this on the iPhone and like this here on Android. And I'd say that's okay for both devices. Again, we'll later explore ways of how you can fine-tune the look to the specific device your app is running on. So now that we got a header, we can continue with the part where users can enter a number which the computer should guess thereafter. And for this here in the app.js file below the header, I of course want to have the input area of the user. Now, just as before, I'll handle this in a separate component and not here in app.js to keep all components relatively lean. And we could create this component here in the components folder. That would not be wrong. But since I now will work on a component that essentially is responsible for everything we see on the screen besides the header, I treat this component as kind of a special component. I'll name it a screen, and I'll store it in a screens folder, because the finished game will essentially have 3 different screens: one for configuring and starting the game, one when the game is running, and one when the game is over. And I want to have these special components, which technically are totally normal components, but which fulfill a special purpose. I want to have them stored in a separate folder. And that's just my personal design decision here. You don't need to store them there. Technically, there is no reason to do it or not to do it. React Native simply doesn't care. So here I'll store it in there, and I'll name this startGameScreen.js to also make it really clear in the name that this is a special component to me. But as I said, technically it's a normal component, and therefore we import React from React, and we'll also import some things from React Native, of course. And we can already tell that we'll certainly need a view, because, well, you probably can't build any component. Well, you can, but not that many components which you can build without views. So we'll import the view here, and we'll definitely also need a style sheet for some styling, and we'll see what else we need. We'll certainly also need a text, I guess, so we can already add that. Now with this, I'll create a new constant here, start game screen, which is a functional component looking like this, where we'll have a styles object with style sheet create, like this, and where I then export start game screen like that. And you could save this as kind of a template for any new component you add, because 90% of custom components you build in React Native look like this, basically. You import React, you import some stuff from React Native, you define your component, the name differs, of course, you have your styles object, and you export it. That's pretty much always the same, so you could kind of save this as a template if you wanted to. I don't want to here, though, so I'll just continue with working on the component itself, and the question now is, what do we render in this start game screen? How should it look like? In the end, in there, I'll have a wrapping view surrounding my entire screen, because I think that kind of makes sense, allows us to set up some general styling. I'll again add a screen property here to this style sheet object, which I can do. It will not clash with the one in app.js. We could have also chosen different names. These two are simply not related because these are independent JavaScript objects in the end, managed in independent files. So we can repeat names here or choose different names. I'll go for a similar name here, name this screen, and set up some general styling for this surrounding view here. The general styling is that I set this to flex 1 so that it takes all the space it can get, which means that since I will add it below the header, it will take all the space below the header, both vertically and horizontally. And besides this, I also want to add some padding here of 10 so that the content doesn't sit directly on the edges of this screen, but there is some spacing to the left, right, top, and bottom. And I'll add align items center. Keep in mind that every view by default uses flexbox and by default uses flex direction column. Align items positions items along the cross-axis. So since the default direction is column, the cross-axis is left to right. So it's a horizontal axis. So this will align items in the center horizontally, but not vertically. There we use the default of justify content flex start. But since I use the default, I don't need to set it. So we'll just leave it as it is here. And now assign this style here to this view. And auto formatting closed my tag here, which I of course don't want to do. So let me revert this. And now we have that view for our game screen. Now to see where it works, I'll just output some text here, the game screen, just some dummy placeholder. Reformat that, and now in app.js, let's use that screen by importing start game screen from the screens folder, and there start game screen. And then simply add it here, like this. If we save this, we see the game screen here and also on Android. So this works. We're using this second separate component, which we'll now use as a full screen component, basically, or almost full screen, the part below the header in the end. Obviously, this screen right now isn't that useful, and therefore I'll now go to that text, which I used as a dummy, and replace it with, let's say, start a new game, something like that. And below this, I want to have an input area with a slight drop shadow. So this typical card look you might know from some apps and websites where you have a box with a slight drop shadow behind it, maybe some rounded corners. I want to recreate that here, so I'll add a view here. A view because, again, that is a very flexible element. We can apply a lot of styles there. We can add our shadow and our rounded corners there and then hold our content in that view. So that's great for having the general styling of the container. And now inside of that view, I want to have a text where we say select a number, for example, and where we then also want to have a text field where users can enter something. So there I'll add a text input component, which is that built-in component where users can use the keyboard to enter a value. And here they should enter a number. We'll configure this and style this in a second. For now, I'll just drop it in like that. And below that, I want to have two buttons sit next to each other. And that's important, next to each other, not below each other, which allow us to reset the input and choose a new one or confirm the chosen one. So we need a view here because that allows us to position items next to each other, whereas these items are positioned above each other then. Because if I would just add two buttons here, then I would have to change this view's flex direction to have them next to each other. But then the text and text input would also be sitting next to each other. So now I'll add a view here so that in this view, the surrounding view, This and this view component are sitting above each other, so on the vertical axis. But inside of this view, I can now also make sure that the items in there then sit next to each other, so on the horizontal axis, and that's what I want here. So I'll import the built-in button, which is one of the view components that automatically adjusts itself to the underlying platform. Later, in a separate module, you will learn how you manually can find out on which platform you're running to adjust the look and feel of your app to that. Here we'll go with the built-in button and give the first one a title of reset, and the second button here, a title of confirm. And then here on press, we'll at the moment do nothing, so that's just an empty function, just adding it so that we have the prop already there. We'll add logic later, and for now we'll just have the buttons here. Now the styling will be missing though. As I said, the buttons should be sitting next to each other, hence I'll give this view here, which holds the buttons, a style pointing at the styles object, and there, let's say, a button container. This name, as always, is totally up to you. And I also want to give this view, which holds my inputs, a style. Here, referring to the styles object, and I'll use the, let's say, input container. This name, of course, is also up to you. And this here, I want to style this like a special title, maybe with a bigger font size. So here, I'll assign a style of title, let's say. Now we can go down there in our style sheet and add the title. Add the input container, and also add the button container. And now we can start adding some styles there. Now for the title, again, I want to set the font size. So I'll set font size like this, set it to, let's say, 20. And maybe also add some spacing on the vertical axis with margin vertical of, let's say, 10. 10, like this. And always keep in mind, margin vertical basically replaces margin bottom and margin top. And now on to the button container, and I'll come back to the input container in a second. The button container will get a flex direction of row. The default is column, but now I want to have items sit next to each other, so we need to use row here. I want to set a width here, because if we don't set a width on the button container, it would just be as wide as the two buttons are together. Instead, I want to use the width of the parent, so of this view here, and then position the buttons inside of this view. So I want to do the opposite, not style the view according to the buttons, but position the buttons according to the view. So I'll give the button container, this view, an explicit width here. And now to position the buttons in there, we can use justify content to position them along the main axis, which for flex direction row is left to right. And there I'll choose space between so that the buttons sit on the left and right edge of this row and distribute all the available free space between them. Also add a little bit of padding horizontal here though, so that we have some spacing to the left and right inside of our view, maybe 15, so that the buttons don't actually sit directly on the edges on the left and right, but there is some spacing on the left and right. Okay, so with that, if we save this, we see that, which I don't know about you, but which doesn't look that great, does it? Now the problem is that the input container has no styles yet. The input container holds all the inputs though, which is why the stylings there look a bit off. So we should give the input container some styling, and there I want to add a width. And you can now use a hard-coded width of, let's say, 300 pixels, or use a width in percentage. Now I'll add a width here of 300, but also add a max width of 80%, so that we have 300 pixels width. But if the device would be too small, so that's a little bit of responsiveness, which I add here already. If the device would be too small, we make sure that our width doesn't exceed 80%. And then I want to align the items in the center. Keep in mind, the input container is a view, therefore it uses Flexbox. It uses the default of flex direction column, and therefore with align item center, we position items in the center on the cross axis, which is left to right. So we center items horizontally. With that, now this looks way better. can't really see the input, but that's the old thing, right? We'll have to style it so that we can really see it. We see the buttons though, and we can see that our general layout and styling is taking some shape. Still, I'm not 100% happy about the look of this yet. There are a couple of things where we could continue, but I want to continue with the input container, which is the container around these inputs. So around the selected number text, around the text input here, and around the buttons. And this container has a width and it aligns the items, but as I described earlier, it would be nice to have that card look there. And for that, we need some more exotic styles, which sounds really fancy, but simply some style rules we haven't used before. For example, I want to add a shadow, a slight drop shadow. You do this with 4 core properties which you can use. A color, an offset, an opacity, and a radius. Now a shadow color should be clear, it's the color of your shadow. Shadow offset is how much it's offset from your container, and that actually takes an object which then in turn takes a width and a height. So you could say I want to offset the shadow by 2 pixels regarding the width and by 2 pixels regarding the height. That influences the 3-dimensional effect you're creating. Opacity describes how transparent this shadow is. If you set opacity to 1, then you have a totally intransparent, so a very visible, strong shadow. And if you increase that, or decrease that I should say, if you set this to 0.1, for example, you have a shadow which you can barely see. Shadow radius then basically describes how sharp that shadow is, if it has rough edges or if it's a bit more blurry, softer, things like that. So here I'll go with a shadow color of black. By the way, you can also use hex codes here if you want to, and you can also use RGBA codes if you prefer this, either normal RGB codes actually, or also with an alpha channel to describe transparency here, though the transparency here won't have a direct influence. For a shadow, you will have to set this with shadow opacity. For other colors, it would have an influence. But that's just a side note. Attached, you find a link with more details about how you can configure colors and which color values React Native accepts, because obviously that's way more exhaustive than what I can show here. I will just go with the name because, well, I want a black color, so why not go with that shortcut? Now, besides the color, the shadow here will also receive an offset. And as I said, offset here takes an object. Now, in case you wonder how I know this, for one, my IDE tells me. If I start typing shadow offset here, you see that hint I get on the right. You should normally be getting this as well. But in case you don't get this, the official docs are of course the place to go, and they are always under guides, components, and APIs. You can click on the view component there, or simply click on the API docs here in the top right corner, and then choose your view there. And there you'll find some style prop, and then you can find a list of all the view styles that are supported, and of course also how you configure those. And there, for example, you learn that shadow offset is an object with a number and a height. For the color, you learn that this takes a color, and that's exactly the link you find attached here, where it's described which kind of colors you can use. So that's just a little side note. Here, I'll use a shadow offset with a width of 0, but a height of 2, so that my shadow is offset a little bit to the bottom, so to say. Not so much to the right, so not at all to the right, actually. And I'll then also add a shadow radius, which is a number of, let's give 6 a try and see what that does. And last but not least, a shadow opacity of 0.26, which is relatively transparent, but which I think looks quite nice. In addition, I'll give my input container a background color of white to make sure that it's always white and not transparent, which is otherwise the default, so that if we would have another background color behind the container, let's say as the base color of the entire screen, the container here would always have a white background. Now with that, if you save this, you should see a shadow that looks something like this on iOS, but you see no shadow at all on Android, and that's not a bug. Instead, the shadow properties here only work on iOS. And that leaves one important question. How can you set a shadow on Android then? Is that not possible? It is, but there you have a special style prop, the elevation prop. This only works on Android, as the tooltip also shows here, platform Android. whereas the shadow properties only work on iOS. Now, elevation simply takes a number of, let's say, 5, and then use the default Android material design elevation. So you have less control there, but on the other hand, you get the default material design looks, which your users might be used to anyways. So that's the good thing about this. And now we also have a shadow here on Android and on iOS. On iOS, you will also notice that the shadow is visible on the left and right of the box as well, even though I gave this a shadow offset of 0 for the width. That can be controlled with the shadow radius, though. If you set shadow radius to 0, then you see you only have the shadow where you defined its offset here. So you can make sure that the shadow really is only there where you want it. If you do set a shadow radius, though, and by default there also is a default shadow radius, you get this spill effect, which is a more natural shadow after all. So here it's actually the effect I want. Now with that, I added a shadow both on Android using the default Android shadow and on iOS. By the way, on Android you can of course change the elevation level to play around with different levels of elevation until you have the look you want for your application. You have enough shadow basically. Now besides having the shadow here, however, I think it would be nice to have some padding in this box now, because the items sit way too close to the edges. They sit directly on the edges after all. So to change this, I'll also add a little bit of padding here. And that will be a padding of 20. And again, that's a value you can experiment with to find the padding that you personally prefer and you think that looks good. And if we try that, now this looks way better. In addition, rounded corners would be a nice thing. So I'll add a border radius here of, let's say, 10 to have slightly rounded borders. If we now save that, this looks pretty sweet to me on both platforms, on both devices. So this is now the input container. We can't see the input, and the buttons probably should have the same size as well, but at least the container is now looking good. Now, with that input container defined, and with a couple of new styles covered therefore, we can do something which I mentioned that it would always be a good idea. We can split our application into multiple components. This look here, this input container look, this card look, is probably something we want to use in other parts of the application as well. We might have different items which we want to present in such a card. Consider you're building an online shop where you have each product in such a card on the overview screen. Now, to avoid repeating this style definition over and over again, we can outsource it into a separate component. A component that doesn't really have much logic in it, but which controls the styling of its content. A pure presentational component, therefore. Technically, it still is a regular React component, and hence I'll create a new file here in the components folder and name it card. Name is up to you, but it is this typical card look, so it sounds like a fitting name to me. Now here, as always, import React from React, and then also import the view from React Native here, and then create the card component, a functional component like this, which you in the end export as a default. And obviously, since it's all about presentation here, we'll need the style sheet to create a styles object, because that will be the core thing of this component. It should be there to wrap itself around any content and just apply some general styling. So now I'm going to the start game screen, and I'll grab all the styles here of the input container, copy them from there, and add them to the card instead. Here I'll add a new card property and use my styles in here. And inside of the card component, I'll have a very simple markup, so to say, very simple JSX code. It's just a view which I return here, which should be wrapped around props children. Props children is that special prop in React, which is basically the content you pass between the opening and closing tags of your custom component. So it can wrap itself around any content, because the only goal of this card component is to apply some style to the surrounding container. And we do this by adding styles card here. Now there's just one thing. There are certain styles in here which probably should not be set from inside of the card. Not every card might have this width or max width, and not every card should center its content. Hence, I'll cut these 3 items from there and only have the shadow and the padding set up in here. And I want to make this a bit more flexible. Besides the card styles, it would be nice if we could also assign our own styles from outside and maybe even override some of the card styles. We can do this by passing in a new object to the style prop and distributing all the properties, all the key value pairs of our card style here into this new object. This is the spread operator, a modern JavaScript feature which pulls all the key value pairs of an object out of that object and adds it to a new surrounding object. So we copy all the styles defined down there into this new object. And I'm doing this so that I can also add another key value pair here, or another set of key value pairs, where I take all the styles defined in props style, so in the style prop I pass to my own custom component, I take all the key value pairs defined there and merge them into this object. And since I do this second, this will override any key value pair set up in styles card, so that we can override any style set up in there from outside when we use our component. And when we add additional styles outside of the component, it will also merge that in and consider it. And with that, we can also assign our own styles from outside of the card component when we use the card component. And using the card component is something that would make sense as a next step. So let's go to the start game screen and import card from the components folder and there from the card folder, and replace our input container view here with card like this. Just like this, with opening and closing tags. Now again, I want to set my own styles. I want to set my own width, max width, and align items. So I'll keep input container in the style sheet down there, but now get rid of all the other styles in there, all the styles which are now set up in the card, so that we only keep the width and alignment here. And then add this here to card on the style prop, which is accepted or which has an effect, because in the card component, it's that style prop which I merge with my other styles. So for that style prop, I'll point at styles input container. Now with that, if we save that, I'm getting an error. Object is not a function near React Native style sheet. So in the card.js file, as it points here, something's wrong. Even gives me the line number. It's line 10. That's what this number here means. And yeah, my problem here is that I use style sheet like this. That's wrong. Instead, we have to call stylesheet.create to define our own styles. So that's the right syntax. So it's a syntax error. Not technically a syntax error, but I'm using the stylesheet object incorrectly. So it's an error from my side. The error message helped us with that. And now we have the same look as before, but we have that reusable card, which we can now use in any place where we want to have, well, exactly this look with the shadows and so on. Now we have the card look. Now, as a next thing, let's fix the buttons. And that's something I already showed you. So definitely your chance to pause the video and do it on your own. I want to make sure that the buttons have the equal size. They shouldn't take the full available width, but they should have an equal size, which makes sure that the text fits in there and, well, that they're equally sized. So your chance to pause the video. Thereafter, we'll do this together. Were you successful? Let's make sure the buttons have the same size. And for this, in the start game screen where I have the buttons, you learned that the solution is to wrap the buttons in a view. So you have to add your own view component around the buttons. And now you can assign a style to these buttons, so to both buttons here. And I'll use a button object in my styles object down there. So let's add a button here and simply give that a width. And here a width I'll choose is, let's say, 80. Let's see what this looks like if I save this. A bit too small as it seems, since there is a line break in this button. So let's go with 120. Now that's certainly too much. So how about 100? And that looks pretty neat to me. Now in addition, and that was not a task for a user, no worries if you didn't do that, I want to change their colors. And one of the colors should be our main color. And I also want to set up some accents, some secondary colors, so to say, which we can use. So for that, back in the Start Game Screen component, on the button itself, there is a color prop which you can set to control the color. And for Android, that's the background color. For iOS, that will be the text color. And now the reset button, there I want to set up a color of #717FC. That's a nice color, I think. And for the main button, the confirm button, I'll use my main theme. And I want to use the same color I used in the header. So there I have this hex code used as a background color. I'll use the same color here for this second button now. With that, we can save this, and now we got these two button colors here, which looks quite nice in my opinion. Now, one downside of this approach, or one thing we can improve, is that I'm using this hex code here, I'm using it in the header, and chances are that later in the app we want to use the same color in other places too. So it would be nice if we could set this up as kind of a theme, you could say, that we could easily use these colors without copying hex codes across our app, and that we can also change the color in one place if we ever want to use a different color, and we don't have to do that in dozens of components. And for that, I'll use an approach where I'll add a new folder on the root level, and I'll name it constants, and as always, you can name these folders whatever you want, and in there I want to have a colors.js file. Again, this name can also be named whatever you want, because what this file will do is it will export a default JavaScript object. So it will export a JavaScript object, and in there you can have any key value pairs you want, and I'll set up a primary color, so just primary as a key name. And this should be this hex code which I just copied, so this header color also. And accent or secondary, whatever you want to name it, I'll go with accent color. And that should be this other color, which I used on the first button, so this hex code here. I'll use that in here. Now these colors are defined here, and we can now simply import them from this file, and whenever we change them here, they're changing everywhere in this application, and we can therefore easily swap this during development. So now in the Start Game screen, we can just go ahead and import colors from constants colors like this. And I gave this a capital C here to kind of indicate that this is a collection of values. You can name this whatever you want. You can also use a lowercase c. That naming doesn't matter. And now you can use colors here to assign your, well, colors. So for this reset button, we'll now use a dynamic value so that we can reach out to colors.accent. And here for the main button, for the confirm button, I'll go with colors.primary. And the same in the header. There, of course, we now also want to use that color and not hard-code it in here. Instead, import colors from constants colors. And with that imported, you can also use it in the style sheet, not just in JSX. You can use it anywhere in that file after all. So now here I'll also refer to colors.primary. And if you save that again, we have the same look as before, but yet again in another more elegant way, where if you ever decide that your accent color should not be this color but should be blue, you just swap it here, your app is rebuilt, and you have a blue button. So that is the huge advantage of managing your colors or other core constants in such files. You could have another file named text, for example, where you have some core font sizes, or another file spacing where you store default values for margins or paddings so that you don't manually have to use the same values over and over again. These are all approaches you can use to make your life as a developer easier and to have code where you can quickly swap values if you need to. For now, I'll just manage my colors in there because that's one of the things that is most annoying to copy around, and it's a really great approach, therefore, to manage it in such a file. So, step by step, we're making progress. What we're not able to do is enter a number. Well, I guess technically we can enter a number if we kind of find the input field. Here it is. But it's not much fun to search for it. Would be nicer if you could see it, wouldn't it? So therefore, let's style that input field, that text input field here a little bit. And just as before, actually, I want to do that in a separate component. So in the components folder, I'll add my own input.js file. And in there, as always, import React from React, and then import text input from React Native. And here I'll actually not need the view because we'll just have the text input here and style and configure that in there. And then have the input constant here, which is our functional component, which we in the end also export, of course. And, well, one thing we'll need for sure is the style sheet, because that should now be styled here so that we have one default input look we could reuse in this application if we needed multiple inputs in different places. And that's really the mindset you have to get into. Create reusable components so that you don't have to copy code around or repeat yourself, but that you can easily share your components and easily create the apps you want from your set of building blocks you create on your own in the end. So here my styles object with style sheet create, like that. Looks good. And now in that component, I want to return a text input, so this built-in text input. Now, of course, my idea is that we can style it from in here. So let's assign a style from in there. But just as with the card, it would be nice if we could also set some styling from outside, like a special width or a special border, anything like that. To enable that, again, I'll pass our object here to style. And for one, take all my styles set up in my styles object. And there, let's say, in an input property, which we have yet to add. And in addition, also add all styles we're getting from props style, so that we could set styles from outside as well. And now down there in the style sheet, we can add the input style to, well, assign some styles to the input. So here we could give this a height of, let's say, 30, which should be a height that looks relatively good. And to see something, I also want to add a border at the bottom. You could also add a border around the entire input with border color and border width and so on. But I like that look where we only have a border below the input. But that's, of course, totally subjective and something you can set up according to your personal preferences. A border at the bottom only can be set with border bottom color, and there I'll go with gray, another pre-built color which we can use with that shortcut, and give this border bottom also a width here of 1. Add a margin vertical of 10 to have some spacing around the input, at least to the top and bottom. And now with that, the base styling for this text input is done. Now let's use that in the game screen. So in there, I want to import my own input from the components folder, input, like that, and replace this text input here with my own input, which in the end wraps this built-in text input, of course. So use my own input, get rid of the text input import up there, which we don't need anymore. And now if we save this, we see it a little bit, but it's very, very small. You can barely see it here on iOS. And it gets bigger as you type, though, which is certainly not what we want, of course. We're, of course, not done. Instead, to style the width, I'll go to the Start Game screen, so to the place where we use the input, and set up the styling here. Because for me, it makes sense that we have some general styles, which we always want, in the input component, something like the height or the border. But some specific styles, like how big should it be, so how broad should it be, that's something you want to set up in the place where you actually use it. And therefore here, I'll add this input property in the Start Game screen style sheet object, and maybe use a width of 50 pixels here, that should look good. And assign that to my custom input here with the style prop. So there we can now point at styles.input. And with that, it will be having that width at all times. And if we type there, we don't make that broader anymore. Instead, we can then simply scroll automatically in that input. Now for this specific input, for this specific layout here, it would also be nice if the text would be centered, I think. For most inputs, you want that default behavior of writing from left to right and starting on the left edge. But here I think some centered text would be nice. And therefore, in Start Game Screen, where I want to have this centering here, on this input, we can also add the text align property and set this to center. And now this will center this text here in the middle as we type. And that's really nice for just entering a number then like this. Speaking of that, right now we can enter anything in there. So we certainly need to configure this input. And for that, if I go to the input component where we use the text input, there is a lot of stuff we can configure there. And actually the best resource, as always, of course, is the official documentation. There in the API docs, if you go there and you search for the text input, you'll find not only an explanation, but you'll also find all the props you can set there. And you can set things like, is it multi-line or not? How long may the text be? You can also set a placeholder text. You can set auto-correction and all that fun stuff. So definitely check these docs to find the specific property you might need for your use case. I want to be able to set these props, but I want to be able to set them from the place where I use my custom input. So not from in here, because that would make sure that we use the same configuration for all inputs we might have in our app. I want to have more flexibility and just set up some base styling in here and configure the input in the place where we then use it instead of in the core wrapper component. The cool thing is React, and that's not React Native, that's just React and normal JavaScript, has a syntax for that. You can take your props you're getting and spread them on your component like this. The syntax might look a bit strange, but what it in the end does is it takes all the props you have, all the props you set here, and basically adds them to your component as props. Now, if you thereafter define other props like style, and you already got a style here, this style will override the style you got here. And that's actually what I want, because if I set a style prop on my own input from outside, I definitely want to override it with this style prop and add this styling which is set up down there to this text input. But if you set other props outside of this component, so on my custom component, then they will be added to the text input. And that allows us to add all the props we can add on the text input also on our input, so on our own component. So here where we use input, we can now not only add the style, but we can also add blur on submit, for example, to make sure that when we press the submit button there, we lose focus and we close the soft keyboard. We can set auto capitalize to none, which is one of the allowed values there. If you check the docs, you can set it to none, sentences, words, and so on. So I don't want to have capitalization turned on here because we'll just enter a number, but also because I want to show you different configurations you can set. I'll set autocorrect here to false so that we're not autocorrecting the user input. And very important here, I'll set the keyboard type to numeric so that the user has to enter a number here. I'll set the max length here to 2 so that you may only enter 2 digits and not a very long number, because this game here, it's just one of the restrictions I have here, is that this game only works with a 2-digit number. With all of that set up, now if you go back and I toggle my soft keyboard, you see you get that number keyboard here, and you can only enter 2 digits there and not more than that, which is of course exactly what I want. In addition, here on Android we see this, if you click the confirm button, this will close it. That's thanks to that blur on submit thing. On iOS, such a button doesn't exist here, so there we'll actually have to find a different solution for closing this if you tap somewhere else, for example, because right now that's not happening. But the good thing is we now have a keyboard we can see and a keyboard where we can enter numbers. One thing I want to change though is that right now I can also enter a decimal separator here. Now to get rid of that, you can change the keyboard type to number pad. And to see all available keyboard types, as always, the official docs are the place to go. There for the text input, you can dive into keyboard type and find out what you can set, what works on all platforms, and what you could set if you would have a check that checks on which platform you are running the code, which we haven't learned about yet. Number pad is supported on both platforms though, and if you set this, you now have an input where you can't enter a decimal place here. If you type in here, you can't do it on iOS. On Android, you unfortunately can though, so there we'll also have to find a different fix. Now we started working on the input and it doesn't look too bad, but we want to make sure that users can only enter numbers that are digits only and that we can't enter a dot here or a comma or paste in some non-numeric content. And for that, we of course need to validate what the user entered here. Now for validating what the user entered, I want to, as I showed it before already, basically save the value the user entered on every keystroke and feed it back into the input. But after every keystroke, I also want to validate the input to make sure that we're having a valid value there. So basically a number. For that, first of all, we need to manage some state here in the start game screen. So I'll import use state. And then up here at the beginning of this component, I'll set up my use state call. So register some state. And that will be the entered value. And even though that will be a number later, technically it is a string at the beginning because all input is just a string and you manually have to convert this to a number then if you want to. I will also add a set entered value function here. The second element we retrieve from that array use state gives us. And now we can add a constant here, which I'll name number input handler or whatever you want to name it. This will get the input text. And that's the function, because that's just a function I'm storing in this constant, which I want to connect to my input. And there to onChange text, point at the number input handler and feed the value back in. And that's our entered value. Now, normally we would just say set entered value in here and set the input text to be our new entered value, which we feed back into the input. But here, I'll actually, first of all, validate the input. So what I'll do here is I'll not set my entered value right to the text here. Instead, I'll set it to my input text where I replace, and I can call replace because input text will be a string, and that's a normal JavaScript method that exists on strings, where I replace some content based on a regular expression. Now, regular expressions can be scary, but that's a simple one. We create it with 2 forward slashes. And in there, I'll add square brackets. And basically with this expression say that I'm replacing anything that's not a number 0 to 9, so not a number, globally in the entire text. So that means it will not just look for the first hit basically, but it will search the entire text. I will replace that with an empty string. So I'll basically drop any non-number value. That's what's happening here. And that's what I store in my new state. With that, we should make sure that the user can't enter anything which is not a number. So let's check this here on Android. If I press the comma, you see that instantly gets removed. And that's exactly what we need here. We only allow number values. So that's a little bit of validation we have in place here. It's not all I want though, but we're still not done with the input. Because on iOS, if we are in that input mode and we want to close that keyboard, right now that's not really doable. We can't click outside and close it, and it would be nice if we could. Now, to make sure that we can and that we close the keyboard if the user taps somewhere else, I will actually wrap the entire view here with a special component provided by React Native, and that's the touchable without feedback component. So a component that allows us to register a touch listener without giving any visual feedback, because that's exactly what we need here. We can wrap our entire screen with this. So our entire view can be wrapped with this touchable without feedback listener, so that in there or on there, we can now register or listen to the press event. And when a press happens, I want to dismiss the keyboard. And for that, React Native gives us a useful API we can import from React Native, and that's the keyboard API. That's now not a component, but that's an API where we can interact with the native device itself, so to say, in this case with the keyboard. And here, upon a press of this button, I want to fire a function, and here I'll go with a simple inline function, a short anonymous function. You could, of course, also use a named function instead. But here, all I want to do is I want to call keyboard.dismiss. That's a function this keyboard API, which we're importing from React Native, gives us. And this does just what the name suggests. So that now if we tap here, we can type, but if I tap somewhere else, we dismiss the keyboard And that, of course, happens on both platforms. And I think that's a better user experience because that's what you would expect, that you close the keyboard if you tap somewhere else on the screen. So we spend some time on the input, but handling user input is important. You want to do it in a way that feels natural to the user, that makes sense to the user, and where you never trust your user and you always validate what the user enters. And we'll dive deeper into this whole validation thing, user input handling thing later in the course, where we also accept more complex input than a simple number. But for now, this was a great first look at how you can style such an input and how you can make sure you get the data you need. With that, I don't know about you, but I think it's time to also progress with our game because we're kind of stuck here. These were all important steps, but we're not really progressing with our game or with our app here. So let's make sure we do that as a next step. And for that, why don't we make sure that our buttons do something? Let's start with the reset button real quick because that will be a simple one. When you press it, I of course simply want to reset the entered value. So I'll register a new function up there in the start game screen component, name it reset input handler. And that's just a naming convention I like. Name these functions which are triggered upon a user event something handler at the end, just to make it clear that these handle certain events. It's not a must do, just a preference I have for React apps in general and therefore also for React Native apps. This will be a function which then calls set entered value, which is our state setting function here, to update the state we feed back into the input, and set this to an empty string. And with that we can connect this to the reset button here. On press should now simply execute the reset input handler like that. Let's give it a quick try. Let's enter something here, reset, and it's gone. That's looking good. And also make sure that this button here, the confirm button, does something. For that, I'll add another button, confirm input handler. And we could simply start the game immediately here, but also just to practice this, I want to give the user one final chance of changing his choice. So here I just want to kind of output, this is your choice, do you want to start message, where then the user gets a button to start the game. Just an extra step so that we have some extra practice here. For that, I'll add a new state, which manages the has the user confirmed yet state. And initially that is false, but of course we can change this. And we want to be able to get the current state. So here we get whether the user has confirmed or not, and we can set this confirmed state with that second element in the array we're extracting. So down there in confirm input handler, I set confirmed to true. On the reset input handler, by the way, I set this to false because if the user clicks reset, the user certainly hasn't confirmed the value, so we should reset this. And then here in the confirm input handler, I also want to do two other things. One is reset the entered value, but also, of course, save the entered value as the value with which we would start the game. We can do that with yet another state we're managing, which initially holds nothing, has no value, is undefined initially, because that should be the selected number, and that should now also really be a number and not some text. So here we have the selected number and a function to set it, and when the user clicked confirm before I reset my entered value, though this here will all be batched together anyway, so we can also use the entered value here after setting it to an empty string, because this will only be done in the next render cycle and not immediately after this line is executed. So we can still safely execute or access this entered value thereafter if we want to, because here I want to set my entered value with parse int by parsing the entered value. So I set this to be my selected number, and again I can still access entered value here even though we reset it, because this reset thing here will basically be queued by React and will only be processed the next time the component is rendered thereafter. And these 3 state changes are all batched together to result in one render cycle. So we can safely access entered value here, but we can also simply do it before we reset it. It does not matter. The important thing is, however, that we parse this as an integer so that we convert this text to a number here. And actually, I'll add yet another extra step before I do that. Right at the beginning, I'll have my chosen number here, which is the parsed number. And before I do anything, I want to check if chosen number is not a number, which is a default JavaScript value. So if it's somehow still not a number, even though we're trying to check for invalid characters, or if chosen number is smaller or equal to 0. If it is, then I just want to return. I don't want to continue. So return will finish the function execution and will not confirm, will not use this as a value because the value is invalid. Only positive numbers are allowed and no invalid numbers are allowed. In addition, I also want to add one extra check and check if the chosen number maybe is greater than 99, because that would also not be allowed. I want to have a number between 1 and 99, and it should be a number. If it's not fitting that criteria, then we'll return. Now, otherwise, we'll set this chosen number as the selected number and then reset the input. And then these 3 set state calls will be batched together and the component will re-render and we'll have our new state that has this number taken into account as the selected number. So now we can connect the confirm input handler to the confirm button here. And now some visual feedback would also be nice to see that confirming worked, or to also get an error if we violated one of these rules here, so that we don't just return but also show an alert. Now let's maybe start with the feedback before we then work on the alert. For the feedback, here below this function, but inside of our functional component, I want to check if we have confirmed and then set some special content that should be output. So here we have the confirmed output, which normally is just undefined. But if we have confirmed, then confirmed output is some JSX code where we kind of summarize what the user entered and give the user the start game button. Now, just to see whether it works, let's go with some text here and just say chosen number and output the selected number here. Selected number, this is our state we're managing here. So since we call set confirmed and so on, the component will re-render when this is chosen. So this whole component function will execute again. And that means that confirmed will then be true for this next run because we set it to true here. And therefore we'll set confirmed output to be that text. And now we can add the confirmed output, let's say, here below our card. So there I want to output the confirmed output, and that's either undefined, not printing anything to the screen, or it's this text. With that saved, if we go back and I enter a number and confirm it, here we see the number. If I enter something invalid like 0, we don't see it. So our check seems to work. And a valid number is output though. Now that's not the final design I want to have, but that proves that it works. Before we finalize this design, let's make sure that we also show an alert if something invalid is entered. Now, to show such an alert, React Native has got us covered. From React Native, we can import alert, and that's also not a component we use, but instead an object where we can call a native API, where we can call a native feature. So here, where we return if one of these conditions is met and therefore we're not having a valid number, there we can call alert.alert and now throw an alert, which you can configure as described here. You can set a title, you can add a message, and you can also add buttons and some general options. Now the title could be invalid number. The message string could be number has to be a number between 1 and 99. Buttons then is an array of alert buttons. What you add here are simply JavaScript objects where each object can have a certain style, a text, and a press, so a click handler basically. And I will add a text here where I simply say OK, where I then define a style, and style here is one of 3 text values. It's not a style you define with a style sheet. Instead, it's one of these 3 predefined style identifiers. It's either a cancel style, default, or destructive. This changes the color and presentation here, and I'll give this destructive as a style. And I'll also add my own press handler where I point at the reset input handler, because I want to reset the user input if it was invalid anyways. With that, the alert is configured, and this alert will now be shown if the input is invalid here. Let's give it a try and save this. And if I click confirm here, I actually get not a number. We'll have to fix that. But if I enter 0 here, now I get this alert with the OK button. And if I click it, this is reset and we're good. But let's make sure that we also get this if we have not a number, if chosen number is not a number. And the reason for that is that this check won't work in JavaScript. Instead, you have a special isNaN function, which you wrap your value around. And now this will check for you if this is not a number. And if that returns true, we make it into this if block, and therefore we'll throw this alert. So now submitting an empty value also is invalid. So that's important. Use is not a number instead of that equality check. So now we're checking for this. Valid values are still allowed. And with that, let's work on this confirmation presentation so that we can soon also enter the next stage and start a game. It's of course up to you how you want to style this confirm text here, or actually it should not just be text, it should be a view with the text in there, which outputs our number, and then a button to start the game. And you can definitely pause the video at this point and come up with your own styling there, your own layout. I have a certain layout in mind, which certainly will differ from yours, but there is no wrong or right decision here. So definitely take this as another chance to come up with your own layout for this, and a button that right now doesn't do anything, but that is there, which would allow the user to start the game. And after a short pause, which you can use to pause the video, I'll implement my solution together with you. So here's how I think that this would look nice. I want to have a view so that I can set up a general container around that. Or actually, maybe not a view, but why don't we use our card here? That sounds like a good idea. Now, that card, if we have a look at it, doesn't have a margin, and I want to have some spacing between that card at the top and my summary card. So therefore here, I'll give this a separate style. Here in my style sheet, in the start game screen, I'll name this summary container. Name, as always, is up to you. And I want to have a margin to the top of, let's say, 20. Some nice spacing here. And add this via the style prop to the card here. And in there, I want to say you selected, and then in a new line, output the number in a nicely presented way. Maybe the number in kind of a box with a separate border with rounded corners so that it's clearly visible, also bigger than the other text. And therefore here I'll add a view with a text in there. And in that text I'll have the selected number. But now that view and the text should get a special styling. And since I plan on reusing that, I'll actually grab it and outsource it into a new component. And I'll name it number container. In this component, I'll import React from React and import view and text from React Native. And then have the number container component here. Export default number container. And of course, we'll also need a style sheet here. So let's set up a style sheet as well with style sheet create down there. And then in this component, I'll return this view thing here with the selected number, which now, however, has to be passed in, and I expect it to get it between the opening and closing tags of my own component with the help of props children. Now, this container, of course, is something you can freely configure. I'll add just a container style container name here. where I think a border width of 2 might look good. So a little bit of a broader, wider border. A border color where I actually want to use my primary color or my accent color. We'll see which one looks better. So let's import colors from constants colors. And for the border color, then use colors accent for now and see how that looks like. Some padding so that the number is not directly on the edges of that surrounding box, doesn't sit directly next to the border. A border radius of 10 to have some rounded borders, some rounded corners, excuse me. By the way, if you would want to target individual corners, you could do so with border top left radius, top right radius. Top end and top start also takes the user's settings regarding if it's a left to right or right to left language into account. So you can target all single corners as well, or set a radius for all corners with border radius. And also add a little margin here, margin vertical of 10 maybe, to have some spacing to the top and bottom around of this container here. And also important, centered text in there with a line item center and justify content center, taking advantage of that flexbox behavior. And with that, I also want to give the number itself, so the text, a certain style. And that style is that I give the color also, the text also that accent color. And I want to use a font size of 22 to have that really stand out. And later we'll also use a custom font. And then this view here gets the container style, and the text here, of course, receives the number style. With that set up, we can use the number container in the start game screen. So there we simply add that import. And what we're doing here is pretty normal, that you have multiple components of which you compose your application. So now we can use the number container in the start game screen component, add it here below this text, and in the number container we get the content here with props children. We output it with props children. That means we have to pass it between the opening and closing tags. So here we forward the selected number. Now that's just my suggestion for how we could style this, but I like this style. And then for the moment I'll add a button here, which is a self-closing tag, though the built-in button, with a title of Start Game, all caps to make it really stand out, and save this. And now if we choose a number here, this is what we get. And it doesn't look too ugly, I'd say. Still, there are two things which I want to change. This text here should be centered, and this box with the number should not be as wide as the surrounding box, but be only as wide as the number needs it to be. Now, to make both work, I'll go to my card, which holds all the content here. And with that, I mean I go to the style in the start game screen, which I also use on that card. That's my summary container. And there we can align the items in there to be centered instead of using the default, which would be stretch. And now this is automatically centered and the box is only as wide as the number requires it to be. Now that doesn't look too shabby. One last thing which I just noticed is also that when we confirm an input, I also want to use the keyboard API to dismiss the keyboard, so that as soon as we press confirm here, we also close the keyboard. And now we have a nice output here. Now with that, we have a solid base look, I'd say. We can pick a number. We're doing some rough validation to make sure that we have a valid number. And the next step is that we make this start game button work, and we swap what we see on the screen here for our the game is running screen, where the computer is now making guesses, and we then make sure we give the user a chance of telling if the number should be greater or lower, and we then at some point are finished and show a game over screen. So we spent loads of time on this first screen, but obviously for a good reason. This course is about learning React Native after all, and you'll learn a lot about layouting, styling, connecting components, using multiple components, and configuring built-in components already. And that is a core part of React Native and what allows you to build real apps in the end. Nonetheless, it's now time to continue working on this app, and before we dive deeper into other things we could style, which I'll do later, I want to make sure that this start game button works. Because right now we're always stuck on this start game screen, but now I'll add a second component to the screens folder, the game screen itself. So the screen, the content I want to show on the screen when the game is running. And that is the screen that is responsible for showing the guess of the computer and allowing the user to tell the computer whether that's right or wrong, if the value should be lower or greater. So that's the goal here. Now, as mentioned before, it's a regular component nonetheless, so we need to import React for sure, and we'll also import some stuff from React Native. Most importantly, of course, the view and the text. You can never go wrong with these. Also the style sheet, of course, you typically always need these. Then here we can add our game screen functional component, create the styles object here by using style sheet create like that, and in the end export our game screen here as the default. And get rid of that plus here at the top. So now we have that game screen component defined here. And now let's briefly pause and think about what needs to happen here. Now, in the end, what needs to happen is that the computer needs to make a guess, and it needs to make a guess initially when this screen first loads, but then also whenever the user basically presses the "this is too low" or "this is too high" button. So whenever the user gives a hint regarding whether that guess is, in which direction of the real number this guess is, so to say. Whenever that happens, we want to generate a new guess. Now, the guess itself should be a random number, and therefore I'll start by creating a new function outside of my functional component now, because it will not use any data from in there, so it shouldn't be recreated on every re-rendering of the component, simply to save some performance. If you don't rely on props or state, you can also simply have a function that resides outside of your component. And I'll name this generate random between, because that's what this function will do. It's a function that will generate a random number between a minimum and a maximum, and which also allows us to exclude certain numbers. For example, the first number we generate should exclude dissolution, so that the device, the app, can never guess the user's choice on the first try. Now in here, minimum will be normalized to math ceil minimum. So to basically have an integer number here if a non-integer is entered, and rounded up. And max will be floored to do the same but rounded down. Then I'll have my random number, which I generate with math random. And math random gives us a random number between 0 and 1. So to have a number between min and max, we have to multiply this with max minus min. And then also, in the end, add min here, but also make sure that you call math floor on the result of this entire operation here. And this will give you a random number between this minimum and maximum. Now with that generated, I want to check if the random number is equal to the number we want to exclude, which would of course be a very rare coincidence, but it can happen. In which case, I will return the result of another generate random between call, where I simply forward min, max, and exclude, which we got. So I will simply repeat generate random between and return the value of that repeated run. If we dare get the excluded value again, we'll repeat it one more time, so ultimately we'll get there. And if we don't have the excluded number, which should be the case in most cases, then I'll just return that random number right away. So this is now a function which generates us a random number. Now here in the game screen, I want to manage some state, so I'll import the use state hook from React and initialize some state here with a random number, because the state I want to manage here is the guess of the computer, the current guess, and that also needs a set current guess function so that we can change this whenever the user gives a new hint. So here we can call generate random between to generate an initial state which will be saved. And this will then only be considered as an initial state. So when this component rebuilds and therefore use state is called again, we'll generate another random number again, but this will then not overwrite that state, because once the state is set initially, it will not be overwritten again by the value derived here. This will only be considered by React if we have no initial state yet. Thereafter, this initial or updated state will be managed detached from the component and will not be overwritten again by this call here. Initially, however, we need to make this call. We want to get a random number between 1 and 100. 100 is excluded with the logic we wrote up there, so it will be a number between 1 and 99, 99 included. And I want to exclude the choice of the user. I expect to get this on my props here. So user choice could be a prop name we use here, and that's the value I want to exclude, because that's the solution in the end. And we won't be able to guess the solution right away. That would be a bit unfair. Now, before we add more logic, let's work on the user interface, so on what we output. So here I'll return a view in the end, and in that view I want to have a text where I say opponents guess, so what the computer guessed, and then we can reuse that number container to nicely present that guessed number. So that's a huge advantage of having such reusable components, because, well, you can reuse them, I guess. So that's what we're doing here. We'll use that number container again below that opponent's guess text here to have our own number container and nicely output the current guess here. Current guess is our state. Remember, that's what we initialize here and what we'll soon be able to change as well. So that's what's getting output here. Below that, we can now also present maybe our card with 2 buttons that allow the user to give the computer a hint. So here I'll import card from components card to wrap these buttons in there, and therefore we can already also import button from React Native, because we'll need that in a second too. And then simply have our card here, and in that card I want to have a button with a title of lower and another button where we say greater. These are the 2 directions in which we can give a hint. So is the number you guessed too low? Is it too high? Then we can give the computer a hint with these buttons. And on press, I'll at the moment just register an empty function that doesn't do anything. That will of course soon change and will effectively generate a new random number. And with that, it's now time to add some styles here. I want to have a style for my overall screen, and as before, this will get flex 1 to take all the available space on the screen below the header which we have at the top. Add a padding of 10 to have some space around the content so that it doesn't sit directly on the edges, and also use align items here to center our content horizontally. And that screen property is used on the surrounding view here to add styles screen there so that the content on this overall screen is nicely positioned. Now for these buttons, it would be nice if they would be sitting next to each other. So on the card, we can add a style, maybe use button container as a name here, and therefore add that same name here in our style sheet, because that's what we're referring to, and set the flex direction here to row. And we can set a flex direction here because I'm doing this on my card, but if we have a look in that card, we distribute these styles on a view, and a view uses flexbox, so we can set a flex direction here, and that's what I'm doing there. Setting flex direction to row to position items next to each other horizontally. Justify content with space around, maybe to have the free space around the buttons on the left and right equally distributed. And also add a margin top of 20 so that this card with our buttons isn't sitting directly next to the guessed number, but there is some spacing in between. And also maybe give this a width of 300 and a max width of 80% to make sure that this can never exceed the boundaries of the parent view. Now, if we save this, it would be nice to see that, and for that we need a way of going to the game screen. Now we're using the start game screen in the app component, so we'll have to use the game screen there as well and manage the selected number in that app component, because that's the only component which is on the screen all the time. Well, besides the header, but the app component is also the component which will hold the start game screen and the game screen soon. Therefore, it is the component where we can also pass data down to the start game screen and to the game screen. So let's import the game screen here from screens game screen. And of course, I want to render my game screen here, but not if the start game screen is still visible. I want to have either of the two. And side note, there also is a totally different way of loading different components, and we'll dive into that in a separate module in the navigations module. Now, whilst we'll cover different navigation solutions later, there is a way of rendering either of the two screens right now. We also have a way of only rendering one of these two screens right now already. And for that, we need no special tool or anything like that. We can use normal React logic. We can render this content conditionally. All we need to do for that is we need to manage some state in our app component. We need to manage the selected number in here as well. So I'll add use state here, and then simply use my state here and initialize this with no value in the end. And there I want to get the selected number or the user number and have set user number as an updating function here. And initially that's undefined. And now here I need a function where we can change this, like start game handler. That sounds like a fitting name because we'll have such a number if the user presses the start game button here in the start game screen. So the start game handler will then get the selected number as an input. That's an assumption we have to make here, and set the user number to be that selected number here. Now, whenever that is the case, whenever we have a user number, we know that the game is running and we know that we can render the game screen instead of the start game screen. So here we can use a content variable, for example, and say our default content is start game screen. And that is normal React code, as you know it from React for Web 2. You can store components like this in variables and then simply output the variable down there. It's also what we already do in the start game screen with the confirmed output. So start game screen is our default output, but now we can add an if check and check if content is true-ish. That's what this check checks. So it will be false-ish initially if it's undefined. But now, if it is true, we can set content here. Excuse me, not content, the user number. So I check if user number is true-ish. If that is true-ish, then we know a number was selected. It will be undefined and therefore false initially. But if it is true-ish, if a number was chosen, then we'll set the content here to be the game screen. And then we render whatever is in content down there. And that will be either the game screen or the start game screen. So now when we click start game here with a number chosen, this should switch here if, and that's the important thing, if we make sure that the start game handler can be triggered from inside the start game screen. Now for that we use a default React pattern of passing down a reference to this handler to that component. Maybe on the onStartGame prop, that sounds like a fitting name to me. We forward the start game handler, just a reference without parentheses here, just a reference, a pointer at this function. And onStartGame is now a property we can use in the start game screen. So here in the start game screen, when we click on the start game button here, I want to trigger that prop in the end. So here I have onPress, and there in the end I want to execute onStartGame and forward the currently selected number here, which is managed in the state of start game screen. So here I forward this to onStartGame, and onStartGame is bound to the start game handler, which expects and then receives that selected number. So that is how we make sure that clicking that button in the start game screen triggers this method or this function here. And when this function is triggered, we set a user number. This makes sure that content is the game screen, and therefore we should be seeing the game screen. Now, missing piece is that in the game screen, I need the user choice to generate my initial random number and exclude that user's choice correctly for that first random number. And therefore, we need to pass a property named user choice down to the game screen. So we can add the user choice prop here and pass user number which is the state we're managing in the app component, which is that selected number we're storing in the state here, pass that down to the game screen. So I hope that flow of data is clear. We get that selected number from the start game screen when that button, the start game button, is pressed. We then store it in the state of the app component here in the use number state with the help of set user number. And we then use that user number to pass it down to the game screen, which is only rendered if we have a user number, so if the game is running, if the game was started, so that in the game screen, we can use the user number, which is received on the user choice prop, to then generate a new random number, which the computer guessed where this user choice, this user number, is excluded, so that for the very first computer guess, the computer can't instantly guess the user's number. A lot of talking. Let's save all of that and have a look at it. Let's enter 55 and confirm and click Start Game. And we can't find a variable on Start Game. So the problem here is that I execute, that should be props on Start Game here, on the Start Game button in the Start Game component. Because of course that's a property we're getting. It's not a function defined in here, it's defined on the props. It's this prop in the end. So, small mistake, let's try it again. After fixing this, click Start Game, and that's looking good. Now we see the opponent's guess. We can give some hints here, which right now have no effect, but which soon will have an effect. And therefore we're on the next screen, we're in the game screen. Now let's make sure we actually can give the computer some hints here, and make sure that the computer has a chance of solving this and of guessing our number. So we can reach that game screen now, and the computer is guessing a number here, a random number which excludes our real number for the first initial guess. Now we need to make sure that subsequent guesses can be made when we press the lower or greater button here in the game screen. For that, let's add a function inside of our functional component, because this function will need access to the surrounding state and the surrounding component. And give it any name you want, like next guess handler, whatever name you prefer. And this is a function which actually should get an argument, the direction in which the next guess should be, so lower or greater. Now, the first thing I want to do here is I want to make sure that we validate the direction. Now, this function here should be executed when the buttons down there are pressed, but of course the direction value, so the value we pass in as an argument, should differ based on the button. So here we have the next guess handler connected to onPress without parentheses to just provide that pointer at our function to onPress, so that this will execute eventually when the user presses this, but I want to pre-configure the argument which will be passed to next guess handler when this is executed. We can do this with bind this, because the first argument to bind is always what this should be referring to in the function that's getting called. Doesn't matter here, so we can just bind it to this. The second value we pass here to bind will be the first argument received by our function though, therefore this will be the direction received here. And it's of course up to you which logic you use here. To me it makes sense to simply use a string, where here we pass lower as a string, and for the other button we pass greater, so that we have these two identifiers which are essentially passed to the next guess handler. So direction will be lower or greater. And now we want to validate whether that is correct. So for example, if you selected a number of, let's say 55, and the computer guessed 60, then if you give the computer the hint of the number should be greater, that's obviously wrong, because the number should be smaller. Your number was 55, guess was 60. It's incorrect if you tell the computer that the number it should guess next should be greater than 60, right? So we want to validate this. Therefore, here we can check if direction is equal to lower. So if you pressed the it's lower button, and the current guess, however, is smaller than props user choice, so the computer actually guessed a number that is smaller than our choice, then lower is the wrong hint, right? Because the number doesn't need to be lower. it needs to be greater because the guess already was too low. So that's one possible scenario where we're getting a wrong hint. The alternative, and I'll wrap this into parentheses to make it really clear that this is one condition here. So the alternative to that, the second condition we want to check, is that the direction here is actually greater, and at the same time the current guess already is greater than our choice. And then it's also an incorrect hint, just in the opposite direction. In both cases where we're giving an incorrect hint, I want to throw an alert, and you learned that you can do this with the alert API, the alert class you can import from React Native in the end. Then in here, in our check, I will use alert to throw an alert with the title of, let's say, don't lie. Of course, you can pick any name you want. I'm escaping that single quote, which I want to print as a character here with a leading backslash, because otherwise it would close the string, because I'm using single quotes to surround my strings. So that's my title, and then the text could be, you know that this is wrong. But of course, you can have any text you want here. It can also be less moralistic if you want to. Now I want to present one button here, and buttons, as I already explained, are objects you pass to that third argument array, which alert takes. And there the text could be sorry, and the style could be cancel. And you don't need to provide an onPress handler. If you don't provide one, the only thing that will happen is that clicking the button will close the alert, which is fine. So here we're giving the user a tap on his fingers, so to say, making sure that no incorrect hints are given. And I want to return here, so I want to stop the function execution if we have such an incorrect value. If we make it past this if block, so if we gave a correct hint, then we want to generate a new random number. So here, I want to check if the direction is lower, and now we know that was correct, so the computer should guess a number that's lower than the previous number. Then we know that a new random number should be generated where the current guess is the maximum upper bound. So therefore, we can call generate random between again, and the minimum number, well, that is probably 1, but what if the user already guessed another number where we told the computer that it was too small? Then we would have a problem here, because the lowest boundary is not always 1. What if the user guessed 10 and we said, no, it has to be greater? Well, then the user guesses 50 and we say it should be lower than that. The computer should, of course, then guess again, but it should not guess below 10, because we already mentioned that this is too small earlier. So our current maximum and minimum should adjust over time as we give hints regarding whether the number the computer guessed is too small or too big. So therefore, we can use another hook provided by React, and that's the useRefHook. Now, you might know that hook as a hook that allows you to create an object which you can bind to inputs, so to your input elements in JSX, to get access to them in your code. And that's one way of using it, but useRef also allows you to do something else, which is pretty cool. It allows you to define a value which survives component re-renders, so which survives that this component is rebuilt. And that's exactly what we need here, because we want to lock in a minimum and a maximum, which we can change, but which isn't regenerated just because the component is rendered again. So here at the top of this component, after initializing the state, we can create a new constant, current low maybe, where useRef is 1, and then another constant, current high, where useRef is 100. These are our initial boundaries we're using for the random number. And now we can update these references in here. So we know the direction should be lower. What we can do in that case, instead of instantly generating a new number, we can set current high dot current, because references generated by React are objects that have a current property where the actual value is stored in. So we set current equal to current guess. So what we're saying is, if I'm telling you, the computer, that the number you guessed is too big and you should guess a lower one, then I know this number which I guessed is my current high. The number which is correct can't be higher than this one. So I save the number I just guessed as my current high. And again, these reference constants here are not regenerated when this component is created again. Instead, if they have been initialized once, a bit like the state actually, then they're stored detached from that component, and React recognizes that they have been initialized already, and it will not regenerate them, but instead initialize current high with the previously stored value. So it's a bit like if you were managing this in a state. The difference to the state is that if you change the value stored in there, the component doesn't re-render, because we don't want that here. I don't want to re-render the component just because I'm saving a new high. That has no impact on my view, on my JSX code, it just has an impact on my logic. But for that, I don't need to re-render the component. That's why I use a reference here instead of a state. So that's happening if it's lower, else, so if we told the computer that the guess was too small and the actual number should be higher, should be greater, well, in that case, we set the current low to the current guess, because then we know we have a lower boundary. And now the goal is, or the trick is, to generate a new random number which takes these boundaries into account. So where we use the current low with our ref and then dot current as a minimum, and current high dot current as a maximum, and I want to exclude the current guess so that we can't guess the same number again here. So that for the next roll, we'll definitely guess a different number. So that's then something I store in a constant next number. This is generated here when the next guess handler is executed, which happens when we tap one of these buttons. And now next number is the next number we want to use. So now what we can simply do is we can call set current guess and add next number. Now the component will be re-rendered and it will output the next guess. So let's give that a try. For now we have no the game is over condition, but at least we can try guessing numbers here. So I entered 53 as my number. Now we start and the computer guessed 85. If I now say greater, we get that warning because we lied. We had 53 as a number, so the guess is too high, it should be lower. Now it's 28, well, that's too low, it should be greater. So if I tap lower, I get the warning. If I tap greater, we go up. Now 78. And now, at this moment, 23, the previous guess, will be our lower boundary. And now when I tap lower, 78, the current guess, will be our upper boundary. So the next guess will certainly not be above 78 and not be below 23. Now that's big, still too low. That's too big, I mean, that's too low. So let's use a greater one, lower one, and that would be the correct one. Now, for now, we have nothing that checks whether the computer guessed correctly, so that's the next thing we'll have to implement here. So to make sure that the computer can actually finish that game and guess the right number, we need to check what the computer guessed and then kind of end the game if it's the number we entered. For that, we can use another React hook, and that's the useEffect hook. useEffect allows you to run side effects, or in general, allows you to run logic after every render cycle. And just as mentioned before, if this whole React hooks thing is relatively new for you, definitely check out some dedicated React hooks resources or dive into my React Complete Guide course where I cover hooks in detail. So what I'll do with useEffect now is I'll call it here after initializing my state and my refs here, and in there, we pass a function, so useEffect takes a function, and this function by default runs after every render cycle for this component. So every time it has been rendered, this function is executed after it has been rendered. That's also important. Not before, not simultaneously, after. Now in there, I want to check if the current guess the computer made is equal to the user choice, because that means the game is over. Now, that can't be the case for the first render cycle, of course, because we exclude the user choice from the guessable numbers, but from the second roll on, so once we clicked lower or greater for the first time, that can happen. So in there, I then want to kind of fire a the game is over message and send that to app.js so that we can swap the game screen for a game over screen. Now, we don't have that screen yet, so let's add it. Let's add a game over screen here in the screens folder. And let's create a very simple one for now. We'll fine tune it later. In there, I'll simply have a view and a text and a style sheet. So what we typically import from React Native. Then have the game over screen component in there, which takes some props and then returns some JSX in the end. Here we have the styles with style sheet create, and then we export the game over screen as a default. Now in there, as I said, I want to keep this simple for now. I'll just have a view in there with a text of the game is over, and we'll output more details there later. For now, here I'll just assign some style, my screen style, which I'll add to this object we pass to the style sheet here at the bottom, set flex to 1, and maybe justify content to center, and then align items to center so that this text is centered for the moment. Now we have the game over screen, and we want to render this instead of the game screen, well, if the game is over. So let's go back to the app.js file and import the game over screen from the screens folder and there from game over screen. And the question now, of course, is what's our condition for rendering this? Well, in the end, we'll need one additional piece of information anyways, and that's the number of rounds it took the computer to finish the game. So one thing I want to store here in the app component is another state I manage, and that is the number of rounds it took the computer to finish, which is 0 initially because we haven't started a game yet. And I'll name this guess rounds and set guess rounds, and you can name this whatever you want. Now the goal is to set this when the game is over. So for that, I'll also add another function here to the app component, game over handler, and there I want to get my number of rounds as an argument, so I expect to get this here so that I can call set guess rounds to my number of rounds I got here. Now the game over handler should be triggered from inside the game screen, obviously. So here on the game screen, I want to pass in a prop which I'll name on game over, sounds like a fitting name, which can be called from inside the game screen then, or which holds a function reference which can then be called from inside the game screen. And the function reference is a reference at this game over handler function, of course. So inside of game screen, we can now use the on game over prop to execute this function and pass the number of rounds it took the computer to guess our number. Then we set this number of rounds here, store it in our guess rounds state. And now in the app component, we know that if guess rounds is 0, the game hasn't started yet or it's running. If it's greater than 0, then the game over handler executed and the game is over. So we want to show the game over screen if guess rounds is greater than 0. By the way, if we start a new game, I also want to reset my guess rounds to 0, because if a new game starts, we want to reset the number of rounds the computer took to 0. So if it's greater than 0, the game is over. So in that case, I want to show the game over screen. So here, if I check if we have a user number, in which case I show the game screen, that's only correct if guess rounds is smaller or equal than 0. Smaller is not really possible, but still we can check for that. So if that's the case, then we know the game is certainly running. Else if guess rounds is greater than 0, then we know the game is over, and therefore content will be equal to game over screen. Right now, that's just a component like this without any props which we pass in. So now we have a condition where we render the game over screen. All we now need to do, we need to use the on game over prop here in our game screen to in the end call this function and forward the number of rounds to the app component. So back in the game screen, if useEffect here determines that the right choice was made, the right guess was made, and therefore the game is over, then in here, I want to call props on game over as a function and forward the amount of rounds it took the computer to guess our result or our choice. And that's therefore another state we have to manage here in the game screen. We have our rounds and set rounds, and initially that is 0. When this component is created for the first time, this is of course 0. And rounds is therefore now what I forward here, because that's a number we'll increment with every guess. Because in the next guess handler, if we're generating a next guess, besides setting that guess here in our state, I of course also want to set my rounds, and there use the function form where I get my current rounds, and I return current rounds plus 1. So I add 1 to my current amount of rounds I store in my state, so that the new state, well, is old rounds plus 1 because a new round started. So with that, we're managing the amount of rounds, and we're using this as a condition in the app component to render the game over screen. And in the game screen, we check whether the game is over here in useEffect. And right now we do this whenever this component re-renders. Now, we could do that, but we can also simply be more honest or more direct regarding the dependencies of this effect. And that's something you can be, or you can do, by adding a second argument to useEffect. First argument is the function it should execute after rendering the component. Second argument you pass to useEffect is an array of dependencies of this function. And here you have to specify any value that's coming from outside of this effect function. So in our case, that would be the current guess. That would be props user choice and props on game over. And whenever such a value changes, this effect will rerun. So whenever it has changed after a render cycle, the effect will rerun, I should say. If a render cycle occurred and the values you specified here are still the same as for the previous render cycle, then the effect will not rerun. So the effect will now only rerun if one of our dependencies changed. Now, as I said, props user choice and props on game over are also dependencies. And to take care of these, I'll use a modern JavaScript syntax where I use object destructuring to destructure my props and get user choice and on game over out of them. This syntax might look strange, but it's like array destructuring just for objects. We're pulling these properties, so these property names, out of this props object and store them in constants with equal names, so that here we can now just use user choice and just use on game over, since we have these values now stored in constants of that name, pulled out of props. And I'm doing this because now we can add user choice and on game over as dependencies in this list. Otherwise, we would have to add props here, and that actually changes whenever the parent component changes. Therefore, it's not a good check. This is a better check because now we make sure if anything else in props changes, we don't care. Only if one of these two values changes, then this effect should rerun. Now with that, we have our check in place that should hopefully lead to the game over screen being presented if the computer guessed our number. So now let's save this and let's give it a try. Maybe here on Android to mix things up. So I'll enter a number here, 32, confirm, start a game, and it's 2, so it should be greater. Let me also show you how the warning looks like on Android. It's this default Android alert. So 32 it was, so therefore, of course, should be greater, should still be greater. Now it should be lower, should be lower, should be greater, should be lower, should be lower, should be greater, should be greater. The game is over. That's looking good. The guess probably was 32, would make sense regarding the sequence of numbers we had here. And therefore, this output makes sense here. So we're able to detect that the game is over. Now it would be nice to also output a summary on the game over screen. Now we can dive deeper into the styling and the detail output there later. For now, let's just make sure that we maybe at least output the number of rounds it took the computer to win, or what means to win, to guess our number. So number of rounds is something I want to output here on the game over screen. And that's of course a value we need to get from our props because we're managing this number of rounds in the app component in the end, here in guess rounds. So in the game over screen, we get this on props, rounds, number, or whatever you want to name this. It's up to you how you name this prop. And maybe also output the number the computer had to guess. Number was, and then props user number, maybe. So these are two props we now need to set on the game over screen, rounds number and user number. So back in the app component, on the game over screen, we set rounds number and user number. User number, of course, should be our user number we have there. User number between the curly braces now refers to our user number state here. User number before the equal sign simply refers to the prop we're passing to game over screen. And rounds number, of course, is guess rounds. So that's the number of rounds it took the computer to guess this. So this is now forwarded to the game over screen and can be output there. On the game over screen, I also want to have a button that allows the user to restart the game. So let's add a button here. And for that, you need to import the button from React Native. So let's add a button here. And the title of this button could be New Game. And on a press, I, want to start a new game. Now, again, the app component is where we in the end control whether the game is running or not, where we present the different game screens. So it's here where we need to change something if a new game should start. And it would make sense that in the app component, we therefore have a new function. Can be defined anywhere. I'll define it here as a first function because it's the function that allows us to configure a new game. So maybe configure new game handler. You can name it whatever you want. And there I expect no arguments, but I want to set my guess rounds to 0. Therefore, actually, we don't need to do this here when we start a new game because we're definitely doing it right before we configure a new game even. So we can set the guess rounds to 0 here. And by doing that, we already ensure that in our if check down there, this condition will not be met anymore. Because if we set guess rounds to 0, it's certainly not greater than 0 anymore. So we'll certainly leave the game over screen. And then, however, we would display the game screen again. So to see the start game screen again, which we want to see because that's the screen that allows us to configure and start a new game, we have to make sure that we also reset the user number, so the selected number. So here we can also set user number to null to reset this to a false-ish value. And now configure new game handler resets everything that we checked down there, hence we should see the start game screen. Now we just need to pass a pointer at configure new game handler down to the game over screen. So there I'll add a prop on restart maybe, and that points at configure new game handler. So now we can use the on restart prop inside of the game over screen by binding it to this button. There, upon a press, I want to execute on restart, as a function without parentheses here, because here I just pointed it so that on press registers this pointer, and when this button is pressed, this function will execute. Let's give all of that a try. Let's enter a number, 41 maybe, and start a game. And lower, that was fast, but that's okay. 2 rounds, the number was 41, that's correct, and if I click new game, we're back here. Let's give it a try, 66. Greater, greater, lower, 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 even lower, greater, lower. Whoa, that's taking long. Lower, greater, greater, lower, lower, greater, yeah. 14 rounds, so it can also take longer, but the main thing is our logic here works, and that's actually already the finished logic of the entire game. Now, what's not finished, however, is the overall styling. I want to have a different button here, want to have different buttons here, want to use my own font, want to use some icons, and I also want to make sure that we show a little image on the screen where the game is over. So here I also want to have a little image. So these are all the things we'll tackle next. Lots of styling and image adding to be done.